Hello and welcome to this Python for Data Science full course by Intellipaat. If you're planning to build a career in data science, machine learning, artificial intelligence, or analytics, there's one skill that you'll come across again and again, and that is Python. Today, Python has become the most widely used programming language in the world of data. From analyzing customer behavior and forecasting sales to building recommendation systems and training AI models, Python powers some of the most exciting technologies around us. But to become a data scientist, you need a practical understanding of data and how to uncover insights and solve real world business problems. That's exactly what you will learn in this course. We'll start right from the basics, so even if you've never written a single line of code before, you'll be able to follow along comfortably. Once you have a strong foundation, we'll move on to the tools that make Python so powerful for data science. You'll learn how to work with NumPy for numerical computing, Pandas for data manipulation and analysis, and explore how data scientists handle, clean, transform, and analyze large datasets efficiently. Throughout the course, you'll gain hands-on experience by working with real examples and practical exercises, helping you understand not just the theory, but also how Python is actually used in the industry. So without wasting any time, let's get started.
Python is a programming language that was first introduced in the late 1980s and has since become one of the most popular programming languages in the world. In 2023, Python continues to be a powerful and versatile language used by developers and businesses alike. So what makes Python so special? One of the biggest advantages of Python is its simplicity. The language has a straightforward syntax that makes it easy for beginners to pick up and start coding. At the same time, Python is also a very powerful language with a wide range of libraries and modules that allow for complex tasks to be completed with ease. Another key reason for Python's popularity is the versatility. Python can be used for a wide range of applications, from web development to data analysis to artificial intelligence and machine learning. This versatility makes it a great choice for businesses as they can use Python to automate a variety of tasks and processes. So why use Python in 2023? There are several reasons. Firstly, Python is constantly evolving language with a growing community of developers and users. This means that there are always new tools, libraries, and modules being developed that make it even more powerful. Secondly, Python has a large and growing number of job opportunities available in the market, making it a great choice for anyone looking to enter the tech industry. And finally, how can you get started with Python in 2023? The best way to learn Python is by doing it. So start by downloading the language and working through some simple tutorials and exercises. As you become more comfortable with the language, you can start working on more complex projects and developing your own applications. In conclusion, Python in 2023 continues to be popular, versatile, and powerful programming language that is well worth considering for anyone looking to get into the tech industry or simply improve their coding skills. Whether you are a college student, a professional, or just someone interested in coding, Python has something to offer to you. So why not give it a try today and see what you can create.
Just a quick info guys, Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
We are going to get into a little more, more into the basics of Python, right? So I would start with a bit of, so why do we need Python? In what places you can use Python, right? Then second thing would be like more on starting with the Python variable to get you an understanding of that. How does the variable assignment work? Then I'll get into multiple variable assignment, names, global variable. Then we'll come to the data types, right? So that will be going to the flow for the day. Okay. So I think if I recall correctly, I had started with a quick discussion on that. What is Python and how it is different from other languages like C or Java, and I think I talked about few pointers on which I was trying to explain that why Python is better and why Python is not good, right? So there are pros and cons, right? Pros and cons. So Python has its own advantages, but with also some disadvantages. Okay. So any question from that angle, compiler versus interpreter. I think I did not make any note here, so let me quickly complete that part. I think we were just discussing it. See, so let's say we compare, you know, compiler versus interpreter. Generally, if someone starts with the history of Python, okay, so you have to keep it, very simple, very much to the point. You don't need to get into too much of the detail. So compiler-based language, it translates, and that will be a quick revision as well. It translates the entire source code into what language, guys? Come on, I had discussed that, right? Into the machine level language and in a single run. And that's what compilation means, right? You will run it, and that will be one single run, and then it will convert everything into a machine level language in a single run, and then you will understand, what went wrong, what went correct. On contrary, interpreter, it translates the entire source code. Even if you write the whole Python code, it also does that translation, but line by line. Second point could be on the time consuming, right? So it consumes less time. And this is on the computation side, not on the debugging side. So please be uh, clear here. It consumes less time and hence it is faster than Python or any interpreter-based language. And you have to read this. I'll make a comment here. You have to read this with respect to computation, not like debugging. Debugging definitely takes a lot of time. Python debugging is simple. I'll make a point there as well. It takes more time, consumes, I'll just write one line, consumes much more time than the compiler based language. I think this is not required. Okay. Then I would say it is memory efficient. And that's where when I teach you NumPy, you'll understand that all the compiler based language, they do a good job at, allocating the memory and when to, flush the memory to take the garbage out. On contrary, Python is not that memory efficient. So you can see all these pointers it seems to be like it is against the Python, but not. Python has some really beautiful feature which compiler-based language is not having. Like for example, debugging takes a lot of time here, takes more time. Here I can say debugging is takes less time. And you remember why debugging takes less time? Because it runs line by line. So if something comes as an error, you will know in the next line. Remember, that's the reason. And here debugging takes more time because every time you have to complete the compilation. Complete compilation happens, and then you can debug. Okay. Now let me give you some ideas about debugging. So let's say suppose, what do you mean by debugging? You have written a code and code goes into error. Means suppose I'm trying to read a file and do a summary, but somehow that summary is not working out. Some error is there, can be a value error, it can be a key error. There are different types of error. And for now, don't go into that. But debugging means that you are trying to understand the bugs in your code. So what do you mean by bugs? Means the issues in their code and you're trying to take it out, right? That's the whole process is known as debugging. So take the bugs and remove it. Now, why debugging takes more time, guys? Because complete compilation happens, and for that you need time, right? And then you can, definitely debug. But in Python, you run line by line, so you don't need to wait till the whole source code is translated. Compilation is done because it is an interpreter-based language. You can just run that line, and still you can understand what is the error and everything, right? So that's where the advantage is. Memory-wise, I think Python is not that great because it uses different memory allocation. And guys, again, that is out of the scope for the whole data science because you don't need to go into that. It's just a comparative analysis so that you have an idea. These are some key bullet points. Don't double click on the bullet points because to get into the whole memory efficient analysis, you have to understand the memory management in compiler based language versus interpreter based language. And that's not really we need to do that. Okay. in data science, don't really need to put much focus on this. But just to give you an idea, like array does the allocations of the data elements in contiguous memory allocation. So it means like it does a very smart allocation of the memory in simple English. Python does a more so array, when I say not the Python array, array is coming from C and C is a compiler-based language. But if you look at list or data frames, they're not very efficient in memory. The moment you load a big data, right? Like I'll give an example, like 20 GB file or 5 GB file, Excel file, which is a CSV format. It loads into directly into the memory, and the moment your RAM is low. So when I say RAM is your computer memory, right? Let's say you have a RAM of 16 GB, but you're trying to load a 15 GB or 14 GB data. Your code will not run. It will start showing out of memory error. But chances are very high that if you are managing this in C, still you will be able to turn around on it. Okay. Now comes the consumes less time and more time in terms of computation. So again, since it's efficient in terms of memory and it uses array, different data types, data structure, to be honest. So C does some of the computations. What do you mean computation? Suppose I want to multiply quantity into price. Let me take an example. You have a data, see this table. You have a data in which you are selling items, just like, item A, B, C, D. And this is going for like, 5 million records, quite a few, right? And you want to multiply quantity with price to understand your revenue. So obviously you say two units I have bought at 100 rupees, one unit at 50 rupees, and you want to do a multiplication, a simple computation, right? I'll show you when I'll teach you NumPy that computation done, this can be done in list also, right? This can be done in list data type also versus array. Here I'll prove with a real example that array is somewhere 10 to 15 times faster. Make a note of it, guys. So when I say array is faster, means this array is coming from which language? C. List is coming from which language, my dear? Python. So you understand the second point is all about computation. Is it if C is faster than Python, why we are not using C? Because C does not have very good library. It's also like that's where I should write one line that data science libraries are the best in Python. That's the reason that people still want to use Python. You don't have good libraries in C for doing Python. Not all libraries are made of C. Only NumPy is based on C. Pandas is not on C. Okay. So data science libraries are the best in Python. So if you take C and you try to get into the libraries, see, that's where you have to do comparative analysis. You have to sit and do it. So few things you have to take on the merit of statement. Okay. And you can, Sagar, I think you can stop writing in caps because caps means you're not writing, you're shouting. So if you're not aware, just let me make you aware of this. If you're writing in chat in caps means you're shouting, you're not asking a question. So if you're not shouting, please write in, uh, the normal, because caps actually, stands out. Okay. So now coming back to how elaborate, we can definitely be statement on the merit that data science library data science libraries are the best in Python. So let me give you the name. I would say I have not heard a lot of data science libraries from C. I need to do some bit of research because I have never heard that they are doing anything on that. You have scikit, you have scipy, you have NumPy, right? You have pandas for data manipulation. You also have Matplotlib, which we are talking about, right? All these are amazing, and all these we are going to study in this course. I think I'm going to teach definitely these ones, which I was trying to talk about, but sooner or later you will also be introduced to these topics. But if you look at the C, you will not see anything coming as a data science. You don't have a lot of functions or libraries which are famous, which have good community support, which are getting all the recent developments happening. And that's where data science is back. For them, data science is not the priority. Python data science is everything. Okay. So community support is also important. So now if I give you an idea that you have LLM models, you must have heard about ChatGPT. So ChatGPT works on LLM model, right? So large language models are the ones which are making a lot of waves in current time. But if you see that nobody's talking about that in C, because it's all done in being Python. But if you observe that and can tell me that okay, can we do in C? I'm not saying no. It's just that not convenient to do in C because you don't have a lot of community support, a lot of materials available for you to do research and do some developments, right? So Python is contributed as the top language, as you can see on this index as well, right? So there you have more support and a lot of new things are being covered. Every week, new things are coming. Okay, makes sense? So that's the reason that why I'm saying that why your data science, if you're looking at data science, you should look at Python. I think that has been taken care of. I think we have to definitely then the next question will be that can we elaborate on that? So see, both are data structures. Just to add to what Purva has mentioned, Prava. So both are data structures, and but they have different characteristics. To be honest, so if I talk about memory allocation, so arrays are stored in contiguous memory locations, right? So basically, the meaning of contiguous is that they will be stored or placed in adjacent cells, right? And that's where arrays are always indexed, right? They have the indexing 0, 1, 2, 3, and that makes them fast and efficient. But as compared to that, linked list is consisting of nodes, and and they're not stored in the contiguous memory location. So they're not like if I can go back to my OneNote, and so when I say indexing, if you have observed, list is also an index-based data structure. So 0, 1, 2, if I write, or if I put my name here, if I put my name Akash here, so here we are storing this into side by side. Can you see? That's what I mean by when I say indexing adjacent cells. It's very easy to, retrieve this data and, push it and retrieve. But compared to this linked list, they are storing in non-contiguous. So they're not being stored in the adjacent cells, and that's where it is a bit slow. So linked list data structure is a slower data structure as compared to array, and that's a well-known fact. Let's come back to the next topic. I think it will be variable, right? So what is a Python variable? Yeah, what is variable in Python? Let's see what you have learned in other languages, or I know also that you guys have done Python. So what is variable in Python? Container to store values, container to hold information. So the moment I write x equal to 10, how do you interpret it, guys? When I say x equal to 10, how do you interpret? It means that in the memory, you are putting 10. So first tell me, definitely you are going to say that here 10 is assigned to x. Are you going to say that? Perfect. Okay. So definitely 10 is assigned to x, and because of this operator, there's an operator involved, guys. And we are going to double click on this. This is known as what operator? Assignment operator. Okay. And then you also see that 10 is a what? In Python what, or in the Python lingo, it is known as object. X is not your object. Always remember that. 10 is your object, and you are giving, and this 10 is going to get stored in a memory, right? And that memory will have some ID. So it is going to be stored in a memory with ID. And let's say, I'll show you in the hands-on as well with ID. And ID is identity, or think like your identity. You have an Aadhaar card, right? Or you have a PAN card. Similarly, this 10 also has some information in terms of ID. That's going to be unique. And generally, it is something like this, like 16 digit, if I recall correctly. I have not written 16, but yeah, let's not get into that with that seriousness. But there is some ID which is unique to this object tag. Now then, what is x here? So x is known as object reference. So you're tagging this x, you're assigning a value 10 to the x, or you rather say that you are referencing this variable with sorry, you are referencing this object with a reference variable name object reference x. So when you are saying x, you are referring to object 10 with assignment of x. Or maybe let me keep it simple. You are referring to this object 10 with a reference, which is you are calling x, which is your variable. Okay, it's more like a tagging. Okay. And what is the interpretation of tagging? Tagging means like assigning a value 10 to the variable x. when you get into hands-on and if you write what is ID of X, and this ID is known as identity. The full form is identity. You can also get a machine level, hex code. So you have to do hex of ID, and that will give you a hexadecimal or hex code, we also say, for that particular ID. Okay. So suppose you are saying X equal to 10, Y equal to, now I'll move on to the another example. This is example one. I'll write EX1. If I move to another example and I write Y equal to APC. So that's my initial, guys, APC. Now tell me what is difference in these two. Please be interactive, guys. What is the difference between these two examples? The person who quickly observed that you are talking to different data type, right? So if I can just, I'll be using a lot of arrows, guys. So I really like this mapping thing. The only thing you'll see different here is that I know you will say, sir, this is X, this is Y, this is another variable. That's fine. But the key difference is what data type. What is this? This is your integer data type, and this is your string data type. So when we get into different data types, I will be showing you that different data types have different types of properties. They characterize differently, right? Even the same function will be used differently on the different data types. So for example, if somebody says that, okay, what is length of this? What is length of X? And if I say what is length of Y, and you put, right, and you try to understand that what's going to happen in different functions, for the same function, different variable, you will be amazed to see that if X is a list kind of thing, it's a list is also a data type, by the way, guys, as it's a sequential data type, and I'm putting this here like, 10, 20, 5, 6, and if I put a string here, and I'll say that, okay, 10 is for, let's say, APC string, 20 is for, let's say, KPME, right? Or something like that. So you will understand that the same function length has a different answer for list, for a list, and for a character data type. So for example, character means I mean string data type. So if I say what is the length of this, you might get number of count of characters here, but here length of list will tell you number of data elements in the list. So there are two different things happening here. But all these you will see at the right place. And that's also known as in OOPS language polymorphism. So these are some keyword I'm giving you to, you know, excite or maybe, make it a bit little interesting. But idea here is that just note it down and wait for me to explore it. Okay. So what is polymorphism? If you start thinking now, you will get panicked, you will get confused. But I'll show you when I'll talk about length. Length I'll talk about when I'll teach you list. List I'll teach when I will completing all the different data types. So there are going to be sequences, but polymorphism, just for your quick understanding, poly means many, poly means many, and morphism means form. So same functions are showing different characteristics or different form is known as polymorphism in Python OOPS. Now, guys, let me quickly put a definition on variable. So let me write. So it's a very simple definition where we are saying that a Python variable is, is a temporary storage location. Why temporary? Because you don't go and create a file unless until you save it. So the moment you write X equal to 10, it picks the RAM, which is the memory location, and tries to put some value there with the address. But if you just delete it or you just close your Jupyter notebook, that will be lost. Okay, makes sense? Unless until you store it in your permanent memory location after writing step. So generally, it's a temporary storage location that will store a particular value for a particular variable. Simple. Now, I'll ask another question, guys. There is a concept of declaring a variable versus initializing a variable. Declaring a variable versus initializing a variable. Declare means make it available. Okay. So let's understand what is declaration. Declaration is nothing. You just say that I will be allocating a memory for the variable. Okay. And that variable can be anything. It can be a numeric data type. It can be a list. So suppose somebody says that my list, I'm creating a variable called my list, my underscore list, and I just put a double square braces. When I'll teach you list, guys, for now, you can keep it just as an information. This is known as empty list. Do you see any value assigned to this? No, right? It's all empty. There's nothing within this. So this means that you just said it to your Python that Python, can you give it a memory for this particular list? I'll make sure that when I'm running a for loop, I'll fill it. So when you're running a for loop, you're using this empty list and try to fill the result of your whole analysis or whole computation into this list. So when you are trying to run the for loop and trying to fill the values, that means initializing. Make sense? So allocating a memory for a variable, or you just declare a variable means what? You're just saying variable my underscore list and you give a memory to it. There's nothing in there. It's empty. What will be the next step, my dear? Next step would be once you are done, you will be saying assigning, and I think that part everybody got right. Assigning value to the variable is known as initialization. Sorry, I missed that. Arrow should come from here. Okay. So for example, now in this my underscore list, if you see some numbers are coming like 10, 20, 30, 40, 50, that is your initialization. But Python is a very bad language in this way because they are very fast and smart. When you are writing x equal to 10, let me take a step back and show you. When you write x equal to 10, actually you have done two steps at once. You have also declared, you have done the declaration, my dear, and also done the initialization. Isn't it, guys? Come on. That's where Python is so no bakwas, right? Straightforward to the business, straight to the point. Suppose you have to do the same thing in C, and those who know how does C work, you will not write like this. You have to at least write 3 or 4 lines of code there, isn't it, guys? If somebody who is an expert in C, can you just ping the code for C the same thing? I want to store a value, x equal to 10 in C. How will you do it? But the right way to can if you can write in C, declaring a variable, initializing it, you will not be writing just, you have to write a code which should run also, right? So ideally you have to do a lot of things. So first, I think you guys are right. If you write int x equal to 10, right, or so definitely here this part you are trying to declare a variable x of integer data type, and then you are assigning it. But here say you don't need to write integer, you don't need to write anything, you don't need to write hash include everything. You can just write 1 line of code, right? And it should do. Okay. But in C, ideally you will be, writing 2, 3 lines of code. Okay. But let's not get into it. Yes, very good. This is what I was talking about. Okay. So what Mayur has written, and if you try running it, so I'm copying and pasting, guys. But let's not delve too much into it. I'll just make it int x so that it is going with my example. So you have to, use some callable functions like include, main, and then you will get into this. Okay. So that's where the difference is. Okay. Now, guys, I will also teach when we will be doing machine learning, right? So you will be doing a lot of multiple variable assignment. Even in array, I'll show you some function where I'll be doing multiple variable assignment. So Python is so kind in terms of writing and making your life easy. So there were questions, right? Why do I need to use Python? Python is really very easy to use. Okay. Anyone can learn Python. That's why I'm seeing class 4th grade, 2nd grade, 3rd grade guys are learning Python because it's so intuitive that you can also write multiple variables and assign it in 1 line of code. So what is the meaning of it when I say multiple variable assignment? We can declare multiple variables in a single line, in a single line of code in Python. So I'll give you an example. If I say x comma y comma z, and I give you, same 10 comma APC, and you can also put a float 20.3. And if you do print of x, y, z, right, you will see everything is coming. Okay. Now, can you see that x is getting assigned to, 10 is getting assigned to x in my example, y, and this float guy is getting assigned to whom? Z. So you have to be very careful. When you will do a machine learning so when you do machine learning, right, you will be doing training and testing. So now don't again ask what is training and testing. You will be learning that. But just to give a quick idea that when you try to fit a model, so you need a training data set, and to predict it, you will be doing testing data set. So training and testing is going to be your bread and butter throughout your life. Okay. If you are being a data scientist, so don't worry that, oh, what is this? I am not aware of. You are not aware, you have not been taught. So just don't get panicky about it. But let me show you this. I am taking it from the one of my simple examples. where you are trying to do the training testing, guys. Can you see that? Are you here? What I'm showing to what I'm trying to show here, can you see it's a clear-cut example of multi-assignment, multiple variable? Can you see that, guys? Training and testing for X, training and testing for Y, guys. Can you see that? Don't worry on the right-hand side, what's getting there. Definitely this function, just try to understand, be smart. This function is going to generate 4 set of data frames or arrays. Later you will realize any data type, but 4. Why 4? Because this is 4. 1, 2, 3, 4. So what we are learning here is getting used here. Okay. That was the reason to show you this. So as a practice, I don't do a lot of multi-assignment, okay, to be honest, because it can get confusing. But if you're trying to do that, you have to be very careful. I'll tell you why. Because if you just change the position, if you write X underscore train, and if you write Y underscore train, it's wrong. You understand? Okay. Okay, let me give a simple example. If I write X equal to 10 and Y equal to APC, what is the interpretation here? X equal to 10, Y equal to APC, you're running 2 lines of code to get it done. X will have 10, Y will have APC. Now, what I'm saying that just to save some time and energy, you can write the 2 lines into 1 line. That's also I have defined, right? If you focus on these 2 words, we can declare multiple variables in single line. That's exactly being done. Now come to our example. This function train test underscore split tries to create 4 set of data frames. You can assign all 4 into 1 line. You don't have any other option. Want to do that? Then you have to write your own function. So this function generates 4 set of data frame. That's what you are seeing. X underscore train, X underscore test, Y train, Y test. Simple. Okay. This is a simple example, a very real example of multiple variable assignment. Now, naming convention is also very important, right? Because you cannot name variable the way you want. You have to follow some rules, okay? So for that, let me give you a list of naming convention so that you don't miss on this. Yeah. So if you have to name a variable, you have to focus on few things like variable name can, are case sensitive, so you cannot take it lightly. So to give an example, if you're writing my underscore list and you're writing my underscore list, do you think they are different, guys? Exactly. They're different. Why? Because here M is small letter and here M is capital. So that's the reason that if you have declared a variable this one and trying to search for this one, you will not be able to find it. You will see an error in the code. Okay. So variables in Python are case sensitive. A variable name cannot be start with a number. You cannot say, suppose I like Dhoni, right? So I'll not be saying, okay, 007 or 7, or my variable name is 7 Mahi, right? It will throw an error. It's not a proper way of giving a variable name. Okay. Although you can do that, you can write Mahi underscore 7, or you can also write Mahi 7. That's fine. These are acceptable. A variable name can consist of alphanumeric characters, which I have already shown here, right? This is what I'm talking, right? Special character cannot also be like you cannot like at the rate Mahi, right? This variable name is not gonna work, right? You cannot say hash Mahi. You understand? So all these are not accepted. So you have to be careful. There are certain keywords in Python. They are known as, they are more like reserved keywords. So you cannot use it for variable name as well. So let me write 1 line about it. So there are certain keywords. And these keywords are, guys, more like your standard keywords which you use for a lot of things. Like for example, print. Print is one of the famous keyword for getting your output printed, right? But you cannot use this print as a variable name. Okay. So for example, if I say print, focus, guys, let me complete, then I'll come to your question. Print, delete, for loop, you have for, define def for the function, you have while. So there are few keywords, pass, continue. Don't use this as your variable names. It will be throwing an error. Okay, clear? Okay, there are some good Abrar, that's right. Hyphen is not accepted if, as far as I recall. Capital def, I think you can use, but why do you want to use that? Let's not use something which is confusing with the reserved keywords, right? So why to go closer? You have so cool variable names. Okay, you can also not use like Mahi at the rate 007. That's not also acceptable. It will throw error. At the rate, not only in the beginning, also in the middle cannot be accepted. Underscore is accepted. That's correct. Yes. So if I write Mahi underscore 007, 100%. Ideally, I use a lot of underscore. If you see, I created my list, right? What I use there. See, underscore. Underscore is a good. So generally, I'll tell you what to use rather than telling what not to use. I will say, I should share. You should always use this, right? My list, you can write. My underscore list, you can write. People also write my list like capital L. I don't like it personally speaking because you have to be very, very careful that you don't miss on capital L, right? Okay, makes sense or not? All these special characters you cannot use a sign. Okay, symbols if you're asking, all these special character cannot be used. I think underscore can be used. I think dot cannot be used either. I think yeah, that's correct. So special character means tilde, at the rate, at. So don't worry, you will be figuring out on your own. So there's nothing. There's don't try to remember it. That's what I'm trying to say. If you don't, if you try to remember it, then you get confused. So don't do that. Over a period of time, it will be easy for you to uh, work on it. So don't worry about, oh, I need to remember it. How to, you know, what are the ones I need to what are the ones I need to use? If you try to remember it, you'll be confused. Okay. So remember, I gave you y equal to APC. If I count length of y, it will be how many guys? Come on, tell me. 3. Suppose I give a space, AP, and then give a space here. It's not underscore, it's a space, just C. And if you count just one space, you have to click that long key only once. It will be 4. Right? You will see all those. And when you will get into hands-on, you will also able to make it out. Okay, cool. Now, I think, so we are done with this. Let me just talk about quickly global variable, and then we will be able to complete the variable. So global variable, anybody, what is a global variable in Python? So let me put it. I think you guys are right. So global variables are those which can be used outside the scope of a class or function. So class, when I say, it's more from the OOPS side. Function, when I say, right, suppose an example you can see on the right hand side. So now we'll not delve too much into it, guys, because I have not talked about what is a function, how do you define a function, right? So let's not get too much into it, but just guys are right. A variable which is defined outside a function and can be used inside, right? Or can be used in across multiple functions. Like prime minister is a global variable. Prime minister is a global variable, but a CM is a local variable. Understand what I'm saying? Hello. It's a very cool example. I should get copyright. So prime minister is a global variable, right? It's for all the states across the states. I know there are some concurrent lists, some state lists, some central lists, right? But then when I say this concurrent list and all, this is like job scope. What what is within the central government scope, what is within the state government scope is all the policies and all I'm talking about. But let's not get into that. I'm talking about that they have their own roles and responsibilities. So PM has global roles and responsibilities across the all states of India. But let's not get it political. Huh? Some of the guys will start saying, no, PM is not paying attention to the state. Let's not get into that. Okay. This is the only concern when I take political example, but it's a good example. Okay. So when the right time will come, I'll show you a global example as well. So why I'm pushing all those things on the future, because I have to do a hands-on to show you. But just to give a quick example of it, this is a good example, but let me give you my own example here as well for the global variable. You're able to read? Is it readable? Now this is a variable which I have defined. X equal to 25, which I have defined here, is your global variable. Okay. Now let's say I define a function. Let's say I define a function called add, which will do the addition. So these are some function syntax. You have to write def, okay, and then you will write add, and then come within the function. You can write another variable called y equal to 75. The only thing which you are going to learn is that this is a global variable. So this guy is a local variable. Why it is local variable? Because it is defined within the function. The purview is the function. Now, if you use z equal to x plus y, do you think it will work? And if I say print addition of x and y is, it will work, right? And I say z. So you'll see that z will come out to be 100. Ideally, it will not come like this. The output will like this. Let me show you the exact output. So what you will see in the print console. So addition of x and y, it will come. Okay, clear? That's a global variable and local variable, understand. So def will define, yeah. So within the function, see, read the definition. Global variables are those that can be used outside the scope of a class or function. Now, if you try to call this variable y in some other function, it will not be called off, right? You will not be able to use that. But if you're trying to, call the variable x in some other function, right, it will still be called. So this is like a global variable. This is like a local variable. So local variable cannot be called outside this function. And these things we will understand when we get into hands-on. So few things, guys, again, I'm reiterating. You have to take at the merit of what uh, a trainer or TA is telling. And then we can validate it later. Okay. You might have some doubt. No, no, no. I don't think it's right or wrong, right? Let's not get into right away, because when we'll go into the right set of things, then only it makes sense. Because before I teach you function, I cannot take an example just to show you that. It will be not correct. Data types. Shall we get started with data types? I think data type is I think it's one of the very important topic for the basic Python. If you don't understand the data type, you not understand the different data type methods. Let's hear from you. What are the different data types in Python you are aware of? Type of data variable can store. Int, float, string, int, character, integers. Python, in Python, things are a bit different, okay, to be honest. So let me show you. There are two types of data, to be honest. Uh, Number one is numeric data type. Number two is sequential data type, right? What you are saying now all the time, float, string, integer, right? All these are not the same data type. Integer, float, and complex, they are your numeric data type. When you say string, or when you say, let's say, list, or when you say dictionary, that will become your sequential data type. Set is again the same. Okay. So let me give you the first, what is data type, a definition. And that's very important, because without the data type, you will be struggling, to be honest, right? And data type is one of the key things when you try to do Python. So please don't take it lightly. So for example, if you are looking at a 2 plus 3, you are actually looking at data type, right? Suppose if I say 2 plus 3, you know it will be 5. Everybody knows that. But if I write 2 plus 3 equal to 5, the first thing you should focus that both are integers. Hello. And then you are doing an assignment operator here, which is addition. This addition operator, it's an arithmetic operator, right? And then you have this assignment operator. So addition operator, assignment operator makes you the whole process here. So in this one line, you are actually doing a lot of concepts, to be honest, right? If I write 2 plus 3 equal to 5, you are looking at data type, guys. You are looking at operators. Can you see that? So all the yellows are what? Your data type. As a matter of fact, this is all int data type, right? But this is your addition operator, which is coming from arithmetic bucket. And this is what? Assignment operator, right? In one simple calculation, you have this. But if you're not sure about data type, and when you write, list 1 plus list 2, and list 1 is also having 2 here, and list 2 is having 3 here, what do you expect? Do you expect it will be another list, and the output will be 5? What do you think, guys? Bit of exposure to Python. Do you think it will be showing 5 here? It will do the sum of this? Very good, Kirti. Proud of you. No, no, it is not correct. It will do a concatenation. It will do a concat, right? Why? Because it will just go and combine these two guys, right? It will give you this 2 comma 3, 2 comma 3. It will just combine these two guys. Concatenation list, right? That's what I'm talking about. So again, another topic will be like, okay, concatenation is what? So obviously you're going to combining two or more lists into a single list, that becomes a concatenation. Operator is same. Can you see that? It's the same operator. It's the same operator, but the behavior is different. Huge difference in the behavior. Why? Because you are not operating on the same data type. What is this data type, my dear? This is what data type? This is list data type. It's a sequential data type. So here, the same plus is termed as concatenation. Here, the same plus was termed as addition. Are you feeling it, guys? This is how I introduce data type, right? So it's very important that you understand what data type you're dealing with, else you will be completely or grossly mistaken, right? And your answers will not be in line with what you're expecting. It will all erroneous. Here you are trying to do an element wise addition, answer will be something. So now we can get into that textbook definition that it is classification or categorization of data element is, referred to as data type. It represents the kind of value that also helps you with what operations can be performed, right? That's exactly I have done here. Okay. So we have taken care of that. Now let me show you now numeric data types, sequential data type, and Boolean data types, right? So numeric data type, let's talk about. Okay. So we have definitely put together some really nice slides have been put here. Numeric data type. Let's start one by one. Numeric data type. So numeric data type in Python, right, uh, represents or it will be showing different types of numeric data having values. So for example, if I talk about integers, all these guys like 10, 20, 30, all the numbers, right, are your integers without any decimal. Suppose I write float, it is 10.5. It can be 10.23. It can be even, like this, which is your 3.33333 is also a float. Okay. Don't get into rational, irrational, and all those things here. Okay. So this is also a float. Even if you write 2.0, what is this? 2.0 is what? Positive, negative, by default, we have to take. Complex, you know that 2 plus 5j minus 2 minus 3j. I'm also writing some minus numbers so that you don't get confused. Minus 20, minus 100. Negative numbers also there. Now, j is something we will be using, not iota. So, iota I generally people don't use in Python. It will be j. Okay. So, these are your complex number. I think everybody knows that this is your real part of the complex number. This is your imaginary part, right? And j is your root under -1. Remember? So I have taught mathematics for IIT J, so you can the most complicated ones. So J is equal to root under -1. So complex is, so if you do look at the numbers theory, right, or number system, complex number is the highest, then comes your rational number, then comes your integers, right? Both positive, negative, then comes your whole number, right? Integer, I. So that's how the hierarchy looks like, right? Complex number is on the top of it. Even you can write a real number like 2 plus j0, right? Nobody stops you. So real number can be represented as a complex number, but not the vice versa, right? Not vice versa. Now let's take what do we have in integer. So if I talk about integer, integer refers to the int class. Okay, let's, now double click on each one of it. How can we calculate 5j? No. So what is happening, no? Then you're asking a maths question. So when you write 5j, basically it was written like 5 root under -1. Understand that? Okay. So it's not like that you are going to calculate it. You are actually representing it. It's a bit of representation. No, you have to take it. And I think there's a question coming from Anthony that where we use complex number in Python in complex calculation. Suppose you're doing a signal processing or Fourier analysis. So some mathematical kind of or scientific research only will use complex algebra. But suppose you are getting some negative under root, right? Root within the root you're getting negative means it's complex. Okay, just keep that in mind. But I don't think that you will be using it in our course somewhere. Okay. But if you really want to understand where you can use, so if you are from electronics background or electrical background, signal processing. So signal processing is more like an area where you are trying to understand different types of signals, and signals can have imaginary components as well. So I have done BTech in electronics, and those who are aware of it, signal processing. So you have that Fourier analysis. There also you will get complex number. or if you have seen, right? So that's why I don't want to go into that, because then it will be like really overwhelming for you guys. Let's not go there. That's not required for us. But I need to tell you what is a complex data type. Now come back to integer data type, guys. So integer is of int class. So whenever you will see any integer, suppose I write x equal to int and to x equal to 10. And then if I print type of, so now I'm introducing one more keyword type. So type gives you the class of variable x. And what is the output it should show, guys? It will be showing you a int. Okay, int class. Makes sense or not? Contains positive or negative integers, right? That's fine, perfect. Covers whole number. Obviously, we cover whole number because you already have whole number is what? Starting from 0, natural number starting from 1. So obviously it covers whole numbers, natural numbers, everything. And sometimes people ask me that how long an integer should be. There's no limit. Python doesn't give any explicit limit on anything. Just like unlike C or Java, right? I think C gives you some limit on 256 or something, but Python does not give any limit. You can give as long as possible, but I am sure that there will be certain limitation, but they don't explicitly mention that. Obviously, everything is there with some limit, but they don't mention about it. That's what I'm trying to say. Okay. Now moving on to float. Focus on the right things here. Float. Float, again, it has a class called float. So you will be seeing the class written as float. Uh, all the real numbers which can be represented with floating. There's not much to talk about it. You have to just pay attention that there will be a decimal point for that, right? Now I'll quickly wrap it up. Complex, which is we are going to not use at all, to be honest, right? Complex is complex class written as complex keyword. You have a real part, you have an imaginary part, and can you see that you have a j here, right? And j has to be after the number. Okay, that's another thing, guys. Sorry, just recall. You cannot write 2 plus j4. It will give an error, right? You have to write 2 plus 4j. This is wrong as per the representation, right? There's a question that what is the value of 2 plus 4j? See, you are saying that what is x equal to 2 will do nothing. No. So 2 plus 4j is a representation in complex plane, or let me show you. So when you go into a complex plane, on the x-axis you write real part, on the y-axis you write imaginary part, right? So when you say 2 plus 4j, it just means that 1, 2, 3, 4, 1, 2, 3, 4, 2, 4. So somewhere here your number will be located. Are you getting? So this is what we also call argand plane, right? So that's what it means. It doesn't give you any value there itself. You're asking like 2 comma 3, what is the value? Are you doing some math operation? Then you'll ask value, na? 2 plus 4j is just a number in the complex plane. Are we clear?
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Can start with sequential data type, one of the most important data types. Can you see my screen? Okay, so sequence data type. Why do we call sequence data type sequence? Because you are able to, put the data in a sequential manner. Basically, you start uh, with, let's say, some numbering, some positioning to it. Not necessarily it has to be, uh, it has to be ordered. That is my one call out here. So generally these, so I was saying that sequence data types are the ones which allow you to store and manipulate, you know, general, loosely speaking, ordered collection of item, elements, or values. Okay. That's what we call sequence data type. But in Python, uh, there is one exception to it, and the exception is what? Set data type. So if you look at the sets, right, they are ordered or they're unordered. You have quite a few of sequence data type, right? Set is an unordered collection of data types. So that's where, although sequence name suggests or it means, right, conceptually, that it is an ordered collection of data elements or items or entities. But on contrary to the definition, it has slight a bit of exception, and I think that's only one. Set is unordered, list is ordered, dictionary is ordered. So we'll talk about it in detail. Also keep making some points. Okay, focus is going to be on list, but we'll start with all the different types of sequence data, and let me show you. So someone can ask you this question: what are the sequence data types? Right? You should be able to answer this. Sequence is an ordered collection of similar or different data types, although sets are unordered. So I'm myself telling you, right, that although we are putting set within the sequence data type, but it has an exception to the definition. Okay. So what are they? String, tuple, dictionary, list, and set. The most critical data type is here list. Then we will be most seeing is the dictionary. Then we will be seeing string. Maybe I'll put in terms of stars. And then comes your tuple and set. So as you can see, this is the rating that list is going to be your bread and butter here. Make sense, guys? Any other data type that you think I have missed it? Yes. So Boolean will be coming. That's the reason I was trying to ask. Array, Boolean are all different under the different buckets they come. So array will be coming as a data structure itself, and that will come in NumPy. Boolean will come as the third data types. Remember? So when I gave you this list, there are three types of data in Python, right? One is numeric, one is sequence, and the third is Boolean data types. Array is on the top of it. Make sense? Everybody comfortable? Data frame is another data structure that will be coming on top of it. But fundamental data types, if you see, these are the ones in sequence. Perfect. So now let's talk about list. What is a list? Anybody? Let's start with list. Question is that what is a list? Anthony. Kind of an array where we can store different types. Yeah, 100% correct. So you are indicating heterogeneous behavior of list, right? Isn't it? Collection of data, stores a collection of data, ordered. Very good, Catherine. It's ordered. Anybody on the mutability? Is it mutable, guys? Nobody's talking about mutability of data. First of all, what is mutability of data? What do you mean by mutable, immutable? Can be modified, ability to modify the values, right? Generally, when you define list, right? Yes, you should always say that list definitely is, list is a collection which is ordered and changeable, right? So let me give you some pointers here. So what is the list? I'm putting the screenshot, guys. Lists are just like arrays declared in other languages. So they're talking about arrays like in C, which is an ordered collection of data. Okay. So let me add to this because this is a little limited here. So if I have to define list, I'll define list as a list is a collection of data. Follow, guys. A list is a collection of data which is ordered and changeable. Which is ordered and changeable. What do I mean when I say changeable? Changeable means mutable, which is changeable, right? And continue with a comma and right allows duplicate elements. Do you know this? List does allow duplicate elements. Unlike sets they don't allow duplicate elements. And the collection of data you can underline and write. The data can be heterogeneous. I'm coming and covering. Don't worry, Rudra. So what do you mean by heterogeneous? That a list can contain all the different data types: integer, float, complex, right? What else? String. Are we clear? That's correct. List can also contain lists. So nested lists, we call them. Now, guys, when we talk about list, indexing, okay? Index. So if you recall, very good, Prava and Samina, indexing is there, right? So when we say in case of, right, list, which is an order, right, it means, so when I say ordered, what is the interpretation of it, guys? Let me write here. So when you say ordered, what is the meaning of it? So order refers to what? Arrangement of elements within the sequence, right? And how do we do that? Arrangement of, let me write here, elements within sequence via indexing or using indexing. So those who are saying indexing, they are correct. Okay. So this is about list. Let's talk about list methods. Okay. So definition wise, we are good. We can take a quick example of a list. So I can say my list is 10, 22.5, 3 plus 4j and APC. In this particular list, can you see that everything is written in a square bracket? Can you observe that? So list, you can also write a quick note. Lists are, right? What about lists? Lists are declared within the square bracket, right? That's what we are saying. So you can say a list is written in bracket in square bracket, or written using square bracket separated by comma, brackets separated by comma. Okay. Yes, it can have my empty elements. Remember, I showed you a list like it's a out list. I can create an out list as an empty list, and then what I'll do that I'll run off some computation, some for loop, and start filling in the list. Remember that I made that comment, right? So this is basic Python. Okay. So let's start with a bit of basic libraries, basic way of writing Python script on Jupyter. So see, this is your Jupyter notebook, okay? And I'll give you a walkthrough of Jupyter notebook since some of the guys are asking, I need to do it. So this is something you click here, which is your user interface tour. And into, you can see that you can use left and right arrows to go through it. So this is your file name, guys. Can you see that on the top? Then comes your notebook menu bar. See, so this is your menu bar, file, edit, view. So you have all those for your actions. Then you have notebook toolbar, as you can see. The toolbar has buttons for the most common actions, right? So you're adding a cell, cutting a cell, right? So this is known as a cell. On the right hand side, if you see, my dear, it is saying it has two modes, edit mode and command mode. I'll talk about it in a while. Now, if you see that, if it is in edit mode, you will see a pencil here. Can you see a pencil? Right? So means you can go and write your code. That's your edit mode. Now, command mode will be something. Then edit mode will have a, kernel indicator as well for the notebook. So this is your notebook kernel indicator. So your notebook is busy or it is computing anything you see there, like dot, the black dot. See here, the black dot means your kernel is busy. Then notification area, something it's happening with your Jupyter notebook. It will come here, right? What else? I think that's it. This is it. Then I'll give you some shortcuts. Got stuff. Okay. Let me just reload this. Yeah. Now, guys, suppose I have to write a code. So I'll go and click in the cell and I'll say 2 plus 3 and run. So while running it, I used a shortcut called Shift plus Enter, and this is for Windows to run the cell. Okay, please keep this in mind. Can you see that? To run the cell, shortcut is Shift plus Enter. Everybody will try. You go into the cell, click, and you will do 2 plus 3 Shift Enter. Are you able to do it? No, cell, not shell. Cell. If you see the cell here, Shift plus Enter, you have to run. Now, guys, how to open a file? The moment you run, you will see a cluster like this. Can you guys see that? Local tree 8888. Everybody seeing that? So that shows your directory, guys. So let's understand what is this. These are your files. Then these are the notebooks which are being run by me. Okay, a lot of it. Cluster not of our interest. So files is more like your directory. It's more like, can you see that you have all the different things? So all the classes comes here in the TL, the Silver Lining Consulting. In that you have Intellipaat. Then we have, so this is my folder structure. You might be seeing different. This is your 11th October batch, and there, once you are there, guys, can you see that? So you can actually navigate to a particular folder of your choice, and there, or you can also create a folder. But don't create a folder here. Create a folder like using the Explorer, And once you have done it, can you see this? There is something written new. Drop down on the new and can you click on Python 3? The moment I click on Python 3, it gives me a new notebook. Are we good? That's how exactly I created this notebook. Everybody. And then you have to name the notebook. You can click on this, you can give a name, write, and then after that, anyway, I've explained. Done. Now, let's understand about little bit on the Jupyter side. So whenever you are running a code, you have to go and, add a cell. So to add a cell, what I'll do, I'll just click on this plus button. Can you see that? The moment I do plus button, it is adding the cell. And if I have to delete the cell or cut the cell, I'll do the scissor. Can you see the scissor there? Okay. Suppose you are in this cell and you want to run the code. Let's say I want to run 2 into 100. It should come 200. So there is a couple of ways to run this. There are a couple of ways. One is that you go there and click on run. You'll click on run, it will come 200. Can you see that? Or smartness would be that use the shift plus enter to run the cell. So when you're in the cell, you will press shift plus enter. Shift plus enter. That's one shortcut you have to remember. Then every time going there, adding a cell is a very tough thing. So I don't like it. So there is an edit mode and command mode. Okay. You might be seeing I'm doing some cool heading and all. So how I am doing it. So to do that, guys, you have to follow certain rules there. That is known as Jupyter Markdown features. Okay. That is known as Jupyter Markdown features. So what is it, guys? So Jupyter Markdown features can be used, can be used to give you this kind of, like suppose I'm saying, basic Python, welcome to Intellipaat, right? Something like I'm writing, more like a heading. Can you see that it is also doing a monospace? So all those things, what I'll do, I'll share my notebook in the interest of time. You can learn from it. So you have to give a tilde sign here. Can you see that? And then you have to give not tilde sign, just it is below the tilde sign on the same button on the keyboard. And then you have to press, in the command mode. So if you are observing very clearly, when I press escape, can you see the color turns blue? If you see this color, this part, you will observe that when you press enter, you go in the cell, it gets green. This is known as command mode. Command mode. When you press escape, it becomes blue. Can you see that? So in the command mode, and this is written here, right? If it is blue, it is command mode. It's green, it is edit mode. Okay. And how do I remember it? Green itself has the word E. Remember? Okay. So GE. Always remember GE. Green means edit. Okay. And the other is command mode. In command mode, you can actually get into this and you can change this cell to markdown feature or some heading or some code. Suppose I go and make it code, right? It will not look that beautiful. The moment I go and select here that it is a markdown, and with the hash you can give title, okay, and with that tilde button partner, right? That quote you can give as your. It's not the quote actually, single quote. It's some other symbol. You can use the monospace. That should be enough for now. Okay, we can keep adding more to it, but yeah, that should be enough for now. So I'm giving few introduction for you in the notebook only. So I'm writing here gentle introduction. Okay. I'll explain so that you're there, but don't expect me to go and discuss Jupyter Markdown features like a course. Okay. Okay. Now you can also embed images like this. Now, if you understand, I have already explained edit mode, command mode. Press escape to go from edit mode to command. All written, just go through it. In the command mode, now you can do amazing things. You can add a cell by pressing a button A, and you can add a cell pressing a button B. A does above the current cell and B does below the current cell. Right? So let me show you this. Suppose this is my cell, which is 2 plus 3. If I run, it is 5. Right, guys? Come on. Now, in the command mode, listen to me very carefully. In the command mode, if you press B, can you see that I'm adding a lot of cells below it? It's in command mode. And if I press escape and again in command mode, if I press A, means above the cell. Correct? Are we clear? Are you guys able to replicate this? at your end? Someone is able to do it? Now sometimes you have to delete the cell. So one thing you can do the scissor. The other thing you can do in the edit mode, if you press D button 2 times, can you see that? It is being deleted. See, right? You can keep deleting in the command mode. So these shortcuts you can practice. How will you learn about all these shortcuts? I can give you the help. Edit keyboard shortcuts, all the shortcuts you will find it here. Okay, so you don't need to worry much on it, please. And don't expect someone to help on this. Just read it, practice it, you will get it. Are we clear on this, guys? Because then this is never ending, right? So I accommodated your request to go through quickly Jupyter Notebook. What is Jupyter Notebook all about? All those things. Are we clear? Perfect. Now let me move on to the proper concept. Okay. What do you mean by only B? To add, you have to do in command mode A or B, not shift or control. Only B, only A. Okay. Above A, below B in command mode. Command mode is edit. Sorry, yeah, this blue color. Now, guys, let's talk about Python variable. That's all about giving different titles of size. So you can try that out. Okay. Sometime I'll give you 2 hashes. See, 1 hash bigger, 2 hashes little smaller. See, can you see this? So size will be different, just like you have seen in Word. See, 4 hashes like this, even tinier, even tiny, and the 5 means italic. Can you see this? Italic title. Are we cool, guys? To click is the edit, escape is command. So I am in, the moment I click in the cell, it is edit mode, green, pencil, see here. The moment I press escape, it is command mode. Write these things down, okay? Else you will keep asking. Now let me talk about Python variables. You already have seen this slide from my side. I am just going to show you some quickly. How do you do that? X equal to 10. So here you are assigning X to object 10. Okay. Y equal to, let's say if I say APC, here you are assigning Y to the string. Okay. Now I'll run this, guys, and I can print it. And this is print Y. Can you see that? It works, guys. So this is to print the output. Okay. You know it. Just I wanted to write. Sometimes people can say, can you also show the type of this guy? So what is type of print of X? It should be integer. See here. What? Type none. I did it ulta, opposite. Sorry. Print of type of X. Can you see that, guys? Class integer. This is what we were discussing yesterday, right? So I'm just quickly showing you hands-on. Similarly, you can say print type of Y. What you are expecting here, guys? Come on. If I do that, you will get what class? String. See, str is string. Is it working, guys? Z can be your, 2 plus, 5j. Okay. And you can say print type of Z. See, class complex. What is left? W equal to 13.5. If I print type of W, float. Now, as I was telling that every object is having a unique ID, which is what we call identity of a variable. How do you do it, guys? How do you find identity of a variable? So for that, you will be using this ID as the function. So you should also know the function. So this is your function, guys. So ID of X, we have defined 4 variables, right? ID of Y, ID of, what was that? X, Y, Z, ID of W. Since you are doing multi-print here, you have to give everything within the print, else it will not show in Jupyter Notebook. I hope you guys are able to code with me. Print ID of Y. And don't worry if you're not able to code everything with me. You can skip that and you can practice later because you cannot match my speed. But that's fine. Guys, can you see that you are getting some numbers there, unique numbers? 1, 2, 3, 4, all are different numbers, guys. Can you see that? That's your identity for each and every object. That's your address in the memory. Sometimes someone can say, can you also tell me hexadecimal code of this? Yes, you can say that. See, this is your hexadecimal machine level code for the same object X. So you have the ID. See, you have the ID and you can also print hexadecimal code. Can you see that? Learn from me, pick things from me quickly. Just let me. Okay. Now there's a question coming from Shilp Shah. If different variables are assigned the same value, then address will be same or not, right? So first of all, big hand to Shilp. So this was from Shilp. Now guys, I'll give you another shortcut and that is known as Shift plus Tab. Shift plus Tab is amazing functionality. It has an amazing functionality to show the documentation for the function, or you can say, syntax of the function as well. Because in the documentation, you have syntax as well and syntax as well. Okay. So those who don't know, Shift plus Tab can be really helpful while you're coding. I'll show you. Suppose I want to understand what you mean by hex. I'll do Shift plus Tab. Did you notice a cool thing has popped up there? You can drop down. You can also return the hexadecimal representation of an integer. This is a very simple function. Sometimes you can also find it by putting a question mark before the function and see it gives you. I have to not get this and then it will return. Okay. So ideally, I don't like this question mark and all. I go with the Shift plus Tab. Everybody is able to do this. Shift plus Tab. Try it out. You write any function. You can write ID. Do Shift plus Tab. See, returns the identity of an object. Now, I'll quickly talk about multiple variable assignments in Python, which I taught you guys. So I'm covering the base, guys. Can you see that? Now, suppose you had X, Y, Z, W. Remember that? And then you had 10, you had APC, then you had 2 plus 5J, something like that, right? And then you have 10.5. You have 4 variables on the left and you have 4 objects to be assigned to this, right? See, it works. So you can also print like X, Y, Z, and W in one go. See guys, is it working or not? Clear? Now naming convention in variable. Already I have discussed about it. Naming conventions, right, in Python. So you already know that. You can say that, my variable is my var, right? You can say 10. I'll give you a lot of one. You can also say my variable like var equal to 100. That will also work. But you cannot say that, 7 mahi equal to 100. See, you cannot say that at the rate mahi at the rate 007 equal to something CSK. Something like that I'm giving. It throws an error, guys, right? What else? What else? Come on. You cannot also use like some keyword like print equal to 100. Although it does, but I don't think it's a good way of doing it. Let's see if I say for, no, here it will, so it's a reserve word. For equal to 100 you cannot do because for is a reserve word for loop. Are we clear on this, guys? However, you can do mahi underscore 7 equal to CSK. That will work. So guys, you have to try. You cannot do mahi 7 equal to CSK, right? It throws an error. So hyphen does not work. So the best thing about variable convention is that, naming convention is that, you always use what I have taught you, right? My variable, or you can say, my underscore, or you can say underscore. I don't like underscore first because it has some other applications as well. But you can say mahi underscore or mahi capital VAR, right? Something like that. Up to you. Something like this 007, or you can say, this is also fine. It will work. Okay. Now I talked about variable names cannot have special keywords or reserve words. Remember that line of mine? So the question comes, what are the keywords in Python? So keywords in Python are quite a few. You can find all of it, but what are those keywords? These keywords are some special reserved words for coding, right? And they have special meaning and purposes and cannot be used for variable names. These are the 3 pointers I wanted to give. Now I'll talk about what are the keywords. You have it. Look at the big list. So all these are your keywords. You can see that you have false, none, true, and is an operator, break, class, continue, def, else if, else, for loop, for, if, is in lambda, everything, retry, return, pass, while, with. So you have a lot of keywords in Python which cannot be used for your variable name. Is it clear, guys? Now my recommendation for naming the variable is this, that you go there and you say that, okay, lowercase you use or start with characters with numeric along with underscore. Characters is not like special character. Alphabets. Okay, clear? Sometimes people want to use double underscore. That is something is more like preferred for naming classes in OOPS. So don't do that. You might have seen some classes name like this, then double underscore like this in Python. So that is for class naming convention. So don't do use it. Okay, clear? Then there are three types of codes you must have been seeing. List data type. So I really like list data type because list is something I'll talk about. I'll put a small heading here. I'll call this as data types. This single, double, triple quotes, I will take it up in when I'll teach you string data types. In that, numeric complex float you have already seen. I'll talk about sequence. Within that, I'll talk about list. So I'm not going to get define again what is list and all, but you already know that when you're trying to go to a grocery shop every day, you have a list. Those who are married, they know it. And most of the time, guys are getting lists from their wives, respective wives, right? I'm one of those guys. So you have to make a list. Like you'll go and you say, I'll take a Surf Excel, liquid. So that detailed list you do, top 2 liters. Okay. Then let's say you want to say, okay, I need some Maggie, let's say 6 pieces. Have you done this? 1, 2, 3, 4, 5, 6. Come on. Isn't it? This is an ordered list, guys. Is it ordered? Look at these numbering. Yes, it is ordered. This is the list which you have been creating every 3 days, every week, right? You just did not understood that this is the same list which you are going to be taught today in Python as well, right? So it can be also a to-do list, right? You define your task for let's say a week and then you put it into the priority order, right? Have you done it, guys? So I'll go for a passport verification, important task, cannot miss, blah, 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 right? Have you done this in your life? I think so. So then this becomes your basis for understanding list. You already have been taught what is a list, but this is also important for you to get a sense check. Okay. Let's create a list, guys. Okay. Let's create a list. So if you create a list, let me go to my Jamboard. Let me take a shape and give it a feel of list. So now, so I'm creating a list like this. 3, 4, 6. Let's say you have some number here. Let's say I say 100. I say APC, right? Within the quote. Quote means it strength 7, 3 plus 5J, 3.14, and then I can say call this as BBC and minus 10. Are we cool, guys? Now you clearly see that you have a list, and the list, every data types are different. Integer class, string class, integer class, complex. Can you see that? Float, string, and then again integer. Are we clear? Now list is known as ordered. Why it is called ordered? It is an ordered collection of data. Ordered collection of data because of indexing. The concept is why? Because of indexing.
So what do you mean by index here? So what list does, guys? Listen to me. It starts with 0. So you'll start here 0. In Python, everything starts 0. So 0 means 0 position in this. So you have a cell, right? You have like boxes there, like or cells there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Sorry. So indexing like what? We will start 0 and then increase it by 1. So then it becomes what? 1. Then this will become 2. The positions I'm talking. 3, 4, 5, 6. But if you see you're going from 0 to 6, ideally how many elements? It means 7 elements. In Python, everything starts from 0. Always keep this in your head. This is never you write 1, then you are making a blunder. Okay. The good part about is this, that the positions which you're seeing on the screen, this is known as what kind of indexing? Positive indexing. Why positive indexing? Anybody? Because you are increasing the counter by plus 1, plus 1. So you're going forward. So positive only, no? Not plus 2. Are you able to follow me, guys? So this is known as positive indexing. Now you have another cool feature that if this guy goes behind it, like something like this, then it also goes into reverse indexing. See, from here, if you are sitting here, right, you can either go forward, means positive. Have you, like, have you done walking, guys? You can either forward walk or this is forward walk, or you can go backward also from here. Can you see that? And this is your reference, guys. Okay. When you're going forward, this is known as positive indexing. And when you're going backward, this is known as negative index. So when you're going backward, like you're going backward, you will come here, na? And then you will say, oh, this is -1 because 0 is already here. -2, -3, -4, -5, -6, -7. So if you do the reverse, of it, you are still going to find that the last element of the list, let me make a comment here. Last element of the list can be accessed by using -1. Can you see that? Always can be accessed using. Clear, guys? Are we comfortable with this line of mine? Okay. So this is known as negative indexing because you're going backward. Okay. So let me do one quick thing. Let me paste it in the notebook. So now what are your observations? Observations are very simple, guys. What are those? It is heterogeneous, means different data types, right? The number one observation. What is number two, guys? It is ordered collection of data. Okay. It can have duplicate elements, items, all are same. Not, I'm also make a comment that not shown ever. I'm writing bot. Not shown ever. Okay. Number four, guys, can be modified. Not yet to be discussed, right? These are the things which we have not shown. But all these guys are the property of a list. Are we clear, guys? Mutable. Okay. So now indexing and slicing. So this is very important when you take a list. Okay. So let me take our list and I'll call it as, my list. And I'll put some different things like string, I'll put a decimal, I'll put a complex, everything, right? I'll also put few more entries there. I will also put duplicate items, right? I'll also put -100. Okay, cool. Now, this is a list you can see, right? Now, those who are wondering that how do I write this so fast, use tab. Use tab. So how do you use tab, guys? Suppose you write my and then press tab. It will start showing the options available to you because this is already being in the memory. Can you see that, guys? Can you try? Don't write my list. Don't do that. It takes a lot of time. That's why you're slow. So if you write M and then press tab, you will see a lot of options with all M. So you see there are a lot. So you will write my, then see. Are you able to repeat it at your end, guys? And then what I do, I use my cursor to go and select and press enter. Please practice it. Smartness is all about, if you can try to be smart, then only you will be smart. If you keep practicing the same old rudimentary traditional approaches, you will not be smart. It's all about practice. Done. This is my list, guys. Now, indexing means what? Indexing means that this 10 has a position. So suppose I want to access 0th position element in the list. 0th position element from my underscore list. See, how will I do it, guys? I'll just go, I'll say my list, and within the square braces, I'll place 0. Now I should be expecting 10. Let's see whether it comes or not. Is it coming, guys? Right? Similarly, you can now go and say, okay, so 0 is 10. What about 1? APC makes sense. What about 2? So you can do the counting like on your fingers and then validate it for the first time. So this is 0, this is 1, this is 2, this is 3, 4, 5, 6, right? So 2 should give me 22.5, right? Always remember it start with 0. Okay. So like that, if you do my list 6th, it should be minus 100. This is what we call indexing. So, right. So if I define indexing for, let me write, indexing is the process of accessing individual element within a sequence, such as string, list, tuple, or any other data structure, right? It's not only that indexing only for list. Okay. Make sense, guys? Okay. So all those options are there. Suppose I know the index, I need the value. I know the value, I need the index. You can do that. Let me go there step by step, right? First element is always with 0, right? But the last element of the list is what, guys? You remember I told you, no? You can use -1. So you will see that -1 will give you also -100, and 6th also give you the -100. Now the problem with the 6 is that it depends on the size of the list. Suppose you have a big list, you have so many elements, you need to go and count like a baby to understand that this is 6th or this is 9th position or 10th, but -1 is always fixed now. So to always get the last element of the list, you should always use -1. Makes sense, guys? See? Are you getting the point here? If you have a list having like 100 elements, you need to understand, you first need to know what are the 100, right? If it is not 100, you will not be able to get the last. Then it will be somewhere in the middle, right? Okay. So last element can be accessed with the help of -1. That's important for us to understand it. Okay. Then there are a lot of, questions, a lot of concept can be coming on list slicing. So this is all indexing, guys. I think the most important topic is list slicing. List slicing. Now let's understand list slicing. Okay. So this is my list, right? Where is the list? Yeah. So this is my list. Can you see that, guys? I'm putting the screenshot here. Okay. So what do you mean by slicing? So I think you have also done a lot of slicing with the food. Give me a slice of pizza, right? So pizza slide, you slice, you take it, right? Give me a slice, a piece, right? So generally, it's a very simple English word, slicing, right? Which means that you're going to, in terms of list, I'll talk about. I don't want to give any ideas about the food, right? So slice is what? A slice is a subset of list, technically speaking. Subset of list, right? Or you can also say subpart or subset, you're right. So suppose this is my full list, which I'm showing on a screen. But let's say I'm interested in only getting this part, and you have to help me there. So I'm only interested from APC to BBC, right? I don't care about the other part. Okay. I don't care about the other part. Then how will you get me this? Are you getting? So then there should be a way out, right? Means we cannot just say that, okay, you go there, right? So that's where you have a syntax of start, stop, and colon step. See, those who don't know, please pay attention. That's where I'm covering the theory, right? So don't be distracted. 100% if you're distracted, if you're distracted 100%, you're not going to get it. And it has nothing to do with anything else. It's all you. Okay. Start, stop, step. Okay. Now this is very intuitive, right? Where to start, where to end. Where you are starting, here. Where you are ending, here. And step. Is it one step? Is it alternate step like jumping 111, jumping 2 steps? So that's how the syntax is all about, right? Start, stop, step. Start is included in the sequence. Always remember, start is included, stop is excluded. So if you put like, I'll give an example also, don't worry about it. So start is included, stop is excluded. By default, step size is always 1. By default, step is always 1. Okay. So let me give you a simple idea. Tell me one thing, if I write my list, my underscore list, 0:5, what is the meaning of it? It means that you will start at 0, stop at not 5. Actually, stop at 5 means you will only include till 4, right? Position 4. Or you can also write 4th index. That's correct. Till the 4th position or index. Okay, clear guys? But you don't see any other colon there, right? There's no colon here. If there's no colon on the step size, by default, you will pick. What is the by default here? 1. So here step size is by default 1. Are we clear on this, guys? So basically in this particular list, this syntax will give me what? I'm putting the output here. Start from 0 means it will give me 10. Then it will give me APC 1. So this is 0, 1, 2, 3, 4, 5, 6. So it will give me APC 22.5, 3 plus 5J and BBC. Isn't it, guys? It will not give me 10. That's what written here, right? Start is included. See this box? Now, you will be telling me the answer for the question we started with, right? So I need that blue box. How will you give it to me? Now you tell me, my underscore list, what should I write? Where should I start with? 0 or 1? I need APC start. APC, see, coming now. So this is clear, guys. Now let me go to one more line. If I just write colon now, right, it means it prints everything from the list. It prints the full list. Prints the full list because the full list, right? See, if you do my list only this, it will also do that. It will print the full list. So doing colon means nothing. It's just that it means give me everything, right? But if you say my list and you say colon and then you say, colon and 2, what is the meaning of this? So it means that, can you remember the syntax? Start colon stop colon stop. Start colon stop colon step. Now here if you see, you are saying colon means everything you will take from start till end, but alternate. So it will print alternate items from the list starting from 0. By default, it is 0. Hello? See? Isn't it that's what exactly doing? 10, then it doesn't print APC. It prints 22.5, then BBC. See for yourself. Guys, come on. So it alternate items from the list starting from 0. Right? But someone can say, no, I want to start from APC and then alternate it from not 0, from APC. APC position is what, guys? 1, right? So what you will do, you will do there 1. See. Isn't it easy, guys? Can you see that? Now you want to say that, no, I don't want to APC to till the end. I want to stop at BBC or maybe the 10. So then you will say that for BBC you'll do 5, right? 1 to 5 and then alternate. See? So this 10 is excluded, guys. So understand what is the interpretation of everything. Here when I say 1 to 5 colon 2, what is the meaning of it? Start at 1, stop at 5 minus 1. So you will only include till 4. And then step is 2. Read it. Are you able to read it, guys? Come on. So 152, if you see here, see 1 is what? This is 1. So 1, 5. 5 is this, but I'll not take 5. I'll stop here. So this is my box. And then within the box, I'll go alternatively. So I'll only take 2 points now. APC and then 3 plus 5. Hello? Now let's say someone can say print the list in the reverse order. That's a very common interview question they ask all the time. That's a silly question, but they keep asking. Print the list in the reverse order. How will you print it in the reverse order? Right? So what you have to do, you will take everything colon, colon, and then you will do minus 1. That's it. Nothing else. So now if you see, your list has been printed in the reverse order. Just like when you were a kid, you were counting 100, 99, 98 in reverse order. Now if you see here, your list is 10, APC 22.5, you're starting opposite. How did it happen? That is important. So it is happening because of this 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4, this is 4, 5, 6. But if you see the reverse indexing, this is what? Minus 1, right? So tell me one thing, hold on. If I say 0 and then I don't say step size plus 1. If I do plus 1, I'll come into APC now. If I do plus 1, I'll come to 22.5 now. If I do plus 1, I'll come to 3 plus 5j, right? Now, guys, if I do plus 1, I go up forward. If I do step size minus 1, so I'll go where? There's nothing behind this, but there is. What is it? See here. Last, right? Right? And then if you do another minus 1, you'll go to another last, another minus 1. You're just taking a step backward. You have done when you were a kid, walking backward. Have you done it? Everybody does it. Why minus 100? Minus 100 is the reason that it is the last point, right? So see here, this is my list, minus 100. If you're starting from the last position, you will print it and then you will go, like this. Reverse means what? 10 is your first, 100 is your last. Reverse, you start with the 100, na? So this is not 100, minus 100. That's why it is coming minus 100. Okay. But start index is 0, right? No, not in this case. So what you have done, that's what I was trying to explain. Here, the catch is that when you write colon, colon, and then you write nothing or plus 1, it will start from 0. But the moment you write minus 1, so first thing first, it takes a step of minus 1, you go to the last. So that's the only thing which you have to keep in your head. So if you are writing plus 1, it will start from 10. If you're writing minus 1, it will start from minus 100. Can we go from BBC to reverse and come back till 3 plus 5j? Like how do you want to go? You want to go like this? Are you saying this? Why don't you try it? Take mine and try it out, sir. So you are saying colon, colon, minus 2. Yeah. And then you are doing minus 2. So it's correct now. So minus 1 will be here. Step minus 2 is here. But why you are not getting it everything? Because you are starting from 0. You're more like indexing it. Okay. Nothing like that. You cannot get a sequence out of it. Getting? That's the reason. So this list. So now understand, guys. Let me take. Why we are only seeing 10 into index, that slicing possible in reverse. See what you are trying to do, guys. My underscore list. Suppose, and you are saying that I should start from, let's say, anything, like you can say start from 2, and then you want to go till, let's say, minus 2, right? So you can see that. Let's try to decode it. No? Don't panic. So when you're trying to do that, from 2, so 2 is your 22.5, and then you want to go to minus 2. So guys, obviously it will do 3 plus 5j BBC, and it stops here. So also need to understand, if you're writing 0, 1, 2, 3, 4, 5, 6, this is minus 1, minus 2, right? And that's why when you write 2 to minus 2, so still it stops at minus 2, which is not including minus 2 means it will only include till BBC. Are you getting it? Look at the one which I've written here. So it's going forward, but it stops at BBC. Why? Because for it 10 is at minus 2. This is tricky. That's why you must not be getting it. Let me give another example. My list, if I start with 2 and I want to stop at BBC, how will I write? I want to start from 22.5, or maybe I can just keep the same example, right? If I want to start from APC and stop at BBC, what I'll write? In positive. Tell me. 1 to 5, right, guys? Both giving me the same result. Can you see it now? Both giving me same result. Why? Because 5 is equivalent to write minus 2. So you cannot be like, doing like combination of forward and backward slicing. You have to do it two different lists. Are you getting my point? It means you cannot be in like present and the past in both.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Okay. So we are done with indexing and slicing, guys, right? Let me talk about list as mutable and dynamic. So mutable and dynamic. Some of the guys must have seen X-Men. So X-Men movie talks about mutant, normal human being and mutant. So in that, if you remember, mutants are those, they have some different powers because of their genes got, the DNAs or genes got DNA, I think, got mutated. So they have a different personality trait in terms of power, in terms of behavior, right? So similarly, these guys like list, string, dictionary, we are also going to talk about whether they're mutable or not, right? So if you remember, there was one of the very good character which used to change the full body, like blue color character, Mystique. So similarly, right, you can also modify or you can change the list, but there will be some data type which cannot be, which cannot be done. Okay. So let me explain that. Okay. So maybe I'll take a simple example to explain it. That when I say mutable and immutable objects in Python, what do I mean by that? So list definitely is mutable, but before I get into that, mutable versus immutable object in Python. So I'm going to put that heading, guys. Mutable objects in Python. Okay. So write the first line. If the state of the object cannot change, after the object has been constructed, it is immutable. Right? That's my first point. If the state of the object can't change after the object has been constructed, it is immutable. For example, I'll continue. For example, strings, tuples, I've not taught you these, are immutable. Okay. Continue and write. If the state of the object can be modified, it is mutable. For example, list, definitely list, dictionary are mutable. I'm just taking example, quick example. List, dictionary are mutable. Okay. List, dictionary are mutable. we have to give you an idea that what I mean when I say that. Definition is fine, right? Let me take an example, a cool example to prove my point. Suppose I say that this is my list. I have a list, right, guys? And I need to find the index of the list, right? Somebody was asking me all the time that how to find the index for anything. Let's say I want to find the index for BBC. Hello? Somebody is asking that question, remember? So I said that I'll tell you later. So what is the index for the BBC? Definitely you can go and count, but you cannot be able to count in a big data, right? I mean, suppose you have a lot of data points. Can you go and count like you'll print the whole data on a piece of paper and then count? No, nobody does. Nobody does that, right? So here you can count that, oh, is it 0, 1, 2, 3, 4, right? But how will you find it? To find it, there is a function called list.index. So you have to give your list and you can put it. So what is your list name, guys? My list dot index. And there you will put the, which one you find the index for, which one you are trying to find it for, BBC, right? It should return 4. Can you see that, Rudra and everybody? It does return 4, right? This is cool. Now since you know that BBC doesn't make any sense, APC is like Akash Pushpacharan. What is BBC? So let's say I say it should be Rudra Patel, right? So I want to change my list. It has a mistake. So what I'll do, I'll go and put my index 4 and I'll say that it should be RP. RP is Rudra Patel, right? I'm just taking an example. So what will happen, the moment I say at this position, which is 4th position, it should update my list to what? From BBC to RP. That's what you're doing, guys. Update the 4th indexed position from BBC to RP. Are we saying the same thing, guys? Let's see, did it do? I think it will do. So suppose you want to now say, see, if you do this and you want to put something else, it will not work. Because you have to understand that, right? The square braces is used for indexing, and this is for it's more for function. Generally, function will always be start with the parenthesis. Okay. And for indexing, or filtering, slicing, you use square braces. Okay. When you are writing a function, you will be using parenthesis where you're trying to slice, dice, indexing, filtering, searching. You will be using square braces. Okay. Did you understand how to find the index? And then you modified it. So that was step 2. Step 2 is what? Update the value, which we did. Good. Now there can be a task which I feel, and I'll give you some amazing thing, and nobody thought about it. If you see here in my list, there are 2 10s. Can you see that? Yeah. Now coming back to that, there are 2 10s. Can you see that? Now, if I ask you that my list 10, right? This is something I'm searching. What do you expect, guys? Will you get the position for both the 10s, 0 and 5? I don't think so. Try. My list dot index. You have to do index, guys, and 10. You will only get the first one. First index in case of duplicate items, right? Suppose you have duplicate items. The list does allow duplicate items. You only get the first. So now I want to give you a task and you work on it. You think about it. Think how will you be able to think how to fetch all the index positions for duplicate items? Would be a good question, guys. List does not give you that, right? How will you find it? In a list, obviously in a list. Don't convert into a data frame and then you can find it. Generally, I do that. Okay. Now, let me give you some methods. Now there's a question that what is the difference between functions versus methods? Functions versus methods. What is it? So let me help you with that. So when we say functions, okay, so they are defined using, which I'll teach you, and I teach really good level of function using the def keyword. Remember I mentioned that define, def, define keyword followed by a function name. That's how you define a function. So function is defined like this by a function name, list of parameters. You give some arguments, some parameters in parenthesis like this, and a colon to indicate the start of the function. I'm giving a like a definition. Okay, that's my first point. So clear? This is what you say a function is. Now, how it is different from methods is that, see, function is something which we create a function, right? So generally they are user-defined function. Let me write another point. User-defined functions. Okay. Typically defined at the module level. I'll explain what you mean module level. Suppose you're writing a command, right? Or you're doing some applications, you're doing something. You will be, creating a function, a user-defined function at that level, which can be used generally in global sense, which can be used globally. So you can define a function, right, which can be used globally within the module. Suppose you are writing this is your notebook, right? You have defined a function here. You can use in this notebook any place, right? Cool. If you compare function with the method, right? Method is not something which you define, right? It is going to be part generally in list, right? You can also define that. I'm not saying you cannot define that, but methods are generally part of the classes and objects, right? Let me write that. So methods are also functions. You can use these interchangeably that are associated with objects or classes. Objects or classes. Okay. So now when you will be taught oops, right? I think I need to check on that oops is in part of the whole thing which I am going to teach. But generally, when you will be doing oops, you will see that, methods are coming there. Okay. And the scope wise, they are defined within the scope of a class. Okay. Using definitely the def keyword and a special parameter, which is your default parameter called self. Remember, guys, those who have done oops, those who have not done, they can ignore for now. But that's how it is, guys. Right? So definitely, both are same. I don't think you can use, right? The difference is that function can be used independently, right? Here it is going to be within the object and classes. So to conclude, so I can write in summary, if I have to write in summary, functions are standalone, if I can use this word, a standalone piece of code that can be called independently. While methods are functions that are associated with objects or classes and are called, so how will you call these methods? On instances of those classes. An instance means object. Object is an instance of, classes. So basically the whole idea is that how they are getting invoked, that defines whether it is a function or a method. Okay. List is a class. You understand list is a class. I'll show you how it is a class. Print type of my list. Remember, this gives you a class name. What is the class name? Can you see that? List is a class. Now, what is a class? What is an object? Right? That is not something we are going to do here. We will do it in oops. Okay, not here. So now if you see here, this is a class. So class will have methods or functions. List will have methods or functions. Methods, right? It's very, very simple, intuitive, right? I've written on the screen, right? So few things you have to just take at the merit. Okay. Now, when the lists have methods, then we are going to talk about quite a few methods, right? As simple as that. Find the length of the list, right? So what does this function does? It's very simple. It will use len, right? Now this is a method, right? We cannot generally length is we also call the function length. So I'm telling you that it's not like very hard and fast, right? But here, if you say length, you have written a method which is associated with the class list. And now if I say length of my list, it will give me what? 7. Why 7? Let me show you. It's 7 because you have how many elements there? Count on your finger. It is 7. Are we clear about the length method? You can say length also function. You can say speak loosely. So length gives you the total number of elements in a list. Okay. Now this is fine. Now I'll talk about next method, append versus append and concat. I hope these are another methods. So guys, in the list, we have quite a lot of methods. Let me show you. See here. All these are methods. All these are like classes. Okay. See, whenever you see double underscore, generally that is reserved for classes, right? Sometimes people also create object by this, but these are all like jargons for you. Forget about it. But these are the methods which we are going to talk about it, right? Especially append, extend. So let me do that. Now, if I talk about append, now append is very important part, right? Suppose you have two lists, you have two numbers list. I'm creating two numbers list, guys. In one, I'm putting all the odd numbers, okay, up to 10. And in another list, I'm putting, all the even numbers up to 10. Right? Now you tell me what does append does. So if I can give you the syntax for append. So this is it. And if I say, I have a list, right? And if I say append, and then if I go into it, can you see that? Append object to the end of the list. That's what I'm saying, right? It appends one list at the end of the other list, right? So guys, you can read the syntax documentation quickly like this, the way I have done. So what append does for you guys, you can take a list, right? So I've taken one list. Maybe I'll take my number, one list, append, and then within the parenthesis, I'll bring the other guy. Can you see that? Everybody, please pay attention. My number one is one list. My number two is another list. Can you see that? I'm picking one list and then calling this method append and bringing the other list. Now let's see what it does. See? Now you will see that my num1 has changed. Can you see that? But if you observe, it has, so what we are doing here, we are taking one of the numbers here. So there are two lists, okay? Everybody, please pay attention on the screen, line number 62. You have a list called my num1 and you have another list called my num2. Clear? Now, what you have done, you have taken this number 2 and appended with number 1. Okay? But there is something which you have to pay attention, right? There is some issue also. The output might not be, the way you might have thought that, I should get output like this. Here, what's happening when you're trying to append my num2 with my num1, can you see that you're getting a list getting appended to the whole list? Okay. Are you seeing the issue? This is an issue with the append. Can you see that there is an issue. You're appending the whole list only. You're not appending these values from the list. There's a difference. So what you're doing that within the list, you have these numbers, right? 1, 3, 5, 7, 9. And then you have not added a number called 0 to not like this. You have added a list there. Are you getting it? Right? And second thing, if you can see, and if you have observed, what are the two takeaways? Let me write. My num1 list changes after append. So original list is affected. So basically what we are saying, original list is affected. That answer your question, Bibit. Number two, append function or method add a list to the list, right? And maybe that's not the expected, or maybe that's what we don't need, right? Why do we need like this? So you might be looking out that, can I get something like this? Let me show you. My num1 and plus my num2. If I do that, and now since the list has been changed, right, because of that, can you see that this is the output is something you might be looking out for it, right, guys? Right, you wanted to bring these guys and be part of the first list. But the problem here is that this is not append. This function or method is known as, guys, I'll keep using function method interchangeably. Don't kill me for this. And there's no difference as well. This is not append. This is known as concat. Are you getting my point? So whenever you want to chain one list into other, that's the problem here. With the append, it does not work. With concatenation, it works. Everybody's clear on this. Now we have still not answered one of the question that why it was showing like this. The reason is that append method is used to add a single element, single item, single data point at the end of the list. You cannot add more than one. If you try, you will get weird answers like that. Are we clear? Only one value. Can you see that, my dear? Add a single. I'm going to also highlight it. So now to prove it that I am correct, what I'll do, I'll take any of my list one, right? So if you see my list one, you have these numbers 10, 20, 30, 40, 10, 20, 30, 40. In this, if you append Sachin Jersey number and you put 99, you will see that it is now not misbehaving. Is it correctly showing, guys? Can you see that? Just adding very nicely. So when you're trying to give a list to it, then it blindly takes the list and put it there, thinking this is one object for it, right? Understand now? For a Python, this is also like an object, and this is also like an object. So since append can only add one object at a time, one element at a time, it takes the whole thing as one and place it here. Why did it do? And what is the solution? So in this, to conclude, I talked about two things. One is that how to append one value to the list. You can use append. How to append a list to the list? Go for concatenation. I'm also making. So that's why I like Jupyter. Do you understand? And this will become my notes, right? So I'm writing, talking, right? So I hope this is fast, at the same time, very informative. There is one more alternative to you, and that is known as extend, right? Let's extend to extend. So guys, again, I'll say we have the two numbers. I don't want to keep writing a lot of list. So this is my number one, guys. See, odd numbers, and number two is even number. If you want to get the similar output which you are looking at, my number one can be extended with my number two. And this will be a loving form as well. Can you see that? It's exactly what concatenation does for you. Now the question to the group, and generally when I take interview, I ask this question, then if both extend and concatenation does the same thing, right? What are the key differences? Like what is the key difference between these two guys? Why we are having extend and and concatenation both? What is the key differences? Extend versus concatenation. Right? So first of all, concatenation is not a method altogether, it's an operation. Did you notice that I did not call any method there? But extend is a method, is a function. See, you use there what is an operation because you use the plus operator there, my dear. Come on. But extend is a method, number one difference. Concatenation does not affect the original list. But extend affects the original list, remember? Correct? These are the two key differences. If someone asks, you throw at them. Okay. Now, moving on, there's one more guy. So we have done what? Append, we have done concatenation, we have done extend. There's one more guy, and you cannot ignore him, and that's called insert. I think somebody mentioned that. These kind of question definitely I like. What is the role of insert? As the name suggests, right? As the name suggests, insert is like insert, right? You'll insert something at some position, right? So if you talk about the function itself, let me take a list, my list. This is my list. I want to insert something on this. So I'll say insert, and then this function says that you have to give the index and you have to insert the value which you want, right? That's what they're telling now. So insert, guys are telling, see, that give me a position and then insert. So I say insert at third and insert something weird like 999, and so that I can quickly see that. Now understand this. Third, 0, 1, 2, 3. This is the third position, guys. If I run this, see what happens. It has inserted exactly at the third position. Can you see that? So who was on the third? 3 plus 5j. He said that, dude, you shift here. I will come and now I will become third. Count 0, 1, 2, 3. Are you getting it, guys? But if you're excited that, okay, can I insert a list to a list, right? Suppose I say dot insert and I say at third position, insert another list, my num1. See? Now, do you notice that the list is already inserted here? So why I did that? So that I can show that if needed, you can also insert a list within the list at an index position. And there's no harm, right? Because see, read the documentation at an index position of your choice. There's no harm because, see, if you keep running, it will keep adding because that's how it works. Okay, without letting you know. Now, can you see that, guys? Why it is able to do? Because for Python, even a number 9999 is an object, and my num1 is also an object. You understand? Everything in Python is an object. So it doesn't differentiate that whether you are putting one value or you are putting the whole list. Are we clear? That's exactly what happened now. So what we have concluded, guys, we have completed append, we have completed concatenation, which is a simple operation. We have completed extend and insert. Are we comfortable? Then take some more methods related to deleting or removing list elements from in Python, right? So now we were like, adding, right? Adding element or data items to the list. Now I'll teach you how to delete things. So undo can be, maybe Diksha, you can take it like an undo here, but not really it's an undo. You are actually in another method you are doing. So you are not exactly going back. You are manually going back. Okay. Deleting or removing list elements in Python. So we can delete the list itself or delete the element or more than that elements, more than one from the list using below functions. Okay, let's talk about it. So this is my number one, right? Maybe I'm not happy with this list. I want to delete it. I can use the delete keyword to delete the whole list from the memory. It will not be in the memory, guys. It's gone. Let me show you. You will not be able to see that. Can you see that now anymore? As a matter of fact, delete can be used to delete any object in Python. It can be a data frame down the line. It can be a dictionary. It can be a list. It can be an array. Okay, are we clear? It's very simple, straightforward. Delete and give the space, and then you can delete it. As a matter of fact, delete can also be used using delete keyword. A single element can also be deleted, but you have to give the position. At a specific position can also be deleted. Guys, don't try to match my typing speed. Every morning I do the same, right? So now let's say in this list, I'll show you. Hold on. My list, I am not liking this nested list. Can you see that? Maybe it can be a bit confusing. What I can do, let's say I don't like 40. Okay. So what I can do, I can say delete my list 1, but you have to tell the position of 40. So you don't know the position of 40. So you can be smart. You can say dot index and say 40. Hello. Can you see that I'm chaining two commands here, right? This gives the index of 40 and then it delete that. Hello. See, guys, the first 40 is gone and it will only delete the first one in case the repeated. Deletes the first element if there are duplicates. Are we clear? What this function is doing to refresh your memory? This function tells you the position index of 40 and then you place it here and then deletes. Now this is like, okay, this is fine. You are deleting one element at a time. You know, all those things are okay. But what about, you know, I give you a homework that you have to try deleting using delete method multiple elements, right? That could be a good point of, right? Good exploration area, right? How to delete multiple items, right? Although there are other methods for deletion which I'm going to talk about, but you can take it as a task. You can take it as a homework to think about it. Okay. Now there are 3 more methods. Maybe I'll make it bold. There are 3 more methods for deletion: remove, pop, and clear. Right? Let's take one by one, my dear. Remove. What remove does? Removes the specific element. Remove removes the specific element. Okay. So now the question comes, what is that specific element then? List methods. Remove. Remove has parameters, right? So suppose I say my list dot remove. What is the syntax says? Remove, you have to give the first occurrence of the value. Can you see that? It gives you the first occurrence of the value. Okay. So let me give you a couple of pointers, guys. Remove methods takes a single element as an argument. Are we clear? Remove methods takes a single element as an argument. Argument is the same thing, the parameter. Okay. And then removes it from the list. Okay. And I'll do some formatting here so that it looks nice. Clear? If the element does not exist, it will throw an error. Okay. It can be possible, right? What element you're trying to, delete it. It's not there. So if the element does not exist, let me type. It throws what error? A value error. Okay. Let me show you this in action. Now, my list. This is my list, guys. Now, I want to remove. You have to give the specific element value. You have to give a name. You don't need to give the index. Suppose I want to remove BBC. It will do. See, gone. But if you think, can I also do this, sir? That if I give a list in that, so I want to remove 10, I want to remove 22.5, right? Can I do this? No, it cannot do this because it takes a single element. Okay, perfect. So I also make a commentary. Error came because remove takes only single element as argument. Perfect. Now you might be interested in deleting, which is not even present there. Let's say I want to delete, means remove, like XYZ. It's not there. It will throw in what error, guys? It should throw some error. Value error it threw. Can you guys see that? That's exactly I've written here. Value error. It is telling that X not in list. So that is all about remove. You might be interested in deleting by index, right? Right. This is you are deleting by value. You're putting the value and you are deleting it. If you want to delete by index, there's a method called pop. Understand? So what pop method does, guys? Pop method takes the index of the as the argument and deletes the element at that index and also returns the deleted value. Okay, deleted item. Let me show you that. Suppose this is my list. Now I want to delete APC. Maybe you don't like APC, so you want to delete it. Simple. So how will you delete it? You will say you go pop and you have to give the position. See, now APC is deleted and also it returns that which element has been deleted. Guys, follow me, right? So my list.pop, when I said one, what I mean here, at the first position, what is the element APC? It has been deleted, right? And it also returns the deleted item. It is returning that APC has been deleted. Now, if I print my list, you will see that APC is missing. Can you guys see that? Sometimes people will just write pop and they'll not give anything. So what is by default it does? By default, it deletes the last element. It pops the last element. If you're not giving any index, see minus 100 is gone. I have also written here if you have missed. If the index is not given, pop deletes the last by default. You can keep doing that. Suppose you run it again, then this will delete 10, right? Now comes the last one is clear. What if I have to delete all the 10? So I'll go back and run again my list. And where is my list? Yeah, here is my list. So guys, this is my list. Now there was a comment that if I want to just delete, okay, everything. So what it does, it flushes out all the elements from the list, but the list will still be there in the memory. So it will be an empty list. Let me show you. You can see that my list still exists, but it's an empty list now. Clear? So now there is a pro tip. Generally, I ask as an interview question. Then what is the difference between delete and clear? That's a pro tip for interview. What's the key difference then? Come on, guys. Delete deletes the list. Clear deletes the list. No. So again, there are few. You should always start with this if you want to impress your interviewer. That first of all, delete is not a method. Remember I mentioned, but a keyword in Python. So let me show you. Directory of keyword. Yeah, so let me show you. So these are some reserved keywords which you can see here, right? Okay. But if you want to really see all the Python list, I have a very good command here. See, can you see delete is a keyword, my dear? This function which I have quickly given you, import keyword, it gets you all the Python keywords which you might want to see. Hello? Right? Pass, raise, return, def, delete. Can you see the delete is a keyword in Python? Everybody, please pay attention. This is a syntax you can easily run later, all these things on your own. So again, someone like XYZ, they will get panic. What is this? You don't need to understand everything. Sometimes you can connect the dots when you are ahead of the dots. Looking backward, you can connect the dots. So these are the dots which I'm giving you. You can connect going forward. You cannot connect at this point. So you might, because I've not taught you what is a for loop, what are these things which you are seeing here, right? So have faith in me and keep going. So delete is a keyword, right? So I wanted to show you. So delete is not a method, but a keyword in Python. Let me complete this, which is used to delete objects or elements from a list. You remember, you can also delete element from the list or the entire list. Clear? However, clear, okay, not that clear. Clear the clear. Clear is a method in Python which is used to remove all elements from the list. You cannot remove one element. You have to remove the all elements, leaving an empty list. Okay? Perfect. So this is my list one. If I want to delete my list one specific element, right? So I'll go and say that delete position number 4. It will delete. Can you see that? Position number 4 is what? 0, 1, 2, 3, 4. Position number 4 is 10. So if you see that, if I print this list 1, you will see that 10 is gone. Can you see that there's no 10 here? Can you observe, my dear? Between 50 and 20, there was a 10. So gone. But in clear, suppose I say my list 1 dot clear, it doesn't take any argument. It just say that if you do that, this whole list is gonna be flushed out. Can you see that? Gone. That's the key difference. And the moment you see this parenthesis, I have only taught you just today that the moment you see parenthesis, it means it's a method. When you don't see any parenthesis, either it will be a reserved keyword or some operation, right? So I think it's a keyword, not an operation. Correct that if you have written up as an operation. But a keyword. Delete is a keyword, it's not an operation. Okay, good. So we have done the addition, deletion. What is next? Some ordering, like reversing the list can be one of the tasks. Reverse. Suppose this is my number 2 and I want to reverse the list. It's very simple, guys. You have to just take my number 2 dot reverse. Done. Now, if you print it again, you will see that it has been reversed. The first position becomes the last and the last position becomes the first. Is it clear? So reverses the order of the list. It is as good as saying that you have done a slicing. So it is as good as doing slicing. Okay. Then I'll talk about sorting. I think these were some sorting is what? Sorts the list in the ascending order. By default, it is ascending, but you can also sort it in ascending or descending order, like low to high and high to low. Suppose I take this new list, num list, and I want to give a jumble number so that you can see that it's not a pattern. 9, tell me numbers, guys. 17, 23, 99, 12, 11, 4, 6, 19, 101. Yeah. So this is the number list. Now, if you say num list sort, done. By default, it is ascending. You see that. Guys, can you see that it has been sorted? By default, it is ascending. I hope everybody knows ascending, descending, or you're also confused. Low to high. Okay. The same number list can also be sorted by descending order. For that, you have to reverse equal to true. So sorts in descending manner, high to low. Okay, let me show you this. Perfect. There's a question that if I say reverse equal to false, will it give me sorted? Yes, that will work. But this is like ascending. But ascending, you don't need to give any function, any parameter there. You can just not write anything, still it will work. But you can write reverse equal to false. It's redundant. You don't need to write actually. Okay. There's one more method, count. And then we are done for the list. There are a few things I'll teach more, but count. What does count does? Count return the occurrences of, it's not the length, don't confuse it with the length, of a specified element. How many times a guy has repeated in my list, right? Isn't it? So suppose I take my list, everything is gone. Okay. So I'll take a names. Okay. So Akash, Raj, tell me, Ajay. The most common name is what? Aman? Do you think Neha is the most common name? Rahul, yes. So I'll put Neha and Rahul multiple times, guys. Robin, not a very common name. Sachin. And then again, I'll put Neha and I'll put Rahul. Now you can clearly see that Rahul is coming how many times, guys? 3 times. Sorry. Neha is coming 3 times, Rahul is coming 2 times. Right? And now if I say names.count, that's the syntax, and you put that how many times Neha has come, you can see 3 times. How many times Rahul has come? You should get 2 times. Are you getting, guys? Okay. So how count is different from length? You should know that. Count counts it, right? So I think I need to reserve this. When I'll teach you function, I'll ask you to find duplicate item summary. So this is a task. You can take it for later because you're not ready with function, but you should be writing a function to show the frequency of each item in the list. Hello? Are you getting what I mean by that? It means that I should be showing that Akash has come how many times. So it should be like an output like this. Akash, like a dictionary, you can say. Like similarly, Neha came how many times, guys? 3 times. Rahul came how many times? Just give an example. So that kind of thing you will be expecting, right? So now you cannot do it because I'm talking about writing a function, which I have not taught it yet, but you can use some of your learning later. So these are the tasks I think you have to do it, okay? It's not that difficult, you can do it right away, but you need to do for loop and the function, okay?
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Okay, so I will talk about, list copies and identity operators. Now, let me talk about one list. It's a simple list from 1 to 10. And if I show you the identity of list 1, what is the address? It is 22331, 83360. Okay. If I take another list 2 and put the same content there, in terms of the data, can you see that? What will be the ID of this? Will it be same? No, it will be different ID. Right? So you need to understand these two lists are equal. So if I suppose I test it by doing an equality operator, it will return me true because of the values in it. But location wise, if you do the ID of list 1, it's not true, right? You can see that on the screen, guys. And the reason is that list 1 and list 2 are two different objects in the memory. Okay. Now, if I say x equal to 10 and y equal to 10, x equal to y is true. ID of x equal to ID of y. What do you guys think? It will also be true. Interesting, right? So ID of x and ID of y are the same. So what's going on? Very strange, no? Okay. So it's nothing to do with mutable, immutable. Now I'll move on to the next data type, guys, and that is strings. String is another important data type. Whenever you're writing any alphabets, right, that becomes your string. Sometimes people also combine alphabets with the number, that becomes your alphanumeric. That is also a string, right? That is we qualify as a string. So let's say if I talk about a very simple text, and that can be as simple as that. Welcome to basic Python course, right? You might have observed double quote there, guys. Hello, right? This double quote is required to create a string. That's important to understand it. If you want anything to convert it into a string, you have to do the double quote. Are you getting my point? Or single quote, right? See, class is what? String. You could have done the same thing with a single quote also. See? And here also, if I print the type of my underscore text, it will be string only. Guys, as a matter of fact, you can also put a number as a text. How can you do that? Nothing. You just go and put in double quote. My num text. If I print my num text, it will also look like a string. And I can show in class as well. See, 99 class string. Okay. In fact, I also created this string in the beginning, but I think you might not have observed this APC and BBC, right? These are not numbers, no? These are string. Can you see this double quotes? I think so. Right, isn't it? So now I'll talk about single, double, and triple quotes. Okay, so let me put the heading, guys. Single, double, and triple quotes. Okay. I think single and double you have already seen, but there are some issues which we need to explain to you guys. So if I talk about single line statement, it's very easy, right? Single line statement is what? So I can say my text again. I'm reusing my variable, guys. Today is the, let's say, 4th session on basic Python. Something I'm right. Can you see that I have taken a single quote, right? Same thing can be done with a double quote, and I'll make it my text one. This is good. Double quote. Okay. As a matter of fact, this can also be done by triple single quote. This is known as, guys, triple single quote. Can you see that? You might not have heard about it, right? If you see, none of them have given us the error. Everybody is okay. Generally in the interview, they ask that why do we need single, triple quote? See, all of these guys is working, right? Today is the first session, you are able to generate. The issue is not in this text. The issue is in here. Suppose I go and change the text and just make an apostrophe. Today class is, can I write, guys, going good? I'm just taking that liberty. But there is an issue. Can you see that, guys? See, I have to be really careful. The moment I try to do, can you see that there's an error? There is an error because Python is getting confused with single quote and with the apostrophe. This is a real problem, right? As a matter of fact, you can handle this by using a double quote. That's fine. And you can see that it works. Let me print and show you. Right? Today's class is going good. You can still see that apostrophe S. But there can be an issue in some other text, right? Where you are going to say that today class is going within double quote, you are writing great. Okay. So whenever you have double quote within double quote, you're still facing issue, right? You can see that, right? So in all these cases, you have to handle it with the concept of scaping behavior. So there's a concept called scaping behaviors. So what does it do? It says that wherever you see there is a character you want to scape, you will just put a backward slash. So now this double quote, you don't want it to confuse it, and then it will work. And you will see the double quote is coming. See, guys, are you getting or not? So guys, in Python, scaping mechanism is, to include special characters. It's not only for the double quotes or single quotes, it's for different special character as well. You can always use scaping behavior, right? By using a backward slash, right? Or backslash. Sometime you will be seeing me in Pandas using this R as a raw string, new line as a, followed by a new line character. So all those things are known as, different way of handling it. Scape character, I've just talked about it, right? I think this is what I would like to bold it because this is what I'm going to use as of now. But the others you can just keep in your back pocket and forget about it. I'll talk about it. Scape character is something we are going to discuss here. Okay. Now this is fine. This is fine. Sometimes people write multi-line statement. Can you see that? This is a multi-line statement. If I don't give this backslash, let me show you. If I don't give this backslash and then try to do, it will not print, right? It will not print it. Can you see that? It is taking very differently. So what it has done, it has just shown you the last line. Can you see that? Or as an output. Everybody observe this, right? But if you take this and give it a backslash, then it understand that, oh, there is a new line coming, right? And then if you see, it prints it, combining it. Can you see that? Although it's, first of all, I'm telling this because I am supposed to tell you all those, but we don't really need this much of these things here because see, our data science, we're not going to do text analytics much, right? So I don't want to spend a lot of time, on these data types, string or some other data. They're not very important, but I thought I should tell you this. New line, I think I can tell you not right away, because you might be thinking, what is new line? New line is very simple. Suppose I am writing hello world, right? I can write. So now the moment I write hello world like this, can you observe that I have inserted a new line? How to write a new line? You have to give a backslash with n. Always remember that, right? And these are some rules you have to remember or follow, right? Now we'll see that it has taken the same. Okay, let me show you differently first. If I say that hello world, it comes hello comma world, right? But I want world to be go in the next line. Then how will I make it happen like this? Okay. Now I'm thinking the last bit on the is the multiple line statement where the single quote comes like a magic. I'll show you. Suppose I'm writing, 3 lines. Can you see that? This is our Python class. It is going good. We are coding with the trainer. I hope you are coding with the trainer. Okay. If I run this, it's the same note I'm writing, assigning the whole sentences to my note. Can you guys see that? But it is throwing an error because you are changing the line without the quote and everything. So definitely not working out. Another good use of single triple quote is to manage the multi-line statement, guys. Now I'll show you how does it do. Okay, I'll copy and paste the same thing. You have to do nothing. You have to just start with 3 simple quote. Generally, when you're doing single quote or double quote and when you're in multi-line statements, right, it doesn't work. But if you do it with the help of single triple quote, you can manage multi-line statement like a boss. Let me show you that. And you'll be happy to see. Can you see that, guys? Although it is not a very flawless output. Can you see that? Python understand that you are writing in 3 lines, 3 stanzas. That's why it has introduced a new line to tell you later that it was in new line. Are you getting my point? Okay. Now I'll say couple of things, guys. I say my list. I want to compare something. My list, I say names of the students. So I'll say Rashmi. I say Shilpa, Shiva, right? And I'll say my text. So I'll say Rashmi, comma, Shilpa, comma, Shiva. Are we good, guys? I've created 2 data types, guys, if you're able to observe. One is list, one is string. Can you see that? See, within that list also we have a string. So don't get confused. But this is string data type. Now, if I find length of my list, what do you guys expect the output will be? It will be 3 because there are 3 names in the list, 3 elements in the list, right? 3 names in the list. That's why you see 3. Correct. But if I find length of my text, what do you guys expect there? 1. No, 20. So what it has done, it has counted the character, including the comma and spaces and everything, and then it's giving you. So what is your observation, guys? What is your observation? Observation is that same length function is returning 2 different types of output. According to the data types. Correct, guys? Same function exhibit different behaviors as per the data types. One is a string, one is a list. And this concept is known as what? Polymorphism. I might have talked about it earlier as well. Polymorphism means many forms of the same function. Many avatars of same function is polymorph. So I can take an example that a woman is like they take care of homes. Guys can also come here and say, yeah, we also take care of home, but that's bullshit. You guys don't care. I'm being including me. We cannot handle it. Okay. So guys can be like, oh, we are also there. No, we are not there anywhere. Okay. So we can't do that. Our polymorphism is unimorphism. Okay. Job is job, job is job. So women play a lot of characters, taking care of home, family. If they are working, they are going to be a 9 to 5 jobs or 9 to 9, I don't know. Down the line, kids. So definitely they have different roles to play. Guys' roles are always only one. Okay. So that's where you can take this analogy and relate it. Okay. Another important thing is that Python, right? If you look at let's say my text, see my text. And I think that if I go in the my text and try to slice it, index it, 0 means what? I'll get R. If I say 0 till 10 and I want to do two alternates, so you will get that R, S, M. Can you see that? It is working, guys. So you're getting alternate characters, right? Good. Let's say if you say that, oh no, I want to replace R with, so R's position with something else. Let's say I want to do APC. Then it will throw an error. And the reason lies in the concept that Python strings are immutable. Can you see that, guys? They cannot modify it. You have written the text, you have written in stone. You cannot change it. Are you feeling it, guys? Easy, right? So why did I do this? To show you so that you can observe and see. See, you are able to change the list. You can go and say in my list, I can replace Rashmi with Akash or somebody else, right? So that is possible, but here, no. That's how strings have been designed. Okay. They cannot be modified. Okay. Now coming to the different string methods, there are quite a lot. Quite means quite. Obviously, we don't need to do everything here. It's really tough to do also. Like, look at the methods, guys. Capitalize, center. You guys can. So when you're doing text mining, text analytics, I don't know if you have in your course curriculum, some of these functions will be super useful. But don't worry, there are some amazing libraries for doing text analytics. What is text analytics, by the way? But there are a lot of tools and technologies coming nowadays for text. NLTK is one of them. Spacey, my God, this is amazing. Spacey is one of them. Tell me, guys, Stanford also has, I remember, Stanford has an NLP module. You can also use certain transformers like Hugging Space, Hugging Face. Okay, what else? What else? What else? I'm just trying to recall. I think these are the ones which are coming to my mind. These are the libraries you might want to take a look when you're trying to do text analytics. Now let's talk about some important uses of it, right? So I think concatenation is very, very important even for string. I'll show you why I'm saying that. When I'll teach you pandas, I will be talking about it. There can be a column called SQID. So suppose you're ordering groceries on Blinkit or Zepto. So you have bought, SQ means item. This is your item. You have bought this item 1, 2, 3, 4, 5. Then you have a site ID, right? And that is, let's say, so suppose site is like a location. Suppose by the way, I live in Electronic City in Bangalore. So, you can say that my location is Electronic City. So the item will not come from, other part of the Bangalore, right? Suppose I ordered groceries, right? It will come from the nearby location. That's the location. And then can be the customer ID, which I also call cust ID. So this will be like Akash 007. Okay. This is the customer name. Are you getting, guys? Although I'm showing one record of the data, but there can be millions of records like this. Are you feeling it, guys? And sometimes to create a primary key, to create a custom primary key, we need to combine columns. Hello? Right? You might have done in SQL as well, right? In SQL, you don't combine, you don't concatenate, you just give the name of the columns, right? But in Pandas or somewhere else, you have to do that. So what you have to do, you have to take SQID, then you will say plus, double quote, and then you put a hyphen, then you put another plus, and you will say site ID. Can you see that? Then you again do the same. You're concatenating with a hyphen. Look at this, right? This is known as concatenation. Later on in Pandas, you'll be seeing something like this. So you have SQID, you have a site ID, you have a customer ID, and then you're creating a key as a last column. And then this key will look like what we have done. In Pandas, syntax will be a bit different, guys. Just to give you a teaser of it, this is how a Pandas syntax looks like for the same stuff. So you can see, right? I'm not going to code because I don't have a DF means data frame, primary key, SQID, concatenation with site ID with the customer ID. Later on, when I'll teach you Panda, I will do like in sleep. Don't worry. Now there are a few more behavior string which string takes very differently. For example, if you do x equal to 10, and then if you do x into 5, what will be the output, guys? Come on. X equal to 10, x into 5. It will be 50. If I say x equal to APC, and then I do the same, what do you think? It will be APC 5 times. Not error, it will repeat. So string has a different behavior altogether. Can you see that? Now, definitely there are a lot of string functions. I will show you some of them. Let me put here. Must know string functions, right? I believe upper and lower is something you should know because that's very easy, right? Upper, lower, and title. Okay, as some of the guys can already sense what I'm going to talk about. Uppercase, lowercase. Yeah. So suppose I take my string and I give a very different, right? Okay. If I do this, definitely this is not the right format. Okay. So I need to go into, come on, where is my string? Yeah. And I want to make it all caps. I'll do this upper, all caps. Right, guys? See, I can make all small. That will be lower. And I can also make a title. Title is like all proper. It's known as proper. Guys, I hope you're also coding like me. Copy, paste, copy, paste. Don't type like every time. Now this is like a proper format. Clear? This is easy. Upper, lower, title. That's it. Title is like your, right name. You always start with the first letter capital, then rest small, like that. Okay, very good. Now, guys, I'll move on to the split function of string. The split is, I always have felt that split is similar to text to column. Those who have used Excel, they know it. It is text to column using a delimiter. So remember, we had a primary key. Where is our primary key? Let's call this as primary key, guys. Primary key. As the name suggests, split means you have to split. This is your primary key. I want to split this key into 3 different columns. Possible? Opposite of it, right? So what I can do, I can say that I'll take this primary key and I want to split it basis the hyphen. See, are you getting now? You are getting a list of having 3 different data points can become your 3 different columns. So what you did, you use Python split function to split it into list of string. Can you see that? Okay, done. That is split. By using some special character, you can give the, like, you want to split on what? You have to give the separator. Okay. Maximum split, I have to tell you. So let's say maximum split is till how long you want to split. Sometimes people don't want to split, right? People don't want to split, let's say after this. I just want to split these two guys. So you can go and say that maximum split only 2, right? Sorry, my bad. 1. So now you can see that what it has done, it has only splitted you this SQ1, 2, 3, 4, 5. And the other guy is still a combined one. Can you see that? Because you are controlling the split here. You don't want to go beyond after one split. You are stopping here, right? Max split 1 is what? You just want to split once, right? But if you don't want to control it, you don't give as a syntax, right? You just ignore it. Make sense? Now it will split it SQ, then here, right? Can you see that it's working? Good. Now I'll talk about the new function called split. Strip is very important. Suppose I give you a text called greetings and it has a lot of spaces, right? So something like this. It's a weird. Can you see that? Something like that. Text is coming like this. This is weird. Possible, huh? In text, anything can be possible. Now, definitely this is not cool, right, guys? Does it look presentable? I don't think so. How we can fix it? Are we going to do and put, enter, enter, enter? No, let's not do like, let's not do like this. There's a function called strip, which is used to trim the white spaces. Can you see that? It removes the leading and trailing. It removes the leading. Leading is this space and trailing is this space. Leading and trailing spaces. Only the leading and trailing. Don't get confused. Left and right. Okay. So now you can use greetings and you can say dot strip and you're done. Okay. Now the question comes, how can I remove the middle spaces as well? Then for that, you have to go to the text analytics, right? Because you have to do some other functions as well. So one is stripping. Stripping gives you till here, right? So this definitely does not do anything for the middle spaces. So then there is a function called join. Join. So now for the same one, greetings. What does join do for you? Let me write one liner first. To join the words back together with a single space between them. And you can actually join anything. So for example, if I say join, right, something like this, and then I say dot join, right, you can put anything here with a single space or any other characters between them. You understand? It's not only has to be single space, if I recall correctly, or any other characters, or you can write any other operators. Okay. And sorry, why I'm saying operator, any other string separator. It can be a tab, it can be a colon, comma, all those things, right? Now, why I'm telling you this? Because I want to fix this middle issue, right? So what I'm going to do, first thing first, I will go to split it. See? Now, can you see that I have splitted it very successfully? Now, this is, let's say you have splitted it. Now, what you're going to do, you're going to say that now this splitted string in the list, I will join with a single white space. See? Right? You are joining with what? Joining with white space. Let me show you. You put a star here. Can you see that? You put this. Look at this. Are you feeling it, guys? Since we want to just join with a white space, I'll put a shift there and I'll join. Are you feeling it, guys? Move on. Let's say join. After join, I think we can talk about find. Find is also very useful function. Find. So what this Python find string, right? Python string find, what it does for you? It finds is used to find the index position. Index means position of a substring. Important, right? In a string. Okay. Maybe I can say a sentence. And guys, you don't need to type. I'm saving some time by copying, pasting few of the things. Right? Now, suppose I want to find that, where is my word all is coming? Or maybe I want to find where I've written guys, right? So how can I do that? I can say sentence dot, everything is very intuitive. Fine. I'll say guys. You understand? Guys. Then it will tell me that it is sitting at the 25th position. I know it's a little tough to count because of the characters, but it is correct. Okay. I think generally after find, I teach replace. So replace is also important. Find replace to we do in Excel also, no? So let's say we want to say that Python string replace function. Now, not only I'm going to find, I am also going to replace is used to create a new string by replacing some parts of the another string, right? Let's take the same thing. Suppose I say hello, the same sentence, and I want to replace dot replace. You need to first give the string, guys, and I want to replace it with what? How are you guys doing? How are you all doing today, right? Can I say that? So now it has done, it has replaced guys with the word all. Can you see that, guys? And there is a question from someone that what does it count? You can replace all and count now. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it tells you the starting character of all. So you're right. Right? Good. Connected. Okay. Guys, I'm done with string. There's nothing more which I want to do in string. Okay, cool. Dictionary. So dictionary is what? If you go to any dictionary, you will have something like this. So first of all, again, I'm telling another disclaimer that I'm not promoting any Oxford dictionary here. Okay, I'm not sponsoring anything. It's just an example I'm taking. Okay. So what is a dictionary? If you see this, in this dictionary, there's a word called dictatorship. So then against this key, you have a value, right, guys? Dictatorship is a word in the dictionary, and then you have the meaning for the dictionary. Sorry, meaning for dictatorship. So means what? You are looking at a key, and then what is the interpretation of it? So ideally, dictionary, the data type dictionary is also like a similar kind of characteristic they show, right? They have a sequence, it's a sequence data type and having key value pair. Now this key value pair has to be unique, okay? Has to be unique. It cannot have dictatorship coming 2 times. Are you getting my point? Right? No sense, right? If it is coming 2 times in a dictionary. So if I can give you some cool, quick bullet points, you can see here. So dictionary is Python implementation of an associative array, which is a data structure that is actually a key value pair. So you should focus on this. You can ignore the rest of the comments there or rest of the words. Generally, we'll be creating dictionary with curly braces, okay? Separated by comma, okay? Now, if I can give you an example of a dictionary, you can see this. This is a real example coming from Pulp. So Pulp is an optimization library in Python, Pulp optimization. And you will be seeing dictionary data type is being used extensively there. Let me show you. So there are some examples like production planning platform problem. So you'll be seeing that, there are, dictionary being used. Let me show you where. Can you see that? Maybe not this example. Or transportation problem. Yeah. So they're trying to. So this is an optimization. Those who know mathematical optimization, they will quickly identify. Pulp is the Python library to do optimization. You should definitely read about it if you're interested in optimization, guys. Can you see now? You are having a dictionary here. Supply is a dictionary. Demand is also in the form of a dictionary, guys. Are you able to observe this? It's all these are a dictionary data type. So why I'm showing you this? Because I want to prove or make a point that dictionary is a very extensively used data type after list. Okay. See here. So everything has a key and value. So A is a key and value is 1000. Can you see that? So this is key, this is value, KB. Another key value. All these are key, all these are values. Clear? So yeah, I think then I can give you a few more bullet points from my side. These are all simple. I have already talked about it. Okay, now let's get into the business. So suppose I create the same dictionary called supply. To create a dictionary, I have to use curly braces, guys, and then double quote A. Then I have to give a colon, and then I have to give some number. Suppose I want to give a number, I'll give a number. I can also give a string, by the way. And then B, I want to say 4000, curly braces close. Then this is a dictionary ready. So if I print it, see, if you want to really validate whether it is a dictionary or not, you can do that. I have taught you. Supply. Okay. It is a class dictionary. Now someone can say that, okay, can you fetch the keys of the dictionary? I need all the keys of the dictionary. Can you fetch in once? Yes, you can do that. How can you do that? Like this. You can say supply dot keys, and done. So these are your dictionary keys. Similarly, you can also find values of the dictionary, guys. Now you tell me, what are the values of the dictionary? 1000 and 4000, guys. Look at this example. I'm using the same example. So if I do supply dot values, it will give me values. Abrar keys can be also string. So not a problem. You can make this as a string. Let me show you differently. Not here. I'm taking a very weird example. These are the student names with their registration ID. Okay? REC. See? Does it work, buddy? But tell me one thing. Now I'll move on to my supply again. Now I'll go back to my dictionary supply and I'm going to do something. And now this can be a question you can ask. What if I do this? What happens? Now I'm duplicating. Can you see that? I'm trying to induce duplicate keys. What are they? A is coming duplicate 2 times, right? What will happen? Now you tell me, guys. What will happen? Whenever you are giving more values to a key, it will always update the dictionary with the latest value. Ideally, it should do. It did not do anything. Okay. So suppose this is your dictionary, supply is your dictionary, but suppose you want to find what is the value of B, right? You can do that by doing supply under double quote B. That you can do. So that we can access the value using the key. Okay. Now suppose you say that supply B, hold on, and I want to make it 10,000. This is possible. I just updated it, guys. Can you see that? Right? So now when we say dictionary immutable, it is in with regard to what? Only with the keys. You cannot mutate the keys. The values can be modified, can be updated. Okay? So don't get confused there. You cannot change the keys suddenly. Okay? So overall, if you want to put it in the set, I think since we are always talking about dictionary or any other data type with the values, so dictionary in Python are mutable. Okay. So let me make it very clear. I said immutable set only with the keys. So don't get confused. Okay. Dictionary in Python are mutable, but someone can, probe you on that. Can we update the keys also? No, you cannot do that. So let me write in bracket, only the values can be updated, which I have already shown, right? So that is something you have to be very careful when you say that. Okay. That is my whole intention. Let me highlight it. Yeah. Dictionary wise, I think we are good, guys. There are a few things which are like, time to time you will need it, but trust me, more than this, the format of the data type is important. We are going to create a lot of data in the form of dictionary. Other than that, we really don't use a lot of dictionary methods. Okay. To show you, you can take a look at your end, but I'm not going to talk about these. And some of them are very much similar to you. So dictionary, if you see, it also has a lot of methods here, splitting, string, more like a similar to string kind of behavior, right? This is dictionary only, no? I think so. This is dictionary. There's any update? I think these are the methods in dictionary. Yeah. So I'll give you some real world problem and then try to, tell you that, to solve this problem, we might need these functions, and then tell you what are these functions and then how we are going to use. That is going to be my approach. Are we aligned on that? I'll not be telling you functions name and start discussing that. I'll be telling you that on the way of solving that problem, I will make you learn few functions. Then on the other question, I'll tell you some more functions. Like that, we will learn. Currently, we were doing some functions right away like this because we really don't want to solve problem in each and every module. I will come back with this kind of learning on when I'll be somewhere around flow control structure and when I'll in Pandas. Okay. Okay.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
So tuple is another sequence data type. It is also an ordered collection of Python objects. So it will be indexed, right? Like what is at 0, what is at 1. Tuples are immutable, which means they cannot be modified once they are created. And to differentiate between tuple and list, you will be writing tuple within a square, within a parenthesis. So let me show you one. So my tuple is this, and this can be also heterogeneous, means you can put different data type within it. So you can put a float, you can put a string. Now let me show you. Can you see the difference, guys? It is within the parenthesis, right? If I would have put a square braces, it would have become a list, right? And able to observe this. This is something you should observe. Okay. Now, if you look at, let's say, if I say my tuple, and if I say what is that 0, you are not getting anything, right? See. So my tuple 0 gives me 1, which means I am able to do the indexing, correct? Let's say if I do -1, I should get the last element. What is the last element? 5 plus 4j. Clear? So definitely when you are able to do this, it means what? It is an ordered collection of elements or objects, right? Why it is ordered? Because you can do a numbering and you can access as per the numbering. It's not like jumbled up and unordered. Are we clear on this? Make sense? Now, when we are saying tuples are immutable, so basically we are saying that, can I go to position number 1 and change it to BBC, right? Can you see? It doesn't work like this, right? You might think that, will it work with the parenthesis? Why don't you try that? It will not. So that's the point, right? Means it is immutable. Okay. It cannot be modified. Okay. It is an ordered collection of objects. Now, generally people ask me that tuple is something I have not seen much. Why do we need tuple? So, tuple is really very helpful. And when I'll teach you for loop, I will be doing this. That in a for loop, tuple can be used to iterate over multiple elements simultaneously, right? So you can run a for loop over multiple elements simultaneously with the help of tuple. But this is just a statement. You won't understand much because you're not going to see an example which helps you understand. So for the time being, this just take it as like with the on the merit, right? That when I say that it is like this, you just say that, okay, we'll wait for the for loop, and so don't dwell too much on this statement now, but on the for loop, someone should remind me that, okay, I have to, illustrate this, that how tuple can be used in a for loop. That's my point. Make sense? Now there's a comment from Sign. Can tuple have duplicate items, right? So Sign, this is something you could quickly, you can also see, right? So you go there and you can put another APC and see that, does it take it? Simple. I think it should take. So it can contain duplicate items. Are we clear? I'm telling you, it's more or less similar to list. The only difference is that lists are generated using a square bracket and tuples are generated by a parenthesis. Okay. Now tuple does have some function. I see tuple will have, to be honest, tuple has very limited application, very limited function we should know about tuple. Maybe I can say that count is something you can just go through, but we don't need to go and do quite a lot of things there. So count, what count does for us? Count gives the count of the specified element, and index gives the index of the specified element, right? Let me show you. Suppose I say my tuple and I say APC, who will do dot count. Can you see that it has quickly counted that APC has come how many times? 2 times. And then if I say what is the index of APC, it will give the index of the first one, which is a general problem, right? We have been seeing this. Okay, so I think, trust me, this is all on the tuple. Now move on to the set. There's nothing much to talk about it. Sets, right? So set data type is something which you have already seen in your school days, I think class 11. So set is an unordered collection of data types or objects or elements in Python. It contains no duplicate elements. It should not have any duplicate elements. And it is mutable, iterable. Okay, let me show you. So these are the pointers you can read, you can go through, but let me create a set for. So let me create a set. So suppose I say set1 equal to, now the good news is that you can also create set using curly braces. So you can put the same things. You can put APC 7.2. It can also have, as a matter of fact, heterogeneous behavior. See. Now if you observe, I started with one APC or something like that, right? But the way set has picked it up, it has done them some kind of sorting. All the complex number, right, on the top, the string will go last. It's something which I don't know there's logic to it or not, but definitely it's not ordered, right? No, I did not put any duplicates there. Duplicates is something now I'll show you. So now if I put like, APC or I put number 1, right, or 7.0, I'm just repeating it. And then if I run it, it will take it. But what it will do in the background, it will remove the duplicates. That's correct. So here you can write, this is after removing duplicates. Make sense? Now it is unordered, means can I go and say that set 1, 0 value is what? You cannot do that. Set 1, if you look at set 1, 0, are you able to iterate it? Can you index it? No. Now let's create an empty set. And then what people do, even trainers do this mistake. They will say my set equal to curly braces, right? But if I show you print type of it, my set, it will become a dictionary. So that's the catch here. If you try to create an empty set by using curly braces, always remember that curly braces is for dictionary. Okay, you have to understand that. So let me write that. That precedence is for dictionary, right? It is not set for set. Although you can create set by using curly braces, that's fine. But you should know that curly braces is reserved for dictionary. Let me write. Square braces is list and parenthesis is tuple. Are we clear on this, guys? This is what we have learned, right? This is what we have learned so far. Okay. So then definitely this is not correct. This is not correct way to create an empty set. But how will you create an empty set then? So for that, you can use, again, I'll try my set equal to set. This is it. So the function is set. Now this is an empty set. See, empty set. And even if you do print type of my underscore set is class set. Okay, so let me, I was looking out for you. Who joined late today? Let me be, yeah, moving on. 1, 3, 5, 7. These are the numbers which I have created in set. See, class is set. So I put together, 4 numbers. Now let's say I want to add a number to it. So the syntax says that, nums dot add, and I will add 9. So now what will happen? Nums will have a number added to it, 9. Can you see that? So add is for single element. Okay, let me also show you the add an element, one element. Okay, and if you have already that element, it will not make any impact because it doesn't contain duplicates, right? Then alternatively we have update. So update is for, let's say, suppose you have another list of number. So I was saying that update is for a, like, suppose you have a number list, right? And I want to add more number, right? Means I want to add 11, I want to add 13, 15, 17, 19. This is a list. And I want to update my set by using this list. I can just do this. See, now my number has, the whole list is getting merged with it. Can you see that? Can I also do the same? Suppose I go there and I say nums.add and I'll put list there. Maybe I'll put 100 and 200, something like that. The moment I do that, it says that, you can unhashable type. Means you cannot actually pull a list into it and get it there. Can you see that, guys? Difference between add and update. Add adds one element, update updates more than one. Simple. Okay, now we have done the add. Let's try to also remove some of the guys. So suppose I want to remove an element from this set. Okay, I want to delete it. More like this. So there is a function called discard. So what discard does for you guys? It removes a specified element from a set if there is no such element present in the set. Discard does nothing and does not raise an error. This is really not good, that it doesn't give you any error. Raise an error. Let me show you. You have to just follow the code. You can later copy paste from the my notebook, or you can keep my note. So this is my number, guys. I want to remove the number 19, right? I want to remove the number 19. How can I do that? I think I can use this nums.discard. Okay. And I want to remove the number 19. I'll just go and say that number itself. Look at the syntax. Remove an element from a set if it is a member of the set. Member means it is in the set, right? If I remove it, guys, can you see that? Nums.discard, 19 is gone. But suddenly you say that you go, discard 99. 99 is not there. So the problem is that the code executes. Can you see that? The code executes, right? But you will not be able to see that where it was 19 was there or not, or you removed or not, right? It's really painful. On contrary, you also have another function which is known as remove. So this was discard, guys. The another function is called remove. Remove removes the specified element, also raises an error if it is not present. I'll show you. So nums, I'll say nums remove, and I'll say remove 13. 13 is not a lucky number. Okay, remove it. It is done, right? Now suppose I say remove 99, it will say hello, there's no 99. Key error, right? Can you see the key error means this is not found. Okay, there is one more that is known as pop. Remember, pop pops the element out, and if you don't give any position, it will pop the last element, right? You remember that? But here, since it is unordered, hold on. So here, pops just removes an arbitrary element from the set. You don't know which thing it will remove, and we cannot even determine that what has been removed. Let me show you. This is my nums. Now suppose I say pop, right? So remove and return an arbitrary set element. It doesn't tell you which one it will remove, but it will remove something. So it has removed 1. Can you see that? Now I'll print 1. Nums 1 is not to be found here. Can you see that? 1 is gone. That's what pop does for you. Pop does an arbitrary removal. So generally people don't use pop. Either we will use remove or we will use discard. That's it in set. Okay. But there can be a scenario that I want to remove multiple elements from a set. How to remove multiple elements from set? So far we were just removing one by one. I might be needing to remove multiple elements from the set. So for example, this is my nums and I want to remove 579. Remove nums. I'll create another set and I want to remove 5, 9, and maybe 11. Let's say, guys. Okay, pop you want me to repeat? See, delete. Pop is very simple. It removes an arbitrary element from the set. You cannot go there and say that, okay, you remove position number 7. You cannot do that. Right, sorry, the index number, whatever you want to put there, because it is unordered. So you cannot remove a number, an element, by specifically saying remove this one. It will only remove randomly, right? I think it removes the starting position. So it's an unordered. So you can try with some more. See, now I think, yeah, it is starting from the first and then deleting it. Guys, can you see that? So from the starting, it is going to delete. But does it give an option to set the index? No. Because indexing is not possible here. That's something you have to keep in mind. There's no indexing which can work here. Okay. See, pop works on index. Remember that in list I have talked about it. Okay. Now, if you're good, can we go to the next one? So this is my nums. Now I have removed already something. So I'll say I want to remove 9 and 11, 2 elements, and maybe 17 also, right? I want to remove all these 9, 11, 17. Okay. How will I remove it? Multiple elements. So there's a concept of taking difference of set or set difference. You must have done in your school days. Remember that A minus B. So what you will do, you will take num set and you will say the minus remove nums, right? You used to do that in your school days. So what you're taking a base set and subtract the remove underscore num set. That will give you the right answer. See, beautiful, right? So you're able to get the difference, means you will get the 7 and 15. Now, I'll go to the last topic on this, union, intersection, difference is already I have talked about, and equality. So these 4 are topics I'll complete. So I'll take 2 sets, guys. 2 sets. 1, 2, 3, 4. Please follow me. 5, 6, 7. Set A. I'll take another set. 1, 4, and 99 and 10. You can clearly see that 1, 4 is common. What is the difference between discard, pop, and remove? Okay. Now difference I'm going to talk about. Now guys, tell me, if I take this set A and this is my set B, and if I say that I'll take union of these two guys, union means what? It will give me combination of 2 sets, right? So can I say that A dot union B? You will observe that it has combined these guys and keeping a unique, all the unique ones. If there are duplicates, because see 1 and 4 is here as well, it is not repeating. That's union. I'll not talk much on this. That's it. Intersection is common. Remember that intersection is common. So suppose I take A dot intersection and then I have to run this again. You should also do that. Then only the common will come out. Okay. Difference. I'm being fast on these 4 because it is very intuitive. A dot difference B, right? See, only the uncommon has come, right? Which is not common. Can you see that? Except 1, 4, it has given the others, right? Equality you can also check. You know that these 2 sets are not equal, so it will throw an error. So if I say A equal to B, it will throw an error. False. Remove multiple elements, how only 2 elements, particularly 7, 15 remove without mentioning. We have mentioned it. You guys have missed it. Can you see that I have taken 9, 11, 17, right? These 3 guys I have removed. That's why 7, 9, 11, 15, 17. These were the numbers from my side. Hello? Everybody clear? 7, 9, 11, 15, 17. Then I said, remove this. Okay. To 9, 11, 17, I have done the minus here. See? So if you remove this, what you are getting, buddy? Mr. Dilip, did you understand? Difference means what? You will take the uncommon. The same thing I've done here, no? Just now. See, here also I've done difference. Yeah, these will not affect the You have to save it on a new set. That's correct. Now the last data type, and we are going to this, is Boolean. Boolean, I'll talk in 2 lines. Boolean is B for Boolean, B for binary, right? So, true or false, right? Mostly it is like that. Suppose I say A equal to APC, B equal to BBC. So if I say A equal to B, you get a something called false, right? This false is what? It's Boolean only, right? Boolean data type, correct? So Boolean data type has 2 values, 2 states, isn't it, guys? Either it will be true or it will be false, right? You can sometimes people relate it with 0 or 1 as well. Okay. So if I can make a commentary here, in Python, Boolean data type represents a binary value which can have one of 2 possible values, and that is true or false. Okay, that is the pointer on what is Boolean data type. Now, where do we use it? So let me write, Booleans are used to perform logical operations, make decision in control structure, which I'll teach you very soon, if else, for loop and all that, and evaluate the truth or falsity, truth or false of expressions, right? Just like we have checked one, right? That whether A is equal to B or not, it says false. Okay. Are we clear on this, guys? I've given a very simple 2 pointers. And it's not like that, oh, you have to always do A equal to B. You can also do, right, is it like 5 is greater than 3? Yes, true. All those kind of logical operation you can also run. Conditional you can run. So this is what comparison, right? Operators I'm going to talk to you after the break. Comparison operators, right? Okay. You can also think like logical operators. You can say that, true, false. You can also do an logical operations and or and all that. Print type, in which case can we get the output is Boolean data type. So you go and print it now. So suppose you can print here type class is Boolean. Can I see that? Operators in Python. What is your idea about it? My question is that what is an operator? Let's talk about first this. I know suddenly we will start taking example. What is an operator? That's my question. So guys, let me go to my Jamboard. I hope you can see that. So I'm going to give you the definition of operator. So an operator serves as the keyword or symbol, right? An operator serves as the keyword or symbol that are used to perform any operation. It doesn't need to have to be addition or assignment. So I take a very simple example. If I say 2 and 3, and I put a plus sign, and the output is 5, right, guys? If you look at this simple equations, right, can you see that? You have number 2 and 3, they are known as what? Number 2 and 3 are known as what? Operands. Might have heard this word, operand. Operands are those numbers or values or the keywords, right? Not keyword, numbers or values on which operation is going to happen. And this plus is what, guys? In this case, it is known as arithmetic operator. Are we clear, guys? And the name is addition operator. It is one of the arithmetic operators. The name is addition operator. So this is what you mean by operations. And this whole thing, so these are operators, operands, the whole thing can be put into a box, and this can be written as operation. You have done some operation. Make sense, guys? Now there are different types of operator we are going to study. What are they? Number 1, arithmetic operator. Number 2, logical operator. Number 3, comparison operator. Number 4, assignment operator. Number 5, membership operator. It's a big list, guys. Number 6, bitwise operator, not binary. You can say binary, but it is bitwise operator. And the last one, identity operator. Some of the guys you have already seen, but we'll see one by one, everybody. Okay. So this is the list of operator, guys, which we are going to talk about. Perfect. Number 1, at least I think we can do arithmetic operators. Should be very fast. Arithmetic operators. As the name suggests, you will do some arithmetic operations like multiplication, addition, subtraction, division, right? We have been doing it for the longest time, right? The moment you started, you got born, people started telling 1, 2, 3, right? So arithmetic operator is something a kid start with, right? Plus, minus, multiplication. These are the symbols, guys, we have to use. Hello? In that, I think most of the guys must be knowing this. What is an addition? What is a subtraction, multiplication, division? Let's talk about exponent. Exponent is also known as power. So like 2 into 2, 2 into 2 is 4. But if I do 2 into 2 into 2 means what? Bad example you've taken, Akash. I'll try again. If I write 3 into 2, it is what? 6. But if I write 3 into 2, it is what? 9. Now you understand? So exponentiation means power, right? Clear? Flow division. This is something people don't understand what is it. So I'll teach separately. Modulus is remainder. So suppose you divide 7 by 2. What is the remainder, guys? So modulus is as good as saying remainder. Are we clear? Now guys, let's talk about two-way decisions, right? So if you focus here, two-way decision is going to be with if-else. And if you focus here, guys, you will see that this is what I'm talking about. Suppose you are standing here. Suppose you are standing here and you have to decide whether you want to go this side or whether you want to go that side. And that will depend on the, criteria. That criteria outcome will decide whether you want to go left or you want to go right. Okay. So let's get into the syntax. Suppose I'll keep it very simple. Suppose you take an input X, okay, and there you say enter an integer. So this is your user input, guys. Code with me. And now we are saying that if X is less than 100, print it is less than 100. Okay. And now you have that option of else. If it is less than 100, you print less than 100. If it is not, you will write it is greater than or equal to 100. Can I say that, guys? And once you are done, you can say print done. Right? I think given the situation we are in these days, right? Given the situation we are in, Kohli missing the century, right? In the last match, definitely 100 is being talked about. So if you look at this, suppose he scored, I think 95, right? So you can definitely run this and say that, oh, he missed the century, right? Something like that, right? Less than 100. Perfect. So this is very simple. There's no rocket science and don't want to also confuse it, right? I want to keep it simple. Nested if else is this one. Okay. Now, if you come back to the second thing, which I am trying to say, nested if else statement. Now, why don't you guys try? I'll give you the conditions and see that can you write this? Okay. So you give it a thought and think that, how will you use this nested if else statement to solve this problem? So what is the condition we are talking about, guys? Check whether the number is greater than 100 or not. Okay. Leverage the above code, means this code, and add nested if else block Check if the number is less than 200 or more than equal to 200. Also check if it is more than 200, then it is less than, okay, got it. So the see here idea is, although I've written in a very raw language, what we are trying to do that, we're trying to compare the same thing, 100 versus 200, hello, versus 300. And you getting guys, that's the whole intention. Use user input, leverage the above code, and try to write nested if-else statement. So we'll copy and paste this code, okay? We'll save some time. Now I'll change this to greater than 100. I'll print greater than 100. And within this, I'll write another if-else. If x is less than 200, print less than 200, else print it is greater than or equal to 100, equal to 200, sorry. And else print less than or equal to 100. I think I am not doing 300 here, guys. But now let's see. If I do 102, it shows that greater than 100 and less than 200, which is correct. I think that's exactly Prabha you were also showing, right? I have not gone to 300, but you can add, right? So it will show both the boundaries, right? Now let me try something else. If I say 200, it says that greater than 200, which is also correct, and greater than or equal to 200, which is also correct. Okay, suppose I take 201, it says greater than 100, greater than or equal to 200. Okay, and if I take 99, it will show less than or equal to 100. Sorry, my bad. It should be less than. But I think you can modify it, and I think now you guys are champion. You can do anything. Okay. You can also contain it. You can also do the between condition as well. Okay. So guys, then you can try it out and you can extend it to 300 as well. That's fine. But let me show you that how does this nested if-else work. Let me show you, because that is important for you to focus. Now suppose I run this, I say 101. Now the moment I say 101, what happens guys, it goes and check this one, right? It checks that whether it is greater than 100k. If it is greater than 100, it will get inside this. Okay. See, it will print that greater than or equal to 100. If x is less than 200, which is correct, right? So you can see that it has entered this also. So what you can do, you can modify this to say, okay, it is, x is greater than 100, x is, let's say if it is 200, if I want to modify this, I can write a unidirectional greater than equal to 200. So you can say, but no, then this will, it will distort the whole idea. Now, since it has entered the nested if-else, guys can see that. So you can see it is coming as less than 200. It printed this part of the if, right? Let me show you something else. I'll run again, and then you observe. Suppose I say 202. Now, ideally, so if you see here, what is going to happen? Let's run it through your mind. This it will execute, then it was 202, definitely it will run this part of the block. Hello, yes or no? But it also knows that if x is greater than 100, it will print this, but this part it will not print. It will quickly jump to the else part. So in both the times, it entered the nested if-else, but in one, which I have just run, it went ahead and printed the if body, right? Body of the if. And here in this new iteration, I am going to print body of the else, correct? So you will observe that every time either you are going to print this body of the if or you are going to print the body of the else. You guys agree with me? You can never print both of them. This is the fundamental concept. And this is your nested if else. You have another outer if-else, which is this one, guys. Can you see that? This is your if-else, but it is outer if-else. So you can also say that nested if-else is more like inner if-else. Are you able to see that? What I'll do now, I'll copy this image and put it in a notebook so that you don't miss it. Now let me run that. So 200 submit, see, now it will get into this, it will print greater than or equal to 100. Now did you notice? It will check for this guy. Now you know that 202 is not less than 200. You are very sure that it will not go this part and do it. It will directly jump and print it. Let me show you that. See, now it has come directly here and it will print this. Can you see that? Let's move on to the next topic, which is now let's move on to the last bit, which is Python if-elif-else. Now, guys, I'm going to use if-elif statement, right? Where we are saying if-elif-else. Whenever we want to go more than two choices, more than two choices means it can be 3 or 100, you are going to use it, right? So, guys, what I'm showing on the screen is writing a program to give the season based on a month. And month number are 1 to 12. Can you see that? If the month is anything from 11, 12, 1, which is November, December, January, we call it winter. 2, 3 spring, 4, 5, 6 is summer, April, May, June. 7, 8 is rainy, July, August. 9, 10 is autumn. And then anything which you give like 13, 14, 200, it should show invalid month. Idea is very simple. You are going to use if, else if, which is we are calling it elif, and last else. That's the syntax. Okay, cool. So what we can do, we can try to do some error handling like I generally do. So although I have not taught you this yet, so I'm using a more like a looping statement. You can see while, and I'm saying that while it is true, more like infinitely, whenever till it is true, I'm going to add my block of the code within it. And I will also use, so I'm putting my name so that you don't get confused with a lot of answers. Enter the month between 1 to 12, right guys? Come on. And then I'll say if my month is in between 1 to 12 and both equal, see how I'm writing it, guys? See, between 1 to 12, and I'll use break. So this is another transfer statement. Else print invalid month. Please try again. Now this is going to be beautiful. Okay. You will see that. Now if I'm saying if month is equal to 11 or equal to 12 or equal to 1, I'm saying season is winter, right? Else if, now already I have this block, then I'm going to print and I'll use a formatting. I'll say the season for the month. Now you learn a couple of things here, and that is something I want you to read. These are known as format string. Is season C dot, and the only thing which I also need to do, guys, season is winter. Since I'm going to use my code a little differently, what you can do, you don't print it like this, because I have copy pasted this. I don't want to print here. I just want to assign here. That's the difference. So I'll assign here. Now what I'm going to do, I'm going to run this. Let me show you. If I use 10, the season for the month 10 is autumn. Can you see that? It is coming a little nice output, right? See, right? See. Now suppose you give a different month, then it doesn't just show you that, invalid month. It is still asking. Can you see that? Enter the month. Invalid month, it printed. please try again, and again it will keep asking you. This is now you're okay. Suppose you enter 14, then you enter some weird number, it will keep asking, it will not stop. It will never give up. It is an infinite loop till the time you put a right answer. Interesting?
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Python loops, okay? So looping statement is one of the most important functions, you can say, or the features in Python, I think, or any programming language. So without looping statement, I feel nothing can be done whenever you're trying to repeat any task which you want to do sequentially one by one. So you're not going to write multiple lines of code for every bit of the task, right? You generally tend to use for loop. So before we get into what is for loop and all, I always start with the question that why we need to use for loop. What is the reason for using for loop? Why do we need to use for loop? So I can give you some reasons, guys. Let me also write. Okay. Definitely number one is iterations. And whenever we want to do a definite iteration, definite is for loop, indefinite is while loop. Always know the difference. So whenever you know beforehand how many times you're going to run the loop, that's called definite iteration. Means you know how many times it will run. 50 times, 100 times, 1,000 times, right? And when we run this, control loop, right, to do some repetitive task, right, uh, definitely that's one of the most important use of for loop. It can be as simple as that. You want to do the cumulative sum of 50 students, right? Cumulative sum of 50 students' marks. So you will start with student 1, 2, his marks is 80, his marks is 90. So you'll keep going, right? Like 80 will be the first one, then 90 will add, it will become 170, then you will add 60, it becomes 230. So like that, you're going to repeat and also do some action. So you're not only iterating the marks scored by the students, you're trying to do a cumulative sum so that you can use it somewhere. So whenever you're sure that you know how many students you have, let's say your class has 100 students, you will run this for loop how many times, guys? You will run it for 100 times. Okay? To get the cumulative sum till the last student. And then you can divide by the number of students to reach a value called average marks, right? That could be one of the simple example for a definite iteration. Second important reason is why do we need a for loop is to reduce the code's complexity. Just imagine that you're writing multiple block of codes for repetitive tasks, right? So definitely it doesn't look good, doesn't look a clean code, and not also as per the best practices. So to maintain the clean code, right, clean code environment, right, where you don't want to write lengthy code or messy code, right, you will be needing for loop as a more like a tool for you. Whenever you want to run an iteration of repetitive task, you go and use for loop. When you don't know how many times it will run, you will use a while loop, right? So you do things in an efficient and clean manner, right? So let me give these pointers as a notes so that you can read through it. Then I also mentioned few things like, indexing and enumeration. So what I'm trying to say that for loop can provide access to the index or position, it's the same thing, of each item in a sequence, which can be useful for tracking the order of items, okay, or for reference. We might need to, refer later, which we can do that. Which I feel that is one of the other reasons we should use for loop. One more reason which is coming to my head is that you can also use for loop for searching and matching, right? It's not to do some mathematical computation. Always people think, oh, for loop is only for mathematical computation. It's not correct. It can also be used for to search specific element although not a very computationally good thing to do, but you might have to, or find patterns in the data. Think about textual data. So these are the few things which I am trying to highlight, guys. Okay. Why do we need for loop? Now, if I have to quickly define what is a for loop, I'll show you this definition block from the slide. A loop in Python or any other programming language which can iteratively execute a piece of code block till the time condition is being met. Okay, till the time condition is being met. Okay, so this looks little, this looks little not very much clear. So what I'll do, I'll get into my Jamboard and try to, outline this. See, we are talking about for loop. Okay. Always remember that when you are trying to do for loop, use for loop, you are going to talk about sequence. Always. So that's why we start by saying that for each element in sequence, for each element in sequence, you go within the element and you will ask this question that is this last element of the sequence? Is this last element of the sequence? That's a question mark, guys. And if the answer is no, then it will execute statement inside the loop. Now, the condition you're looking for is this one only. Is this the last element of the sequence? If it is no, it will execute the statement inside the loop. And my dear, please pay attention. This will keep going on. It will come back again, pick the next iteration, and again check it. That whether is this the last sequence or not. Until the time it is no, it will keep running. The moment it says yes, it is the last element. So you'll come on this side. Let's say this is yes. Then your for loop will end. Are we clear, guys? End of for loop. I'm writing here. This is the most simple for loop I have written. This is an example only. This box is for condition. Okay, you know, right? Decision making box. Okay, let me put this in the notes. Now, guys, I'll talk about the syntax. It's very simple, as you can see on the screen. And let's pay attention and get it right. For each element in the sequence, right? So you are writing for, that's your keyword. Element in sequence. In is also a keyword. This element can be also written as I, J, K, your name, my name. And then the sequence will be a data type. It can be a list, it can be a data frame, it can be a dictionary, anything. Then you're going to run the body of for loop. So let's also understand what is element. Element is the variable, I also call it iterator, that takes the value of item inside the sequence on each iteration. So basically what I'm trying to say here, that every time it will pick the element present in the sequence or item present in the sequence and keep iterating till the time the condition is being met. I'll show you. So let's say I is equal to 1, then it will pick 2, then it will pick 3, and so on and so forth. Then the second thing is that all the statements inside the body of the for loop, this is your body, right, will be executed, okay, with the same value of the iterator. Okay, suppose you are using some statement like element into 2. So it will take the element value for that particular iteration and multiply by 2. That's what we are saying in this line. Okay. The other thing which you can observe, my dear, is that there is indentation. Can you see that? There is 4 dot space or 4 white space, right? You have to follow that, just like you're following in the if-else. Last one is that loop continues until we reach the last item in the sequence. So that's how it works, okay? But you can control it. It's not the very standard thing that you have to go till the end of the world. You can stop somewhere in the middle also, but you have to put a condition to that. You have to subset your loop But end of the day, subset your sequence. End of the day, sequence what you plug in here, it will go and cover it till the end. Okay. Now what I'm going to do, I'm going to run a simple for loop. Let's do it. So I'm going to write the basic for loop. Okay. So I'm going to take my item as a nums, which is going to be a number 1, 2, 3, 4, 5. I'll not keep quite a few because then you get confused. Then for I in nums, okay, I'm going to just print I into 2. Clear, guys? What are you expecting from here? Before we run this, let's break it. That what are you expecting out of it? And you have to understand, right, what we're trying to say here. What's happening? What is this nums in our language of for loop? It's a sequence. But data type is what? List. Sequential data type, list. See, sequential data type is list, right? Then for I is your element, which we are talking about, guys, right? Remember, element in the sequence. And then what you are doing, you're going to execute this line of code, which actually says that take each element and multiply by 2. And then print it. Simple, right? And then print. Can you also observe that there is indentation of 4 white spaces? Perfect. Now, what is the expected output? You will take 1, multiply with 2, 2, 4, 6, 8, 10 will be the expected output. Right, guys? Come on. And if I just run this, you will observe that that is true. Correct, guys? First line of code, what it will do? It will create a global frame list. See, done. Then it will go in this iterator and it will pick I in nums. Now, since you've given the list as the sequence, it will pick the first. So I will be 1. See? Then it has gotten inside and it will print I into 2 on the top, you see. Then again it has come back here. And then the iteration, you can say that the counter will increase from here to here, right? Now it will pick 2. See, guys? Observe. 2 into 2, 4. Like, keep going like this. See? Till the time you're done, it will keep going like this. Okay? If the sequence is like millions of items, it will run million times. I'll be clear, guys. Now, guys, for loop is really interesting. But before we get into for loop, I need to, teach you, not really to teach because you have been taught. There's one more thing which you should know before you get into for loop. The depth of the for loop is range. I hope everybody has been taught range earlier, but if not, let me teach you now. Okay. So range is a very simple function which we have three parameters in the syntax, which gives you a sequence of number. You can give start, stop, and step. Start is your starting of the sequence. Stop is stop of the sequence. So suppose 1 to 100. One thing you should always keep in mind that stop is not included, right? And step is like you want to take 1 step, 2 step, 100 step. What is your step size, right? Let me show you with some example. If I say range 5, okay, then you will not be able to see what do you mean by range 5. Range 5 by default means stop 5. Stop 5. And 5 is not included. Always remember that 5 is not included. So what is included, guys? 5 minus 1. Always the last minus 1. So what is 5 minus 1, guys? 4. Till 4 you can get it. I'm writing this like a baby because people get confused. Now suppose you write next time range of 10. Don't say 4 is still 4 only. No. 10 minus 1. But how will you see this is definitely a sequence? Just do list of this guy. Then you will see that you have generated a number like Vikas is telling 0, 1, 2, 3, 4. Can you see that, my dear? So what range gave you? Range 0, range of 5. Range of 5 generates numbers from 0 to 4. But how many numbers are there, my dear? 5. Can you see that? Sometimes people say, oh, no, I need different step, right? So I'll say, okay, fine. You want to go till, 1 to 11, 10 numbers, but alternatively. See, step size 2 means what? Alternate, right? Every second. 3 means every third. Are we clear, guys? So range is very important in for loop, and that you will understand with this infographic. See, range can be used to also iterate. I'll show you. If you see this simple for loop for I in range of 5, so basically you are getting a sequence and it will start from 0, 1, 2, 3, 4. So if you observe on this cycle, 0 is your I equal to first iteration. Can you see this? Second iteration is I equal to 1. Third iteration is I equal to 2. Fourth is I3 and fifth is I4. Always remember that Python is always starting with 0. Keep in your head. Let me show you this. If I say for I in range of 5, and I just say that do I into 1, means you are printing square of I. Square of I is, you have just written a full function called square. Square of the number I is, I hope you can do all those things, like multiple print commas. Let me run. See, square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16. Did you see? Just using certain text in the print, I have made it a bit presentable. You agree, guys? Now a simple task. Let's do some question. So first question, guys. Print all the even numbers. Very simple question. Print all the even numbers from 0 till 100, both included, in a line. And use for loop. Sometimes this is not required that you will use you can use range also. So please use for loop. That's a condition. Okay, let me do it. This question has nothing to do with the for loop, but let me do it. See, definitely we'll use for loop I in range. Okay, and you can just use the logic. Okay, that you only pick the, every second item and then print it. Okay, but this is not the right way, because suppose if you're writing range 0 to 1012, then why do you need a for loop? You should do something where you have to use the logic. Okay, so what you have to do, you use modulo, and if you equal to 0, remainder is 0. So the idea is to use some logic here, and then you will say print I. Now, when you're trying to print I, this will also work. Yeah. So you can see that, guys, you must be getting this as an output, right? Correct? But I don't need this, right? I don't need this. For I in range 0, 1, 0, 1, 2. So what you are doing, guys, you are just doing this. So ideally, you have created your, you have created your sequence in that manner only. So there's no intelligence. Means you are already telling I'll pick 0 to 4, then go and print. So then why do you even need this? Then you just use the range and print it now. So if you're using for loop, I understand, but it's not still that good. So this is a better one, right? To use for loop and show some condition, some logic. So this is your some condition statement you have also used, and then you are going to use a command called end. So end by default is always set to new line. Okay, this is in print only, by the way. But if you give a space, then what it does, it set it to the space as the separator, not the new line as the separator. So let me talk about it little, so that you don't miss it. Don't miss it. The end parameter is really cool parameter in print. The end parameter in the print function is used to specify what character should be printed at the end of the printed text. Okay. By default, I'm just writing in my own English. End is set to what? End is set to the new line character. Remember new line character, guys? You don't need to type, I'm doing for you. This is your new line character, right? And you already know what it does. It will always put it to the new line, right? But if you are doing this, doing end equal to this, sets the end parameter to what? To a space character. So after printing, let me complete it. After printing each value of I, a space is added to separate the printed values. Are you getting, guys? You must have. I've written so much. Sorry for these, 2-3 lines, but this is important, guys. You cannot just write in one line and do justice. I'm just highlighting few things. Clear? And you can do a lot of things here, like you can say star and then do it. So after everything, it will be doing a star. And all those things you can handle. See that? If you don't want to give any space, it will be like this. Everything will come close. Space, big space, big space. So you can play around. Can you see that? See? I'm just doing something. But this is what I wanted. Okay. Now let's level up. Multiply two lists. This is my favorite question. So I'm giving you two lists and you have to multiply from. You know that. Already you know that. You have to just do it. I need you to give me this as an output. The name is outlist and I need this as the output. Multiply the given list. Okay. In this question, guys, if you focus, first you will create an outlist. So definitely you have two lists here. Outlist is going to be an empty list. Why I'm saying an empty list? Because you're going to fill it with you need to fill it with the product of the item by list. So I'll say for I in, if you do this, then the issue will be there. Sometimes people just try to remember things, right? But if you just do print I, it will only pick what number. Just do it and see, na? 1, 2, 3. But do you really need only 1, 2, 3 or you need something like this? So you have two lists, 1, 2, 3, and you have 2, 3, 6. So ideally at each iteration, so this is your I. When you go and pick 0, you want to not only pick this guy, you also want to pick this guy. Then only you can do the element-wise multiplication now. You also want to pick this guy and this guy, both of the guys. You want to pick this guy and this guy so that you can do cross multiplication across the list. Am I correct, guys? Right? So that's why writing list 1 is wrong, because it will just pick that list element. So what you have to do, you have to get the length of the list so that you know, right, how many elements within the list. And then you have to generate a sequence out of the length. So you will do range of that. And here you can take any list, list 1, list 2, because both the lists are going to have the same lengths. Let me do it. See, if I just write for I in list 1, it is going to give me what? List 1 values. Everybody is there so far? Because you are just focusing on list 1, right? You are being specific, list 1, right? Do we need only list 1? No. We need list 1 as well as list 2, I equal to 0 position. What is I equal to 0? 1. And what is list 2, I equal to 0? 2. Then only you will multiply and get it 2. So you not only need list 1, you need list 1, 0 position, list 2, 0 position. Are we clear? To get there, what we are suggesting here is that you don't generate list value. Don't put list value directly in the iterator. That's the way I'm trying to say. Don't put 1, 2, 3 here. You should rather put 0, 1, 2. This number can be 100, 200, and 300 also. Let me show you. I think I need to show you. This is the most tricky part, which I have. So let's say this is APC list. And I'm putting some big number so that you don't get confused. Now, suppose I say, everybody please pay attention. For I in list, sorry, APC list, and then I say I. And done. I have to print, else it will not be done. See, it is actually printing the list itself, right? I don't need to print the list. I want to do it differently. Why? I want to say that you don't print the list. You rather generate the sequence equivalent to list length. So I'll do the length. And then I'll generate the range of this. If I print 1, print I, then I will not get number this time. Why? Because length of APC list is what? 3. Range of 3 is 0, 1, 2. Everybody knows that. But you might be saying, no, Akash, but we wanted to print 100, 200, 300. So print it now. Who has stopped you? You just don't print like I. You go and make it dynamic. You say that I'll take the list and I'll place I there. It will give you the same answer, but now it is dynamic. You change the number. You say, I'll say 700. I'll say 900. You don't need to change the logic every time. See? And now you have another list. Let's say you have BBC list. Hold on. And here you are saying that, I'll do 10. 10. Everything I'll divide by 10. This will be 20. And this will be 50. Hold on. Just something I'm saying. Now, the good thing is that you can not only print I, you can also print BBC list this time. Are you feeling it, guys? See, every couplet is these two. First, you print 700, you print 10, right? Are you seeing that? You are printing the 0th position. You are printing the 900, then you are printing the 20. Now, since you are able to print these two guys, you can also do that. Print division of list, APC by BBC. And then you can go there and you can say, oh, this is very easy, Akash. I can do that. I'll just go there and I'll use this. See, this is the beauty of using this. See, are you getting it? Now you're also dividing these two guys. So you're actually doing 3 things, but you can say, why you want to do this can be to comment these 2 guys and now run it. See, now the question can be that length of the list can be different. No, you cannot do that if you're doing some operation like this. You have to maintain the length of the list. Okay, means you need, right, the same length. Okay, now I'll complete the original question, guys. I'll get back here. Maybe I'll just delete this because I wanted to first explain this and then maybe we can come here. Yeah, so I can say, forget about this. You can take 2 lists. Come back to our question, guys. Here you can say list. Okay, now the good thing is that you have a list. You will create a out list, which is my output list, which is going to be currently empty list, right? You're going to fill it. Then you will go into this, let's say, out list. And then you will use the function append coming from the list. And there you will go and pick list 1, I. Now you understand it. List 2, I. So you're going to multiply 0 with 0th value. And then you are going to output the list. So you can say print coming outside the for loop, multiplication of 2 lists is out list. Done. Now let me show this in visualize. Now guys, I'm going to create 2 lists. Done. See, list 1, list 2, right? Don't look at the add. Okay. Out list will be an empty list. See, coming as an empty list. Okay. Now look at that. Iterator will go and pick 1. So 1 is like your first position, which is 0th position in there. Right? See, I equal to 0. You should also focus here, my dear. You should focus here. Okay, all the time. I equal to 0. So, right, out list is filled with empty list. And now you should also focus here. Maybe I'll put a box here. See, now it is going to get updated. So my box is not that great. Fine. I'll make another box. Big box. This is too big. This is fine, right, guys? Now see. Then focus here. I will increase to 1. See? And the value is what? 6. How it is coming 6? 2 into 3 is 6. Focus I equal to 2. Now the value will be 18. Can you guys feel it? And now it is already done. It has taken everything, but still it is going back and check. Now you will observe that it will suddenly jump to here. Just focus on that. Okay. And here it comes. Did you notice? And then it will run that last command. Good. Because this is just one dimension for loop. I am going to do 3 dimensions. I will running 3 loops, 4 loops. You will not have any idea as of now. So be ready for that. Okay. Now I'm going to do a very simple question, guys. So the question is very simple. Calculate the average marks of 5 students scored in Python test. And these are the scores, which is I'm giving you as a list, right? And then you have to use the for loop to get me the average marks. So guys, you are not supposed to use some other function. You have to use the for loop only to get the average mark. So the idea is very simple. We'll start with the addition of each and every guy. 80 marks, then you will combine the second student, it becomes 170, then you'll pick this student. Finally, you have a sum total, you will divide by the length of the list. That's the logic I am expecting you to use. It's very simple, right? You have the Python test scores. Now, I'm going to also use the same kind of approach. Total marks first, I'll initialize with 0, right? So that it doesn't take any garbage value. Now, then I'll go into for mark. You can put anything. I also you can write for mark in Python test marks. Right? This is super easy. And you're going to take plus assignment operator. So total marks you will update equal to mark. Okay. Why? Because marks will be total marks is 0, then 0 plus 80, 80 plus 90, like that it will work. Okay. And if you don't believe me, so you can always add 2 print block before, right? And you can say print total marks. And then you can also write after, so that you can print these 2 guys after, updating. So this is after updating and this is before. Then the last step is very simple, guys. You can find average equal to what? Total marks divided by the length of the list, which is Python test marks. And then you can call this as, in the print, you can say average marks, average Python score is, and you can go and use average. See, guys, don't worry. This is intentionally I have done. That's how you're seeing. Now understand what's happening with the output. Please pay attention, guys. I'll not repeat. See, total marks is 0. So the Python will first quickly run the before. See, 0. Then the iterator will do what? It will say that using this line, total marks is going to get updated like this. Total marks is equal to total marks plus mark. Remember, guys, I have discussed this earlier as well. See, earlier it is 0. Now the iterator will give what is the value of mark? 80. So after updating, it should show 80. See, guys, can you see that? Again, when it goes to here, 80 plus 90 will become 170. Likewise. Are you able to follow, guys, the logic flow? And then what I have done, I have taken the total marks, which is the last value of this 443, divided by length of Python marks, which is this list 5. Answer is 88.6, right? Clear? Any doubt, any confusion on this? So I'll just comment it because the output should look a little nice, but you can always uncomment it and try to understand. We can do a question on this, sum of n natural numbers, and I'm giving the setting the context for this question. I think everybody knows that sum of n natural numbers can be easily done, right? Suppose you want to do 1 plus 2 plus 3 up to 100, you will go and use the formula this one, right? So 100 into 101 by 2. So answer is what? 50, 50 is the answer for this. I am asking you to write in Python the same formula, but without writing the formula. Are you getting? You're not allowed to use this formula as a direct formula. Then you have to do. Make sense? And n will be an user input. Okay. So you will be entering the value of n, right? And then it will give you the sum of consecutive natural numbers. Okay, so let me do one thing, guys. Let me do it for everybody here, right? This is a simple question. It's a very simple one. So this is not a very difficult one. Trust me on that. You have to just use int input. You have to enter the value of n, or maybe enter the positive integer n, right? And then what you will do, you will again do total equal to 0 for I in range. Okay, and you have to generate the sequence, right? So you'll do n plus 1. This is important. A lot of time people miss that. Suppose you want to do sum of 10, so you have to go till 11 so that you can get till 10, right? And then you will do the simple plus equal to I. Simple. And then you can do print sum of n natural numbers is total. Now this question is like what I have done is without any error handling, guys. Come on. Yes or no? There's no error handling being done. It is as you have done. Enter the positive integer and all those kind of things you can do like perfect. Now let's do error handling. Number one is so very easy. Error handling for positive integer and for positive integer and valid integer. Means people also give some alphanumeric character, right? You have to handle this as well. Okay, guys, moving on to the next bit, conditional for loop with if-else, right? This is going to be a combo of condition statement and the looping statement. So as the name suggests, it's very simple. You're going to use a for loop and you're also going to use a if-else block to test for any condition. If that condition is true, you are going to execute the block of code present inside the if block. If the else condition is true, you will go and execute the else block. So end of the day, you are going to iterate it, repeat the same step again and again. This is the condition. Make sense? So it's more like a switch, right? And the switch can be multi-switch. So either, have you seen a gearbox, right? So either you switch this side or that side, right? And then decision will happen. Make sense? If else, and then the iteration will happen. This circle represents iteration. So generally, I feel that this can be understood with a very simple use case of categorizing student grade, right? So let me take this as the example. So suppose, we have a list of 10 students, keeping simple. And we want and need to categorize into different grade as per the criteria below. Okay. Okay. So grade A, if you scored 90 plus. Grade B, if you score 80 to 90. Grade C, if you have scored 65 to 80. grade D 55 to 65. Okay, I'll make it. And then we have a F grade less than 55. Are we clear, guys? And grades are like this: 75, 40, 95, 88, 65, 52, 59, 82, 92, one more, 65. Actually, this should be also part of the question only, so it should come here. So let me give you my way of coding. Okay, and you can see that if it is going there or not. So guys, this is the list of student. We will start with the grades. Actually, this is not the grade, to be honest. This is your score, your marks, right? So marks of students in Python. Students in Python test. Clear, guys? I'll start with the marks. I'm changing the variable name. Now I'm going to put the criteria in a dictionary. So dictionary, and this is the standard way of doing things. Dictionary defining the grade criteria. Criteria can be changed anytime. So you will want to store it outside, not like hard code. Can you see this is being hard coded? So what I am going to do, I'm going to write a dictionary like this. So grade A, how I have defined, guys? If it is within, now I'm using a tuple. Can you see that? 90 to 100, C. So you learn a lot of things in this coding exercise. 80 to 89 is C. 65 to 79 is C, comma, you have to keep giving, guys. D is what? 55 to 64. And F is 0 to 54. Everybody is comfortable with the criteria? This is how I have mentioned in there, right, guys? Come on. When I said 90 plus this range, means what? This is exactly I have meant it. This is what I meant it, right? Now I'm going to also create an empty dictionary to store the grade categories, right? Okay, guys? To store the grade categories. So this can be simple dictionary name, grade categories with a curly braces, right? Now I'm going to what? I'm going to iterate through the marks. Then I'll also iterate through the criteria and then put some logic through it, right? So you are not only going to learn if else, you're going to learn also the nested for loop. Let me show you first. Iterate through the list of marks, which is on the top, guys. So I'll say for, then I have to go through marks. So I'll say mark, maybe score in the list marks. I'll pick one. Then for category, and this is your range, min score and max score. I'm naming it, guys. See, in your criteria, you have a min score and you have a max score, right, guys? Correct now? 90 to 100 is an interval, right? You have a min marks, you have a max marks, or max score, min score, how do you want to call it? In grade criteria. And you have to pick the items. Okay, so you should know what is the meaning of item. Let me show you separately. This is your dictionary, guys. Let me copy it as well. Run it. And if I say grade criteria dot item, you should understand what is going to give you. Actually, it's not item, it's items. Can you see that it is showing all the items? So it is printing the dictionary items, right? Values, keys. Keys is like the key, values, value, item is like combined pair, right? See that? It's a list of, in the form of tuple. We need items, and then we are going to put some condition, right? See, keys values is okay. Item is what? It's gives you like, all the items. Item will have key and the value as well. That is what I'm trying to say, Shrikant. Keys and values. Very good. Now, I'm going to go. Now you should understand if you are giving a multi-assignment here, right? So category, min score, So now you can put a logic around it. And the logic is very simple. If min score grade is more than the min score and less than equal to the max score, are you feeling it, guys? Then you will give the grade categories. In that, you will put that score and you will assign the category. Now, this you will not understand. I know I'm giving you some advanced coding here, but it's not a rocket science. Trust me on that. It's very easy. I'll explain and you will get it. I can promise. So first of all, don't think anything. Don't think anything and just focus, and then you will be able to digest it. And let me print the grade categories in the end, which I can also do in a separate block. You don't need to really write it here. Means in a separate cell, I can do it. Now let me show you how does this work. Yeah, see, but it's not coming correct. All are saying CCC. 75, 40, 95. It should not be. I'm taking 90 to 100. Just going through the code, guys. For score in marks, here, my score I have to compare, na? This will work now. See, guys, does it work? Clear, guys? I wrote something wrong here, na? Grade I wrote. Is it clear, guys? At least output is correct. I can see output is correct. Now let's understand this. First of all, do you like this code? This code is more modularized. This code is structured. You are not doing any hard coding. Do you agree with it? Criteria is separately stored. Marks is separately stored. You are creating an empty dictionary and filling it with the logic. Are we clear on this? I hope you should love it. Okay. Now let's understand this code very easy. Trust me, it's very, very simple code. My objective is that you will be writing some mind-boggling code down the line. So don't think this is the limit. This is the most simple code you are saying. Now I'll explain everything. That's why I'm coming to my Google Jamboard. So guys, first of all, this is very simple, right? Everybody should understand this. You cannot say I don't know this. What I have done here, I have created a dictionary to store the grade details, right? Grade criteria details. Simple. So grade is in the key and the criteria is in the values in the tuple, right? See, simple. This is like creating an empty dictionary. Nothing. You must be looking at that what you are doing here. So first of all, can you see that whenever you are looking one loop within the loop, this is known as what kind of loop? Nested for loop. So first of all, the example I have taken is the advanced one. The way I have solved it, it is nested for loop with conditional statement. That's the heading, guys. So actually, I did solve two objective with one example. Clear, guys? Nested for loop. Nested, if you have seen, nested for loop is similar to that. What's happening here, guys? You are starting with the outer loop. So this is your outer loop. Outer loop, you are picking what, my dear? You are saying that I'll take score from the list marks. So what it will do, score will iterate from 0. So first thing what it will assign score, 75 will be assigned to score. Arrow is opposite, guys. Sorry about it. Are you getting what I'm saying? Listen to me, guys. 75 is going to get assigned to score. Are we clear? Now what's going to happen? After the score is assigned, you are getting inside another loop. So then you will get into an inner loop. So let me place an inner loop. Hold on. So this is your outer loop. Within that, you have an inner loop, something like this. This inner loop is going to start with category, min score, max score. So it is doing multi-assignment, to be honest. Since grade criteria item is going to give you what? It is going to give you the keys A and the value is 90 to 100. 90 is min score. I'm taking with the first example. Max score is 100 and category is what? A. That's how it is deciding. Are you clear on this? How it is assigning? And remember, you had this grade, this. So category is being assigned to this min score and max score. So far, so good, guys. Are we clear on this? So now it is going to do what? It is going to check. So obviously it has all those details. So first it will go and take that. Is my score? What is the score you have tagged to this guy? Come on. 75. So is my score 75 is within 90 to 100 cap? No. Right? It will iterate now. First it will go where? 90 to 100. Then it will go where? Come on, tell me. 80 to 89. Then it will go where? 65 to 79. So it is going to go and check in this conditional statement. The first one, it will say, no, score is not between this. Why? Because score is 75. It is not there. Not there. Here it is, right? The moment the for loops conclude that it is here, then it will assign. What it will assign? In the dictionary, the empty dictionary, grade categories, it will go and assign first in the key. This is going to be a key 75. Listen to me. And the category, it will say what? C. Are we clear, guys? That's exactly we're looking at the output. C. 75 is C. Now, this is my way of explaining this code without getting help of any iterator or visualization. But what I've explained now, and then I'll go back and explain in that visualization tool, you will thank me. Okay, just hold on. Let me go there. And this is where you will feel like, wow, this is really good, Akash. This tool which you have introduced to us is really good. It is amazing. A situation like this is like amazing. Now, please don't look at these ads. Focus on our work. Now, see, I'm going to write next. See, the score has come. I'll go one, right? Now, criteria has been set. It is reading, guys. Right. Can you see that? I know it looks, the criteria has started a tuple. This is so amazing, right? A, B, C, D, E, F, 90 to 100 is a tuple. I mentioned that. Tuple also has 0, 1 position. See, now grade criteria will be an empty dictionary. See, it is saying here. Okay, cool. Now look at this. For score in marks, see, score picked 75. Everybody, please pay attention. 75. Now for category, min score, max score in grade criteria items, look at this. Now, did you notice, guys, it has picked A 90, 100 exactly the way I mentioned. Guys, so far so good. Can you see category A, min score 90 and 100? That's a way of assigning this. Now, you will observe that this particular arrow will keep dancing. Let me show you. It will keep dancing here only. See, till here it will keep going like this, like this, like this. Because inner loop has to complete it and break it before you go to the next one, right? So on that note, let me show you. Now what it will do, it will check for this criteria. See, it is going to run this if statement. Do you think it is going to satisfy? No. Again, it will go up. Again, check. The next guy will be what? P 80, 89. We know our is 75. Score is not changing. Also observe that. So obviously it will also not work. Now see, I'm going to take C, which is in this range. See, 65 to 79, 75 will sit. Now you will observe, my dear, is that this part of the code will run. It will go inside this, right? So let me show you. It will go and assign it. Can you see that? It entered now. This time it entered. Why? Because the criteria is satisfied. Now what it will do, look at this guy, grade category. It is going to fill the score. What is the score value? Come on, 75. What is the category value? C. You will see that it is coming there. See, somewhere it must have done it. Do you observe this, my dear? Are you feeling it exactly the way I explained? Now, keep running it. See, now 40 has been picked, right?
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Now, while loop. What is while loop? I've already mentioned it in the last class that there are two types of looping statement you will get to know. One is for loop, which you have covered it nicely. The second one is while loop. There are only two loops, okay? It is while do. So in Python, while do is, I think while do while, sorry, while do or do while. It is in C and JavaScript, right, guys? So it's a more like conditional for loop, which you have just seen here, right? So this is what you have written, and this example itself is an amazing example which we have done. Like we have written two for loops, right? Then checking a condition. So that's where some of the components of other programming language uh, is already been considered, right? For loop is a plain vanilla term, and then you can combine with different things, but still it is a for loop, right? Then we have in Python second thing, which is a different concept altogether, is while loop. So while loop, if I have to define, or if I have to do a comparison, for loop is mostly used when you have a predefined sequence, right? Like you have a list, you have a tuple, right? You have dictionary, and you want to iterate over each element within that sequence, right? But while loop is something when you want to just run a repeat or block of code indefinitely as long as a specific condition is true. Make sense? So till the time your condition is satisfied, it will keep running. So basically, I'm saying that if your condition is satisfied for infinite period of time, it will go into an infinite loop. So let me talk about while loop with an example, and syntax is more or less same. So I'm writing a program to display 100 natural numbers. So I'll say I equal to 1, starting from 1. Natural numbers, I hope no, right? Or anyone else, what is a natural number? Start from 1 till infinity. Positive integers. So 5, 6, 7 is natural number. No, you have to say positive integers starting from 1. Okay, what is composite number, guys? Composite. If it has two characters starting is same, right? CO. And being a parent and that one being engineer, you are wondering, right? And you guys are right. Composite numbers are those which has more than two factors, not two factors. Because for any number, there's going to be one is a factor and 5 itself is a factor. So two factor means everybody will be a composite number, but more than two factors is the concept. So see, it can be divided by 1, 2, 3, 6. How many factors it has? 4 factors. So keep brushing these things time to time. I know 100 natural numbers means 1 to 100, right? All the positive integers. So I'll start from I equal to 1. I'll say n is, less than equal to 10. So I'll say, sorry, 100, right? Less than equal to 100. And then I'll put a simple condition while I is less than equal to n. This is your condition checking that whether it is less than equal to n or not, and then it will keep printing forever, guys. And you can see that I have missed one thing, guys. What is it? I have missed it, guys. Let's not print, sometimes kernel you have to interrupt. Okay. Let's only print 10 natural numbers, guys, because I don't want to take the whole screen. Now, if you see what is happening, it has gone into an infinite loop, guys. Can you see that? This condition is always this I equal to 1 is always true. 1 is always less than equal to n. N is what? 10, no? So 1 is always less than equal to 10, which is always true. It will keep going like this. It's an infinite loop, guys. Now to tackle it, you have to just add one more line of code, and that's called increase the counter by I equal to I plus 1, and then magic will happen. I plus plus. Aparna is still in C mode, but yeah, you're right. Are we clear on this simple example? Everybody, give me a go ahead if you're good. Let me show you the flow diagram for a while loop. Okay, perfect. So guys, you will enter the loop. You will enter the loop, as you can see here. Then you're going to test the condition. So you will find whether the condition is true or false. If the condition is true, it will go and execute the body of while loop, and then the code goes back to again check the condition and keep doing it forever if the condition is satisfied forever. At one point, let's say the condition is false, right? Condition outcome comes as to be false, then the loop terminates. Are we clear? That's exactly what we have seen. Now, I'm going to give a very simple question and let's see who can apply the mind. It's a very good question and I have created this question on my own. And I think you'll love this question. So I'm going to give you three lists. Now I have given you three lists. What I expect you that give me all the valid combinations of A plus B plus C that gives you the sum total of 20. So what I'm saying, guys, one example I've given that if you take number 1 from list 1, number 4 from list 2, and number 15 from list 3, are you getting a sum total of 20? Hello? 1 plus 4 plus 15 is 20. I'm trying to ask you guys that can you search all the combination and then you print? Don't do it manually because this list can be really big also. How will you do it? And you're free to use. See, while loop generally we don't need to use a lot, but there are some amazing application of while loop we will see over the. Avrar, question is that you are given with three lists, right? List 1, list 2, list 3, and you have to pick A from list A is A, right? 1, 2, 3. List B, 2, 4, 6, 8. So you pick one element from here, list A, one element from list 2, list B, and one element from list C. And then combination you have to find that total 20 comes out. How many combinations will be there? See, it has 3 elements, it has 4 elements, and it has how many? 5. So total you are looking at 60 combination. Is it correct, guys? Guys, this much is basic. Everybody knows now. Sorry. Out of 60 combinations, you have to tell me all the combinations where the sum total is 20. And your output should also look like this in terms of presentation. Huh? Don't miss that point. Your output should look like this, guys. That's important. Do you understand that? What is this? 1 plus 4 plus 15. What is the sum total, Indrani? 20, right? So question is very simple that you have to give me all the valid combinations. So I think maybe you did not study PNC. So valid combinations are like invalid. I'll show you first. Suppose you pick 1 and you pick 2. Then how many combinations you're talking about? You can fill here 3, you can fill here 6, you can fill here 9, you can fill here 12, you can fill here 15. If you do the sum total, you'll realize that the number 1 is 6. This is same. Okay. Next one is 12. 3, 6, 9, 12, 15, and 18. Can you see that? None of these guys are coming to 20. So all these are invalid combination. Now you're getting, so you have to actually write a combinations of for loop, right? Then try see that. Okay. Simple. Your code is simple. Output is also correct. So if you look at that, it's a very simple blocks of lines of code, right? And very simply it has been written. You guys, can you see that? Now let me go back to my Jamboard. So see, you have 3 lists, right? List A, list B, and list C. It has some element, it has some element. I'm not going into that. How many? It has 3 elements, it has 4, it has 5 elements. Guys, you have A, you have B, you have C. And you want that sum total to be equal to 20, isn't it? This can also be dynamic. You can say that it is N, right? User input. Now tell me one thing, how the loops work, right? To get all the combinations, first the outer for loop, which I'll write, let's say outer loop, right? The most outer loop, what it will do, guys? Come on, tell me. It will pick A and set it to what? Let's say A is having 1. So 1 is going to be fixed, right? Isn't it, guys? Till the time the inner loop, so now we will go to the inner loop, which is your second for loop. That will be set to what, my dear? Look at your list. It is 2. So B is also fixed. Then you will go and take another inner loop, right? To pick the C. And now C is what? keep changing from 3, then it will go to 6, it will go to 9. Can you see that, guys? 12, 15. Till the time this is not done, these two guys will be fixed. Everybody is comfortable with this statement of mine. That's what you mean, like, nested for. It's going to be a nested for. You have an outer loop, then you have inner loop, then you have the most inner loop. Something I'm saying. Okay. Once this is done, then what will be done? Then this 2 will get updated again. Always like that. Then 2 will become what? 4. Then again the same thing will be done. Are you there? Then 6, again it will be done. And then 8, again it will be done. And once these two guys are done, right? Then what will happen? Then you will change this guy. It will become 2, right? Correct? So it will become 2. And then you will be picking number 2, 2, to be honest. And then again 3 to 15, right? Then it will be 2, 4, 3 to 15. Like that, the for loop will work. Okay. So visualizing this is not that easy, let me be honest. But I'm trying my best to visualize it, because you should know that the inner loop first complete, then the second out, the loop above it will complete, then the loop above will complete, and then you will change it, right? So now on this logic, and let me put it here, there in the screen. I know it's not very much nicely written, right? And now let me, code it, guys. So if you see here, right, this is my list. I think what I'll code only. There's nothing different I'll do. For IN, you'll pick list A only. For JN, list B. So you're just picking the numbers. And for KN, list C. And then you're gonna check if I plus J plus K equal to 20. It's a test, equality test. Then you're going to print, right? I have to just say I have to just say J. I have to just say K. Just I'm changing as per mine. If I plus J plus K equal to 20, it will work. Okay. Now let's see this in action. But do we have 4 combination? Who got this, by the way? See, this is very simple. Let me show this in action and let me know that you understand or not. This simple code, if you visualize, and let's visualize what I was trying to say. I equal to 1. I will not change now. Now everybody will focus on this only. This line of the code and this I. See, J is picked. Now if you see, only K will keep changing. Can you see that, my dear? If I can make a quick slow app, then you now J has changed. Can you see that, guys? See, J will change now. J changed, right? 2 to 4. Observe. Now 4 is picking. 1 is still fixed, right? That's how I was explaining. See? So that way you can make a small list and you can visualize it. See? Till the time J is all done, it will not move on to the I and change it. Now, after this step, see, I will change. I'm going to say change. Come on, yeah, change, right? 1 to 2. Can you see that, my dear? So that's the way you have to understand it. Means there's no other way, right, to talk about it. You have to go through these examples which I have given, these tools which I have provided. I have not created these tools, but definitely it will help you to understand more. Make sense? And then, guys, I'll also give you, I created a version of the same code by user input. So you can decide N, and then you'll get the combination. Can you see that? So now I said I need to find the sum total 15, right? 20, I got 4. 16, I got 4. 100, I got none, right? Minus 33, I would get none, right? Can you see that? It does work. 34, I did not get anything. 13, I still got 4, right? 17, I got 4. 38, I did not get anything. 12, I got 4. So I'm getting mostly 4 outputs, right? 6, I'll get only 1. I was just checking. The code is having some bug here. To the next topic, and that is transfer statements. So break, we are not talking about the break yet. We are talking about the break concept. Okay. So break is going to break the loop when execute it, right? So break is more like a keyword, and if you bring that break keyword, right, it will come out of the loop, right? And that sometimes it's very important that you stop at one point. So for example, right, you don't want to complete the whole execution of for loop. You want to break it, the loop, and in you tie it up to some conditions, right? Then it will happen. So for example, and this is going to be a very good example, guys, right? And then what I'm trying to say that I want to print all the numbers in the list, above list, which are below 100. Okay. So I want to do that. So to do what I'm going to do, I'm going to iterate through the list. Correct, guys? And I would say for I in nums, if I is less than equal to, sorry, above, greater than equal to 100, then break is a keyword. Sorry. Yeah. Else keep printing current number is I. And once you're done, come out of the for loop and print done. Now what this code will do? What does this code? What this code is going to do for us is that it will print. Can you see that it has printed 10? It has printed 20, 30, 40, 60, and after that it did not print anything. Can you still see that this number definitely is more than 100, but these guys are less than 100? Hello? But did you get an output there? You did not get that output, I guess. Can you see that? You got till 60. Why? Because once you have come out of the loop, you cannot go back in the loop because of the break. Are we clear on this? But some of the guys would say, no, no, this is not expected output. I would have wanted only 100 plus. You don't print, but you print everything. So for that, guys, you can do this. You can just simplify your code. You can just make it commented. And till the time the number is less than equal to, you can print. See, now you're able to print everything, right? But then we are not talking like this, right? Here we are talking about break. Break does terminate your for loop. Here we are not talking about termination of for loop. So this is a very generic for loop with no condition on termination. Can I say that, guys? The below for loop, hello? So you should know the difference. It's not only about expected output. You are not terminating anything. Here, this is your condition to come out of the loop, right? So what basically is happening, it will keep going and checking whether the number is more than 100 or not, right? The moment more number is equal to or more than 100, the break gets executed. Let me show this in action. So what I'm saying, guys, see, everybody will focus here. See here. Now, let me run it. See, the list has been created. It is going to pick the number. The first number it picked is I equal to 10. Now it's going to check whether I is more than 100 or not. Is it correct? 10 is more than 100 or no? No, right? That's why if you observe, this guy, the red cursor directly jumps to the print. It doesn't get inside. Keep doing that. One time you realize after 60, now I'll go a little slow. After 60, now it knows that 150 has come. 150 is more than 100, greater than or equal to 100. That's true. Then it will execute the break. The moment break is happening, the code is going to come out of the for loop, and that's why it is coming here. Can you see that? This is what break does for you. Now, definitely we'll talk about that. You wanted everything. And that's where you will have your another reserved keyword. Sorry. Another reserved keyword, and that is known as continue. 90, 99 are less than, also less than 100, because the code actually saw 150 already, na? So the break is done. Once break is applied, then the code will come out of the for loop. You cannot reverse it. But if you want to do it, right, this is known as do while in C. I'm making a comment. So this is similar to do while. Okay. Now, if you really want to just skip that particular guy, whenever you see it's more than 100, you are going to use the keyword called continue. So if you see the keyword continue, it is used to skip the block of code within the for loop for the current iterations only. Let me highlight this. For the current iteration only, and then continue with the next iteration. Let me show you. This is very simple. You will understand. Let me copy paste the same code. And here you replace break with continue. Okay. Now what it will do, guys, condition to not come out of the loop, condition to just skip the iteration, that to current iteration only, right? If the condition is satisfied. Definitely if the condition is met, is satisfied. Now you will expect an answer which you guys were generally expecting is this, right? Isn't it? That's what you wanted for, right? Only skip those guys who are more than or equal to 100. Even 100, if you write now, it will be skipped. Let me increase it. See, even 100 is skipped. Why? Because the condition is that if it is more than equal to 100 and it is able to print the last number as 7. Are we clear, guys, on this? Perfect, guys. And then we can quickly complete another one, which is pass. Right? Pass. Pass is similar to continue. Right? Means it basically does nothing, to be honest. Not even similar to continue. It's a null statement. Have you done a pass on something? Have you used this word in your English? I'll take a pass. What is the meaning of that phrase? I'll take a pass means what? Football lovers don't get in that pass. Okay. Let's be in literal sense, I'm asking. Right? I know there will be few football lovers, right? Generally, they give the pass, not take the pass. It means I've written already. It means I'll just skip it. Simple. Passport. Guys, are you trying to find all the keywords having the word pass? What's going on? Okay. Pass means in this context, null statement. Nothing happens when this gets executed. Suppose somebody offers you a job and you say, I'll pass. Means what? You don't change your status, right? You don't change your status quo. So if I give you a simple example that why we need a pass, right? In the same example, if I replace pass, break with pass, right? Can you see that? I've just done that. Okay. Guys, this is all about coding. You have to observe these patterns, which you have just done. Okay, on a lighter note, but let's come back to the original pass we're talking about. This pass, can you see that, guys? I have put it here. It basically nullifies the whole condition, right? Let me show you. It will print everything. So it's like you're giving a condition and then you are putting a pass. Means what? Your condition has no impact. You must have done with your parents, right? You must have taken that pass. You do this, you do that, you do this, you do that, and then you do what you want to do, right? That's, I feel like, nullifying the condition being put on us by our parents. Everybody has done it. Which generally in society we say disobeying your parents, which is a good thing. We should do that time to time. Okay. So the why do we need to have it, right? Is it like an organ in the body which does not have any function? You can say like that, but not it's not like it's like really waste. It has some uses. Let me give you an idea. Suppose you write a function, simple function. Suppose I want to do a square function, right? You know that you can do the square of x. And here you're writing a function called y equal to x into x. That's going to be square. And you return y, right? So if you run this function, my dear, and put a number 10, it will give you 100, right? Is it clear? What? This one, So I've written my own function quickly. Now, if I write a function, any function, x, y, z, right? And I say, so let's write a function like some function, cool function, cool ABC, right? And I put x. And then if I don't put anything, it will throw in syntax error. Guys, can you see that? So sometimes what people do, they use pass as a placeholder, right? You can use it as a stub. That's the meaning. So since this is going to throw an error, if you just place a pass, this line will be looking nice. Can you see that? Are you getting it, guys? More like a placeholder. I'll come back and complete my function, right? So the conceptually, if you see, you can use as a stub, which is basically a simple way of saying temporary code as a placeholder. That's one of the uses that everybody does with pass. Okay? But yeah, don't dwell too much on pass. You can also pass on the pass. Make sense? Or second option, who is coding at least alternate days. If you're doing alternate days, it will be gone if you just do coding like this, which is my first code I always write 2 plus 3, which is 5. If you think coding like this will survive, make you survive the whole situation, then you will definitely you're not going to be there. But if you are logical, you are thinking, your business knowledge is at par, ChatGPT cannot match that. Trust me on that. We are testing ChatGPT like anything as a company as well. It has a lot of flaws. So don't think ChatGPT is perfect. But definitely ChatGPT is very helpful. So it has increased our productivity of creating applications, right? It gives you a template of code which you can quickly modify or quickly ask questions that can be specifically answered. So take ChatGPT for those kind of utilities. So I'm going to highlight it in my notebook so that when you open this at some time, 7 days a week or alternate days, I'm going to write 1 hour. This will work for starter. Okay. Once you will get interested in coding, you will not be looking at time and everything. You will be just wired. Okay, guys. So that's from my side. Just took a step, or more like a deliberate step to motivate you guys a bit. Generally, I start this topic with a purpose. That why do we need a function? There has to be a purpose, right? Uh, that is one of the key. I would say generally, those who are not a very good coder, they tend to use less functions than a coder. They will be writing a lot of functions. Okay. So if you see that function is not some rocket science, it's just a wrapper around it, more like a outer layer. You put it, your components here, then you have another layer, you put another components here, and like that. So all these can be treated as function 1, function 2, function 3. And as for your requirement, you start getting into the functions which you need. Let's say you need F2, you will go for F2. You need function 3, you'll go for F3. But let's get into details of it at the micro level, that why we need function. So to make you understand, I'll take a real use case which we do all the time. So this is coming from my industry experience, right? So I work in supply chain. I have told you guys multiple times. When I'll teach you visualization and pandas, I generally use data called superstore. Okay, so this data superstore has a lot of columns. I'll show you some of the important key columns. So one is order date. Okay, then we have customer ID. I think superstore, everybody has been to some superstore, right? Guys, hypermarket, DMart, Dreammart, blah, 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 right? All these are superstores, right? You go there, you buy something. Let's say you buy some t-shirts or shoes, right? Anything up to you, like depends on who are you. And definitely, generally people nowadays buying online or offline. So let's say you are buying offline, you go to a store that, okay, today is 26th October, customer 01 bought like a Nike shoes, right? Definitely one, and let's say costed you 5500. Since it is one, so sales value is also 550. Okay. And then the same customer, right, on a different date, like 28th October, he bought, let's say, what you will buy more in that? Maybe some stationery item like notebooks. New Year is coming, new notebooks, right? And you bought 10, and every notebook costs 150, so 1500. Maybe 10 diaries you bought for the new year, something like that. I'm just making up the data, guys. Now, how does this data will translate for a sales department, right? So for every product, there's going to be a product ID. So then you will have an item master, another data called product master or item master. And there you have this information on the product, right? So you will take the same product, product one, right? Product description, weight, volume, right? All those things you will have it. Generally, people join tables, these tables. So this table can be joined on this column. Later on, I'll teach. Suppose you have a product ID here, you will be able to join on the basis of this column. You must have done in SQL, guys, isn't it? Similarly, we'll have also reason that is known as location master. Now, it's not like your DMart is only in your city, right? DMart, you know, Mr. Damani, a businessman and a stock investor, like share market. He's more like a legend there, right? Radha Krishnan Damani. Okay. So DMart, he owns the DMart. So obviously you will know, right? You know, what is the store, and you'll have the store number, let's say 001, 002, and you have all the details like which city the store is located, what is the address, what is the pin code, latitude, longitude, everything. Region, city means state and everything. Now suppose you are a more of a sales manager or sales VP, like your VP, sales VP, right? Vice President sales, right? Then these guys, they need some weekly reports. Okay. So they need weekly reports, how we are doing category wise. So the product will also have categories, guys. I missed to mention that categories, the most important column. So they need like category wise, what is my weekly sales? So there is a concept of wow. Anybody who's working in sales. So wow is what? It is known as week over week. That's a fancy, you can say, slang or acronym. And they need your week over week trend. So let's say this is your sitting in week 1, this is your week 2, so on. Let's say you are till here week 46. So then categories wise, you have to do how does the sales look like? This is one category. This is second category, like something like this. Just again, there are 3 categories I have shown. So red is one category, yellow is another category. Are you seeing, guys, monthly trend? And the blue is another category. Now this is week or week, right? And this is generally will be asked by, right, maybe one of the guys. But someone can also ask, okay, this is fine, Akash. Okay, give me month over month as well. And also give me quarter over quarter because quarterly meeting is happening, right? So generally meeting happens at different level, right? Weekly meeting, weekly report. Monthly meeting, monthly report. Quarter over quarter, like these guys will be like company owners. Generally, monthly, they'll not come and see, right? Every week, they'll not sit and monitor the sales. They will look quarterly. Maybe the company managing director or CEO, right? They might look at only monthly or quarterly. You might have to just generate the same chart month over month, quarter over quarter, and you might have to also do one more. There's one more, guys. What is that? YOY. You know this. What is that? Year over year, right? Forget about this. This is also like, year till date also, YTD we call, right? So there are a lot of time slicers you are looking at, right? Are you going to just write every time a new code to do this? Never ever. Then you are not a programmer. You are like a laborer. Always remember my word. It's harsh. Sometimes I say harsh words just to make you feel little bad, but I have an intention there. Don't ever do that. You should be smart enough. If they need you to, get these slicers like week, year, month, quarter, your code should be smart enough to handle it, right? You cannot go and code back again and again. And you're writing 10 codes for 10 different cuts. Never do that. Sales can also be asked like, okay, give me total sales. Give me average sales, right? Are you going to write another code for total, another code for average? Then again, you are not a good coder. Like you code, but you code inefficiently. That's the word. Okay. So that's where who is going to save you? And the hero name is, trust me, this is like the most important thing which people don't like to use because they think it's very tricky, complicated. No, it's very easy. And over the discussion, I'll make you feel like that. I'll take the same real example and do things in front of your eyes, and I'll make sure that you learn the way industry uses it, not like some square function, this function, bullshit functions. I don't do that. Okay. Because then I'm not doing a justice here, right? I should be coding a function, writing all the super intelligent function in front of you guys, so that you get a feel that, okay, this is something what industry uses. And this is what trainer has also talked about it. Right? That's where I justify my position. The kind of series or trend chart you say, right? Generally, you need to write a function on the time series data. So you're talking about time series data. Whenever there is a time, week, month, year over year, it's a time series data. Now, let's talk about function parameters. You must have seen, right? There are a lot of parameters in the function. I'll show you. A few of them I have shown already, a few of them syntax, right? So you have arguments, parameter, keywords, everything. For loosely speaking, everything is same. Now here, for this function of ours which I'm talking, I'm going to use one parameter as frequency. So frequency is like your chart is a WOW, or is it a month over month? Is it a quarter over quarter? Or is it a year over year? So if you give a keyword WOW, it will understand that you need what kind of chart? Week over week chart, right? Understand, that's the frequency. Weekly frequency, monthly, quarterly, year over year. Are we clear? Then someone can come and say that, okay, I want to select the measure. That is also my choice. I don't want to just create a chart only on sales. Someone can come and say, no, I not only want to find sales, total sales, I also want to find that how much cost I am incurring. How much is the revenue? Sales is revenue, guys. How much is my cost? How much is my margin? Right? How many quantity I have sold? Are you getting my point? Right? How much is my, yeah, you can say profit also, right? So total, you see that how many measures I have given. You can give a name and that chart will take care of it. Perfect. Now comes the aggregation. Like, you want to summarize your chart like what? Are you talking about, total sales, which is your sum? Are you talking about average? Are you talking about median? Right? I think let's keep it like this. Now tell me how many combinations of charts you're talking here. Here you are saying 4 measures. Here 1, 2, 3, 4, 5. And how many here? 3. Total, if you do the simple math, total 60 different types of chart you can just create by writing a one function. Isn't it powerful, my dear? This is what function. Why do we need functions? This is just the introduction. Now the question comes, are we going to do this? Exactly, yes. This function I'll write in the class, but at what point I'll write? When I will be able to, teach you aggregation and few things, okay? Aggregation, I can only teach you in Pandas. You understand, right? Everybody knows that Pandas is a library and aggregation can be only done there. So don't expect me doing this function in basic Python. I'll do something else, right? But that will be also amazing. But this is going to be the end game. This is what we are looking out for. Then when I'll teach you visualization, I will be using function to create charts, So you need a different chart for different. Suppose you wanted week over week trend chart, right? So you need to write a function and the function should be able to print that chart as well. You understand what I'm saying? So yearly chart will be different. The axis will change, right? The x-axis, right? The graph will be a different color. So all those things you can handle it. So what I'm saying, basically, I'll combine pandas with visualization, right? And then also combine with the functions. Are we clear, guys? So 3 pillars we have to combine to reach to this level. Are we clear on this? So you have to be patient. You have to be, wait it out and trust. Now function works on the principle of DRY, D-R-Y, which means it's a very famous word in the world of function. Do not repeat yourself. So whenever you're trying to, do a similar kind of activity, try to write a function to take care of it. It is different from for loop. For loop is also does repetitive thing, but it will keep, changing the way you're picking the, counter or you're picking the sequence, right? But Here, it's more like, doing different kinds of tasks, but can be grouped into one. You will be using that principle of dry. You're going to use it. I'm giving the commentary around it, that you can make your modular and small clean code, which can be written in form of function, and it can make your code looking more organized. And you don't need to hard code everything. You can actually go and change a function of way it works. And then definitely when you will call that function again, it will be updated, and you don't need to update the whole code, right? For that matter. So if you don't hard code, you try to use the principle of dry. It will help you to make your code better, improves your efficiency, and definitely reduces the error. And debugging is very easy. So you know that what function block is misbehaving, you can just go to that block and fix it rather than looking at the whole code. Are you getting my point? That's the importance of doing modularized code, right? So just like you form a building, right? So you have seen, right? People put pillars, right? Something like this, people do. So they know that, so if this part of the building is getting damaged, you'll focus on this part. You'll not focus on the whole building. So, right? So that's modular in nature, right? Then you put modules of slabs, right? I'm not an architect, but definitely you can always draw an analogy between making a building and using Python coding in terms of building blocks. Now, there are two types of function, guys. What are they? User-defined function and built-in function. So user-defined function is something which we will write. Built-in function you have been using for so long, right? So like length, print, input, int, like you're using so many Python functions already. Range, for loop is not a function, but yeah. So range is a function. You give a range, right? 10, it gives you a sequence till 10, excluding 10. So all those things you are already knowing. Now I'll quickly go to user-defined function, guys. I don't want to spend any time on built-in function. This is something you write as per your requirement, right? So let's talk about the syntax, guys. It's very easy. Let me show you on the Jamboard because I need to go and annotate a bit. So whenever you have to define a function, you will start with the keyword def. Can you see that def? So this is your keyword. Without this, you cannot define a function. Okay. So this def is helping you to declare or define a function. The function declaration. Then you definitely need to call something to the function. You cannot say function and then you don't know the name of the function. So this is your name of the function, which you can give. And there are some guidelines to give the name of the function you have to follow. Second thing is parameter. Like, these are optional, but sometimes these parameters are very important to, invoke the function. So you'll give the parameter 1, 2, or you can give 100 parameters. Nobody's stopping you. Then comes your return. So you will do, then comes your function body, my bad. Once you have given this function name, define the function, given the parameter, basis that you do something in the function, you do some work, some action, right? And once that's done, you will return the value of your interest, okay? So now I'll go back and I'll give you the commentary which I have just done in form of notes. You can go ahead and read and you'll understand. Okay, let me do a function. Then I think you will be having more ideas. So let me take a question. First function to add two numbers, right? Every bacha does this, right? Every kid does this. To add two numbers. Can we write a function to do it? Let's say I create a function called add, and then I give two numbers, A and B. Okay, you can also say generally number 1 and number 2. Okay. And then within that, first we'll print the number. So you can say first number is this, num1, print, second number is this, num2, and then you will do the addition. You will just create a variable called addition, num1. This is the most simplistic function, and you will return the addition, guys. Okay, perfect. This function is ready. So I'll store the result of this function, which is add. I'll give two numbers, 10 and 90. And then I'll use this result to print sum of two numbers is result. See, guys, does it work? We have defined the function means declare the function with the name, function name is add. Then I have taken two parameters, num1 and num2. Can you see that? And then we have this typical indentation. After colon, we have to give a four white spaces or a single tab. Automatically it picks up. If it is not picking up, you have to make sure it is picking up. Then I've done this some unnecessary, you can say irrelevant, means I'm printing the numbers so that I know that what are the numbers I have given. I've given, let's say 10 and 90, numbers are coming. Then what I'm doing is there addition. Addition is what? Simple addition of two numbers, and then I'm returning the value. Are we clear on this? So this num plus 1, num plus 2 will take these numbers, add it up, store in the variable addition, and then it returns after the function is complete. Are we clear so far, guys? Now what I'm doing to use this function, I'm just taking the output to, so this is the variable addition, guys, right? This variable addition 100 is assigned to result, and then I'm calling the result here to get the answer. Clear? This is our very basic function. Now, sometimes people say that do we have to put in parameter? Do we have to do a return? That's the best practices. But you can also write an addition function without doing these things. So I'll show you. Addition to, see, I did not give any parameter. Then I will put a user input. Can you see that? Enter the first number. Then you will say B equal to float of input of. You have seen this. This is user input. Don't get confused. This has nothing to do with the function. Enter the second number. And then I'll say total equal to A plus B. And I'll come out here and I'll write print sum of two given numbers. You can also call those numbers A and B here. Is, see, I'm not using return, my dear. Rather, I'm using print. Okay, now the moment I say add underscore to this, it asks number 1, number 2, and gives me the output. Did I use any parameter on return? Here, this print is acting as a proxy to return. Can you see that, guys? Don't use this. Means I don't, encourage writing code like this. You should write code like this on the top, what I've written. Perfect, guys. Can you let me scroll up? I have written this function without any parameters. I have written this function with parameters and return. This is what I suggest you guys to always follow. This is the best practices. I'm going to write it one line. Okay, now I open the forum for you guys. I'll give a question and then I'll open a forum for. So this is a question, guys, I'm giving as you have to do the swapping of the value. It's very famous question in function, right? So if you give a value 6, 9, your output should come 9, 6. If you give a value 3, 5, your value should come 5, 3. Like you have to swap the value. Okay, perfect. So you have to write a function.
Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course. Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course. So before we proceed with looking at how NumPy arrays perform better than Python list, let me tell you that I have written some codes that include the NumPy syntax as well. But you guys need not worry about it right now because I'll be covering each and everything in detail step by step. So starting with the very first difference is speed. Okay. So consider a scenario where we have a list, and what I'm going to do is I'm going to multiply this with a really large number. So what this basically means is 1, 2, 3, 4 is repeated these many times in this particular list. Alright. So now what I want to do is I want to multiply each and every element of my list with the number 2. Alright. So basically after the multiplication, what my list is going to look like is 2, 4, 6, 8, and then again 2, 4, 6, 8, basically 10,000 times. Alright? So this is what I want my final list to look like. Now, in order to implement this particular logic, what I will have to do is I will have to loop through my entire list and manually multiply each and every element with 2. Alright? Since I want to multiply it with the number 2. Now, this process is going to take some amount of time, right? And in order to calculate that time, I have written down some code for you guys. So over here, as you can see, I have imported the libraries, NumPy and time. Now, if you guys try to import the NumPy library directly, there is a high chance that you guys will get an error. So do not worry about it right now, because I will be telling you how to install it in your systems as well. So here you can see I have created my list and I have written my start time over here, and I have created a for loop where I am multiplying each and every element of my list with the number 2, and then finally I'm printing the amount of time that was required to perform this particular operation. Alright, so you can see over here it's around 1.13. Now, if I do the same operation on a NumPy array, over here you can see I have created np.array. Do not worry, we'll be discussing it later. So you can see the time taken for a NumPy array is just 0.03. Alright, so this is a huge difference. Now, if you guys are wondering why there is such a huge difference between the speed of NumPy arrays and the Python list, let me tell you, NumPy is built on C. Now, C is a low-level language. Okay, so whatever operations the C language performs are much faster compared to Python. Alright, so coming on to our next point, which is memory. Now, NumPy is considered more memory efficient. Okay, now why is that? Let's quickly look at an example and understand it. So now, in order to check the memory usage of Python lists and NumPy arrays, I have imported sys library, and this is my Python list and here is my NumPy array. Alright, so over here I'm going to get the size of my list, and over here I'm going to get the size of my array. Now if I run this, as you can see over here, my list size is 104 for these 5 elements, and my array size is 40, again for these 5 elements. So this is why NumPy arrays are considered more memory efficient as compared to Python lists. Okay, so far we have discussed speed and memory. Now another point is direct operation in NumPy arrays. Alright, so when we were discussing the code for speed difference between Python lists and NumPy arrays, you guys must have noticed that to perform the same operation on Python list, we had to write a for loop. Whereas in a NumPy array, all we had to do was write a one-line code, right? So this is another property of NumPy array, which is called direct operation, which is also known as vectorization. Alright, so let me just write it down over here. Okay, so as you can see over here, I have listed down some basic differences between Python lists and NumPy arrays. The first one is speed, which we have already discussed. So Python lists are slower compared to NumPy arrays, which is mainly because NumPy arrays are based on language C or built on language C. Alright, then we have data types. So Python list basically allows mixed data types. Alright, so you can create an array which has a number and say a letter, and then you can also have a string, and apart from that you can also have a float. Alright, and your list is going to work absolutely fine. But in case of a NumPy array, what's going to happen is all the elements are going to be converted to a string format. So let's quickly go ahead and check it out on our notebook. Alright, so let me create a list having different data types. So alright, now if I were to create an array and store it in a variable called arr, so you can see all the data types over here, being an integer, being a float, are converted into a string type, right? Because NumPy allows only same data type to be stored in a particular array. So the next one is memory efficient. So Python lists are comparatively less memory efficient as compared to NumPy array. We have already seen this. Then comes mathematical operations. So if you want to perform any sort of mathematical operations on our Python list, we will have to manually loop through them and then implement the operation on each element separately. Whereas NumPy arrays have something known as direct operations, which is also known as vectorization. Alright, so this is a very important property of NumPy arrays. Moving on to built-in functions. So Python lists have very limited built-in functions, whereas NumPy arrays have a lot of powerful tools, which we'll be looking into shortly. Alright. So let's get started with NumPy. So the very first thing you need to do is open any command prompt. It could be your terminal, it could be your normal command prompt. And all you have to do is run the command pip install NumPy. Okay. And when you run it, your NumPy library is going to get installed if it is not installed already. So once you have run the pip command to install NumPy on your systems, you can go to any notebook. I'm using Google Colab. You can use VS Code or Anaconda, Jupyter Notebook, any platform. And the first step that you need to perform is import the library that you have installed, saying import NumPy. Now you can leave it at that, import NumPy, but there's a common practice of using as NP, where as NP is nothing but your alias. So generally we import NumPy as NP, and then whenever we have to use the library, we just say NP dot. Okay, we just use NP instead of NumPy. So the very first basic step is creating a NumPy array. So first we'll be looking at the inbuilt functions, and then we'll see how we can create those arrays manually using np.array function. So we can just pass a list in that array. Okay, let me just go ahead and quickly create an array, np.array. Okay, so we'll be looking at the properties and how we can implement this in detail in the later stages. But before that, I want to make a few concepts clear for you guys, like dimensions and shape of an array. Okay, so this is somewhere most people face confusion and doubts. So let us go ahead and resolve this query first. Okay, so when we have a single number, this is basically something known as scalar, and it is going to have 0 dimensions. Okay, now if I have data that is spread across one direction, that is, if say I have 1, 2 and 3, now this is going to have a 1 dimension. Okay, but if I have data that is spread across rows and columns, that is in somewhat this way, maybe 1, 2, 3 and 4, 5, 6, this is known as 2-dimensional. Okay, so let us go ahead and check this. So if I were to check the dimension of my array that I just created, I will have to store it in a variable. Okay, and so now let me go ahead and, okay, so you can see the dimension of my array is 1 over here. But if my array looks something like, so you can see my dimension for this particular scalar element, scalar value is 0. Okay, now brackets in NumPy play a very important and major role. So whenever we're defining dimensions, we'll be creating arrays in the later stages. So I'm just going to give you a theoretical overview. So is basically, if we have a single bracket and elements inside it, it is going to be a 1 dimension. Okay, if we have 2 brackets, so this is going to be 2-dimensional. Okay, as the number of brackets increase, so do our dimensions. Okay, let us quickly go and check it. Okay, so let me just create empty arrays. Let me just initialize the arrays using brackets. Okay, so that you guys get a more clear idea. And I'm going to pass a single bracket. And then I'm going to check the dimension of my array. So it is the dimension is checked using this function ndim. Okay, so this is an inbuilt function. You just have to remember the syntax, that is ndim. Okay, okay, so there are no brackets over here. It's just ndim. Okay, so you can see there's 1 bracket and there's 1 dimension. If I increase the number of brackets here, okay, now let's run it. So my dimension is 2 now. Now if I further increase my brackets, the dimension is 3. I can add the brackets anywhere. Okay, it does not matter. Now my dimension is 4. Okay, so now it's up to you how you are defining the array, how you are, what's the shape of your array. Now if I go ahead and check the shape of my array, shape is nothing but that tells us the number of rows, the number of columns, Now over here our dimension is 4, so we are going to have data spread across 4 particular rows, right? So it's basically going to be a 4-dimensional space. So a 3D object looks like this, right? We had created this. So this is a 3-dimensional space. A 4-dimensional space would look something a little more different, a little more complex to draw right now. So basically this is how it's implemented. Now we'll move on to creating arrays using the inbuilt functions. Like the first one is going to be range. So basically whenever we have a list, okay, say I want to create a list containing elements 0 to 10. How would I do that? I can either manually write all the numbers like 0, 1, 2 and so on, right, till 10. Or I can go ahead and create a for loop. So I will say for I in range 10, and then I will just L dot append, okay, and I will insert my array. Okay, so this is what I would do for a list. But in order to avoid all these complex operations, I can directly go ahead and say np dot arrange, pass the range that is 0 to 10, and by default my step value is going to be 1, so I will not write anything and I just have to store it. Okay, so let's go ahead and see the practical demonstration or the hands-on demonstration of all these functions in our Google Colab notebook. All right. So the very first thing we're going to do is try to create a range of numbers, like a Python range. So let's say I want to create a range of numbers between 1 to 10. All right. And let's store it in a variable called range. So as you can see over here, I have a NumPy array with the elements 1 to 9. All right. So the last element, which is our stop element, is not included. And just like Python, we can also provide a step value. So say if I want to skip one value, so this is what my NumPy array is going to look like. All right. So this is basically the start. Let me just write it down here. Start, stop, and the step value. All right. So the start value is included, the stop value is never included, and the step value is basically telling us how many numbers to jump. Okay, by default it is 1. All right. So moving on to the next property of NumPy, it's called linspace. All right. So this helps us create evenly spaced numbers. All right. So say if I want to create an array with a specific number of values which are evenly spaced between two numbers. So say I want to create, so let's create an array np.linspace, and I want to create numbers or values between 0 and 1, and I want 5 values between them. All right. So let me print it as well. So see, I have values between 0 and 1 and they are evenly spaced, right? So 0, 0 0.25, 0 0.5, 0 0.75 and then 1. All right. So if I were to say I want 10 values, this is what my array would look like. Clear? So basically over here, we are giving the parameters of start, stop and a number of values between them. All right. So this was all about linspace. Moving on to the next property of NumPy array. So these are basically the inbuilt functions, all right? We can create different types of arrays using a range, linspace, and the next one that we have is log space. So the name itself suggests that this is something related to the log, right? So this is nothing but a logarithmic scale array, all right? So let me again store it in ARR itself. Okay, and I want my array to start from 10 to the power 1 and end at 10 to the power 3. And I want 3 points only. Alright. So basically what I'm telling here is 10 to the power 1 to 10 to the power 3. And how many values I want between these? Basically I want 3 points. Sorry. Not the number of values, the number of points. Okay. So let me just print. Yeah. So 10 to the power 1, 10 to the power 2 and 10 to the power 3. Alright, I'm getting 3 points. Now if I were to say I want 2 points over here, let me see how it would look like. So I would get only 2 values. Alright. So np.log space, let me just make it more clear for you guys. It's basically taking the starting, or you can say the starting power value, okay, the ending power value. Over here the start end are the powers, alright, these are the powers. And then our last parameter is going to be how evenly spaced you want the scale to be. So if I want 3 points on the scale, I'm going to get 3 values. If I want 2 points on my scale, I'm going to get 2 values, alright. So this is basically going to tell us the number of values again, alright. So I hope this was clear. So moving on to the next property, which is np dot zeros. Now what this is going to do is it is going to create an array full of zeros. Alright. So let's see how this is implemented. Okay. So let's say I want an array called ARR, which is full of zeros. So I can directly go ahead and create mp.zeros 5. Now what this 5 here is, it is going to tell me how many number of zeros I want in my array. So basically the size of my array is going to be 5. Alright, so let's print it here. Now this is basically just one line of elements, right? Okay, so another great use of NumPy arrays is that they are used for creating a matrix, which is nothing but rows and columns. Alright, so if I want to create an array which is full of zeros, but I want 2 rows and 3 columns of these zeros. So this is what I'm going to do. Alright, so basically over here I have 2 rows and 3 columns. Okay, so as you can see over here, these are my 2 rows. This is my row 1, this is my row 2, this is my column 1, this is my column 2, and this is my column 3. Alright, so when I defined in the np.zeros parameter 2, 3, what I meant was 2 rows and 3 columns. Alright, so you can create 2D, 3D, 4D, any number of dimensional arrays using NumPy. Alright, say if I were to say 5, I'm giving random dimensions over here. So here, this is how my array would look like. Alright, so NumPy is never going to raise an error. How many dimensions you want, you can give the parameter over here. For now, we'll just keep it limited to 2, 3, which is practical enough, right? So similar to np.zeros, we have another NumPy property, which is np.ones. So you guys must have gotten a basic idea. Similar to np.zeros, we have np.ones, which is basically nothing but instead of zeros, we're going to have ones in our array. Alright. So whenever we want to create an array where all the values are 1, we can use this particular function. So I'm going to create an array having the dimension of 4, 2. Alright, and I can also decide a data type. Alright, so if I want to give a data type over here, okay, and I want my data type to be an integer, so here you can see. But if I do not write this particular argument or parameter, by default my array is going to be a float, as you could see over here as well. Alright, so we can write, let me just comment. Similarly, this is something array full of array. So previously we saw how we could create an array which was full of zeros or ones. But now we can create an array having a value of our choice. Okay. So now over here similarly what we were doing earlier, maybe I want to create an array having 10 elements and my default value is going to be 2. Alright. So instead of np I wrote arr by mistake. So that's why I was getting the error. So let's print it here. So I have 10 values of 2. Alright. Now if I want to create a 2D array, I would simply say np.full and I would pass the dimensions say 2, 4. And I would have to pass this in a square bracket because I also want to pass a default value, which is going to be 7 in this case. So my code looks neat and it's easy to understand also right now. Alright. So if I print it, here I have 2, 4. So 2 rows and 4 columns of the default value 7. I can pass another value here, maybe 7.1. Yeah, so 7.1. No error. Smooth and easy. All right. So let me just write it down to you guys. So it takes the parameters of row, column, and a default value. All right. So moving on to the next function is np.empty. So this is basically an uninitialized array. Okay. So whenever you want to create an array without setting any sort of values, so you can simply use np.empty. All right. So let me store it in a variable called arr again. You guys can go ahead and create different variables, but I'm too lazy to do that, so I'm just going to use arr over and over. So over here in my empty brackets, I'm simply going to pass the dimensions, which is 2, 3. Alright. So let me just print it. So basically it's an uninitialized array. This is not np.zeros. This is an uninitialized array. Okay. Basically there are no elements over here. So this method is basically faster, but it's not safe unless you're going to override these particular values. Alright. So whenever you want to override these values later on in the later stages, this method is pretty good to go because it's really fast. Alright. So moving on to the next function, which is np.random.rand. Now this function is going to generate random floats. Now floats are basically going to range from 0 to 1. Alright. So, and these are going to be uniformly distributed. Alright. So I just have to pass my dimensions. Say I want to generate 10 random floats between 0 to 1. Let me print it as well here. So I have 10 random floats between 0 and 1. Okay, and they're going to be uniformly distributed. Let me try another one using np.random.rand, and my dimensions are going to be 2, 3. Okay, so this square brackets is not required over here because instead of dimensions, the np.random.rand function is considering it as a list. So make sure you pass these dimensions without any square brackets, okay? Since it's not taking any default value or no third parameter, we are not going to use square brackets for these particular dimensions here. Alright, so here I have 2 rows and 3 columns, as you can see. 3 columns and 2 rows. Alright, so this was np.random.rand. Moving on to our next function, which is np.random.randn. Okay, now randn basically stands for random numbers having a normal distribution. Yeah, so Google Colabs has generated the definition for us. So basically these are the random floats from standard normal distribution. Okay, what this means is that this particular function is going to generate values from a standard normal distribution, meaning the mean is always going to be 0, mean is nothing but the average, and the standard deviation is always going to be 1. I'm sure you guys are familiar with a graph like this. Okay, so the mean is somewhere over here, which is basically 0, and our standard deviation, which is basically telling us how spread our data, is always going to be 1. Alright, this is also known as the graph for normal distribution. Okay, so in order to generate random numbers having a normal distribution, all you have to do is pass the dimension again. So I'm just going to go for 2, 3, and then I'm going to, okay, I haven't stored it in a variable. Let me just store it, and then I'm going to print add. So here my values are also going to be negative because again they're normally distributed, and the center is going to be 0. Alright. Then the next one that we have is np.random. Random basically stands for random numbers. I hope you guys got an idea about that. Okay. Dot randit. Now this is the most simple one so far. This is basically just random integers. Okay. So here we are going to generate random integers within a particular range. So over here what we are going to pass is the starting value, the stop value, and the size. So I want it in a size, and if I don't mention the size, I'm by default going to get 1 row. Okay. So let me just run this. I haven't printed ARR. Okay. So I got one random integer called 99. Okay, so I did not specify how many integers I want. I just gave a range that I want my random integer to be between 10 and 100. Okay, so it is going to be start, stop, dimension, or the number of values. Okay, so if I were to run this again, having a different kind of parameter, okay, let me just do it. So now I'm going to give a dimension of, say, or size 2 comma 3. So here I have 2 rows and 3 columns. So basically 2 comma 3 means I'm going to have 6 random integers in my NumPy array. Alright, you guys have to keep this calculation in mind. Alright, so whenever we have 2 rows and 3 columns, basically we are multiplying 2 into 3. We are going to have 6 elements. Alright, we'll be performing some advanced operations in the later stages. So you guys need to have this particular calculation on the tip so that you guys do not get a lot of errors later on, right? Let's do another one. Say I have 4 rows and 4 columns. How many elements am I going to have? 16, right? 4 into 4. Let's do a last one. Say I have 10 rows and 5 columns. What's the total number of elements I'm going to have? Quickly comment in the chat box. Okay, it's going to be 50, right? So this is how you can generate random integers using this particular function. Alright, so moving on to our next topic, which is NumPy data types and typecasting. Alright, so NumPy data type is basically a function that tells us what kind of data types are stored inside the NumPy array. They could be integers, floats, strings, or complex numbers. Alright, so till now we saw how we can create NumPy arrays using inbuilt functions. Right, the first one was arrange, where we basically, if we were to implement that in Python list, we would use a for loop, right? We would give the start value, the stop value, and the step value, and then according to that, we would create a list. Similarly, in NumPy array, we can just do that using the arrange function. All right. Then we saw log space, we saw linspace, we saw some random functions like randn and just rand, right? We saw how they're implemented and their functions. All right. Now, another way to create NumPy arrays is manually. You can manually pass the integers or the elements that you want to be stored inside your NumPy array. So, for example, I want to create a NumPy array called ARR, and I will say NumPy array, and I will pass a list of all the elements that I want to be stored inside this array. Okay, so this is my array 1, 2, 3, 4, 5. All right. So if I change the data type of even a single element over here, so I basically converted 3 to 3.1, which is a float value. And now you can see all the elements in my array have been converted to a float. Alright. So as you already discussed, NumPy arrays do not allow multiple data types to be stored. So we're going to go ahead and check the type of our array. So as you can see over here, it's a NumPy array, right? Now another way we can create arrays is, say if I have a list called LST and I have a few elements in my list, say this is a string, then I have a few integers, and then I have some float values. Okay. Now if I want this particular list to be converted into my NumPy array, all I have to do is say ARR equal to np.array and pass my list in it. Sorry. Okay, so as you can see over here, all my elements inside the array are converted into a string format. Alright, so before we go ahead and check the data types of our NumPy arrays, here are a few common data types that exist. So the first one is int32. So these are 32-bit integers. So for example, the single digit numbers. Alright, then we have int64. So by default, whenever we store an integer, they are stored in the 64-bit format. It also depends on your machine specifications. So 64-bit integers are basically the larger digits. Then we have float 32. So again, they're the 32-bit floats. So basically 1.0, 3.14. But if we have a really large float value, it would be stored as float 64. And this is also the default data type of any float integer. Alright. So basically we have a lot of decimals over here. So it's going to be float 64. Then we have bool, which is basically boolean true or false. Then we have complex numbers like 1 plus 2j, 3 minus 4j. Then we have string, which is a Unicode string like hello 123, basically anything in double quotes. Alright, so that comes under strings. So these are the common data types that exist. So let's create an array containing only integers. So I have created an array using np.array, which consists only of integers. Alright, let's go ahead and print it. And now what I'm going to do is I'm going to check the data type. So over here it's int64. Alright, and now if I were to make even a single element over here a float value, my data type changes to float64. Alright, now if I were to make it a string, let's see how it would get affected. So it's u32, basically specifying that it's a string data type. Alright, now another way that we can create NumPy arrays is while we are passing our list of elements, say I have 1, 2, 3, 4. Okay, now I want these elements to be float data type. Alright, but if I were to print the data type right now, they're int64, right? They're integers. But if I want to convert them into float, what I can do is I can simply write dtype, which stands for data type, equal to np.float. I can leave it at float, or I can also specify 32 or 64 according to, okay, there's a typo. So here my data type is float 32. I can also convert it to float 64 instead of float 32. Here, it's float 64. So I hope you guys are getting a basic idea. But if we were to do the reverse, say I have my float values over here and I want to convert them into integer 64, what do you think would be the result? Would I get an error, or would my elements get converted to int64? So let's check it out. So there's no error. Rather, my array has been converted to integer data types. So as you can see over here, the decimals are simply lost, right? So we basically round them up, and so if there was 2.6 over here, let's see what my array would look like finally. Yeah, so we basically just remove the decimals and pass the integers whenever we're converting float to integer. And we also saw that whenever we do not assign the data types, NumPy will do that for us automatically, right? Over here, you can see we did not happen to specify any sort of data type like float or integer. But if we go ahead and check the data type over here, it's going to be float64. Alright, because by default our elements over here are float data types. So when we go ahead and check the data type of this array, it's going to be float. So NumPy will do that for us automatically. So we're done with data types. Now let's move on to typecasting. Alright, so typecasting is basically done using the function as type. Okay, so whenever you want to convert one data type to another, we use typecasting. So this is going to create a new array with the values converted to the other data type. It is not going to change the original array. Okay, so say for example, I have my array np.array and I have my elements 1, 2, 3. So quickly comment your answers. By default, what is the data type for this particular array going to be? Okay, so if you guys have commented int64, you guys are absolutely right, because if I go ahead and check the data type for this particular array, it's int64, right? As we discussed, the default data type is always going to be int64 or float64, depending on integer and float values. Okay, so now I want to convert this particular array into float64 instead of int64. So what I'm going to do is I'm going to create a new array and say arr, which is my previous array over here, dot as type, and I'm going to say np dot float 64. Okay, now I'm going to print it. So you can see my integers have been converted to float values. Alright, I can also go ahead and print the data type. So you can see the data type is float 64. Alright, similarly we can convert float to integer. So let's convert this new array to integer 64. Alright, so here, so again my new array 2 is again an integer. So I have successfully converted my float to integer over here. Now next we are going to look into something known as typecasting errors. So whenever we try to convert from one data type to another where typecasting is not possible, we get something known as typecasting error. So say for example, I have an array where my elements are 1, 2 and hello. Okay, so say all of these are strings. So even my integers over here are stored as strings. Sorry, this is going to be np dot array. Now I want to convert this particular array into an integer data type. So what do you guys think? Is it going to run successfully or is it going to give me an error? So let's go ahead and run it here. So invalid literal for int with base 10 np.string hello. So over here we have hello, which consists of multiple characters and it cannot be converted into an integer or float format. Alright, so this is what is known as typecasting errors. So we cannot convert a string into integer or float. Is that clear? So now we saw how to create an array manually, how to check the data type and how to typecast those arrays, right? Now the next thing that we're going to look at is how to create a multi-dimensional array manually. Okay, when we were using the inbuilt functions, all we had to do was pass the number of rows and the number of columns that we needed in the array, right? But if we are creating an array manually, say np.array, now what we have to do is we have to manually pass the elements in each row and each column that we want in our array, right? So this is going to be my row 1 and then I have my row 2, 5, 6. Okay. So as you can see over here, this is my first row and this is my second row. Alright. So I have 2 rows and 3 columns. 1, 2 and 3. I can also write it like this. So I hope this is more clear. So basically this is our column 1, 1 and 4. 2 and 5 is our column 2. 3 and 6 is our column 3. Alright, and these are our 2 rows. So if we go ahead and run it, right. So now why am I getting an error over here? Because these are 2 lists. Okay, so these are considered as 2 lists. I am allowed to pass only one list in my np.array function. So what I have to do is I have to place another square bracket so that this is considered as one list. Alright, now if I run it here, if I print my array, this is what my array is going to look like. Now I can go ahead and check the dimension of my array. So as you can see, this is a 2D array because it consists of rows and columns, right? You can check the dimension using ndim function, alright? So there's another method where we can check the shape of our array using arr.shape. And you can see over here, we have 2 rows and 3 columns. So the number of rows is always going to be the first argument or the first parameter in a tuple. And the number of columns is going to be the second one. Okay. The next thing that we can do with our array is we can check the size of our array. So the size of my array is 6. Now what this means is that I have 6 elements in my array. Now we already discussed it. We can calculate the number of elements by knowing the dimension. Now we already discussed this. We can calculate the number of elements of our array by knowing the shape of our array. So if we have 2 rows and 3 columns, it is just going to be 2 into 3, which is 6. Alright. Now the next one is checking the item size. That is the size of one element in bytes, right? So we can do arr.item size. So basically each element in our array is taking up 8 bytes of memory. Alright, so this is how you check the item size. So these are some important properties of NumPy arrays. Alright, so moving on to the next topic, array reshaping, where we'll be learning about functions like reshape, ravel and flatten. Now what's the purpose of array reshaping? So say sometimes we want to change the shape of our array without changing the data. Alright, so say instead of 2 rows and 3 columns, I might want to have 3 rows and 2 columns, right? So such array reshaping is done by the help of these functions, as you can see over here. So first let's look at reshape. Okay, so say I have an array and I have elements 1, 2, 3, 5, 6. Alright, so I have 6 elements in my array. So my reshaped array would use the function arr.reshape, where my elements would be distributed in 2 rows and 3 columns. Alright, so I can just say 2, 3. So initially my array looked like this, and then after reshaping, this is what it looked like. Alright, 2 rows and 3 columns. Now I can again reshape my reshaped array, where reshaped is my this particular array, right? 2, 3 columns. Now I want to reshape these two rows and 3 columns into 3 rows and 2 columns. So it's run successfully. If I print it, as you can see, I have 3 rows and 2 columns. Alright, so I hope reshape function is clear. Now moving on to the next one, which is Ravel. Okay, so Ravel is basically used to convert a particular array to 1D array. Okay, so whatever may be the dimension previously, so we can just convert our reshape 2 array. Reshape 2 array is basically having 3 rows and 2 columns. So we are going to convert it into a 1D array. So as you can see over here, our array is converted to 1D again. The next one that we have is flatten. This is also going to convert your array to 1D array. Now what's the difference between Ravel and flatten? So basically Ravel is going to return a view, which basically means that any changes that you apply over here in this particular array are going to be reflected in your reshape 2 array. Okay, so basically this is going to return a view, whereas flatten, it returns a copy. So whatever changes you apply to the new array, that is the flattened array, are not going to be reflected in your original array. Okay, so let us just try changing something in the Ravel array. So say I want my first element, that is my element at 0th index, to be 100 instead of 1. Okay, so if I make this change, I'm going to print my Ravel array, and then after that I'm also going to print my reshape 2 array, which is basically the array that we converted to 1D. Alright, so let's see if both the arrays are changed or not. Yes, so as you can see, the first element of both the arrays have become 100. Okay, now if I try to use the flatten method, so I'm going to say flat equal to reshape 2 dot flatten, and I'm going to print it. So here, okay, now if I want the first element of my flat array to be 1 again, okay, now if I print reshape dot 2, reshape 2 array, so it's still 100. Alright, so any changes in my flat array are not being reflected in my reshape 2 array. Okay, so this basically means that we are creating an independent array over here, right? So I hope the difference between Ravel and flatten are clear, although their functions are the same. That is, both the functions convert any sort of array to 1D array, but whenever we use the Ravel method, we are basically returning a view of the original array, right? So let me just explain it over here in case you guys did not understand. So say I have my original array over here where, okay, 1, 2, 3, 4, 5 and 6. So basically I have 2 rows and 3 columns. Okay, so when I use the Ravel method, my array is going to look something like this. But this variable is still referring to this particular array. Okay, but it is only returning a view that looks like this particular array, right? It's basically returning a view that looks like one dimensional, but it is still referring to the original array. Alright, so whenever we make any changes, they are directly reflected in the original array. Make sense? But when we use the flatten method, we create an independent array where we convert the original array to a one-dimensional array. Alright, so whenever we make any changes, they have zero connection with the original array. So it is completely independent. I hope the difference was clear. So moving on to the next topic on our list, that is arithmetic operations on arrays. Alright, so this is where we are going to perform the arithmetic operations. Again, NumPy lets you perform all the mathematical operations on entire arrays, element by element, without having to loop through them. Alright, so let me just create 2 arrays, where my first array is going to be np.array, and I'm going to have the elements 1, 2, 3. Similarly, I'm going to create another array, np.array, and I'm going to pass the elements 4, 5, 6. Alright, so let me run it. So the first operation is going to be addition. Now if I want to add these two arrays, all I have to do is print a plus b. And there, 1 plus 4, 2 plus 5, 7, 3 plus 6, 9. Alright, so I have my element wise operation, and the result, the output is clear as well. Okay, so the next operation that I have is subtraction. So all I have to do is print a minus b, and voila. So 1 minus 4 is minus 3, 2 minus 5 is again minus 3, 3 minus 6 is again minus 3. If I were to perform b minus a, we would get positive 3s here. Okay, moving on, we have division. So all I have to do is print a slash b, and there. Okay, so it's basically 1 divided by 4, which is 0.25, 2 divided by 5, which is 0.4, and 3 divided by 6, which is half, 0.5. Okay, so next one that we have is multiplication. So print a star b there. So 1 into 4 is 4, 2 into 5 is 10, and 3 into 6 is 18. Alright, easy enough. Now over here we perform normal division, right? And our answer was in float. But if we want to perform integer division, all we have to do is print a double dash b. So this is going to give us integer values, right? Okay, wait. It's supposed to be b slash slash a. Okay. So when 4 is divided by 1, it is going to be 4. When 5 is divided by 2, it is going to be 2. The roundup of 2 point, it's going to be 2.5, I guess. I'm not sure. I've not really done the multiplication. So next one is 6 divided by 3, which is again 2. Alright. So you can use double slash for integer division, whereas single slash for normal division. Then next you have modulus, which basically gives you the remainder. Okay, so all you have to do is print a mod b, and you get the remainder. So when you divide 1 by 4, so let us get the remainder. Well, b is divided by a. So when you divide 4 by 1, your remainder is going to be 0. When you divide 5 by 2, your remainder is going to be 1, because 2 2s are 4 and 1 is going to be the remainder. And since 6 is completely divisible by 3, our remainder is going to be 0 again. Alright. And then our last mathematical operation that we have is exponents. So this is basically the power. Okay. So all I have to do is print a double star b. Or I can just do every element raised to the power 2. Okay. So basically I'm squaring the array a. Alright. So it is going to be 1, 2 2s are 4. And 3 to the power 2 is 9. Okay, so as you can see, this is our output. So these were the element wise operations. Alright, so that was all about the mathematical functions. Now let's move on to our next topic, which is universal functions, or also known as U-funcs. So NumPy basically comes with many built-in math functions that work element by element, and these are called U-funcs that we just discussed. So for this particular section, I'm going to create another array using np.array and pass my list as 1, 4, 9 and 16. Alright, let's run it. So my first universal function is square root, which is written as np.sqrt. Alright, so let's go ahead and implement it. So all I have to do is print np.sqrt square root and pass my array as a parameter. Alright, so I want you guys to comment quickly what's the square root going to be for this particular array over here. 1, 4, 9, 6. 1 is going to be 1, 4 is going to be 2, 9 is going to be 3 and 16 is going to be 4. Let's see if that's the answer. Right, so you can see this is the answer, but it's returned in float data type. Alright, so moving on. The next function that we have is exponential, which is nothing but np dot e to the power exp. Sorry, np dot exp, which is also written as e to the power x, where x is any integer. Alright. So let's go ahead and implement it. So I want to print np.exp and say I want to print the exponential of only 1 and 2. Okay. So I'm going to pass it as a list, these two particular elements, and that. So e to the power 1 is 2.7 and the remaining decimals, whereas e to the power 2 is 7.389 something. I hope that's clear. So these are somewhat very basic mathematical functions that we will be using most of the time. So it's very important that you guys know the syntax and how to implement these functions, right? You can always go ahead and look them up online, but again, that's very time consuming. So it's particularly important that you guys remember the syntax somewhat, right? So the next one is sine function, which is nothing but np dot sine. Okay. So say I have a few angles where np dot array is equal to 0, np dot pi. Np dot pi is nothing but the pi, right? So it's written as np dot pi. And then np dot pi by 2. And then what we're going to do is we're going to print np dot sine and pass angles as a parameter. Alright. So the sine of 0 is 0, sine of pi is 1. So you can see the sine of 0, pi by 2 and pi. Alright. So this is your resulting array. So this was all about the inbuilt mathematical functions. Now we'll move on to a very important topic, which is known as indexing and slicing. Alright. Now for all those who are not familiar with the concept of indexing and slicing, let me quickly tell you guys using a list. So say I have a few elements in my list. Now if I want to access the first element of my list, which is this, all I have to do is note down the indexes of these elements. Now indexes are something that represent the value at which these elements are stored, right? So this is what my indexes are going to look like: 0, 1, 2, 3, 4. Note that the indexes always start from 0, alright? So if I want to access this particular element, all I have to do is look up the index of this particular element. Now I know that my element is stored at index 0. So all I have to do is access my index 0 and this would give me the result 1. Alright. Now this is normal indexing. There's something known as negative indexing as well. Alright. Now negative indexing basically starts from the last element. So this is going to be -1. Note negative indexing starts with -1 and not 0. Alright. So this is going to be, our last element is always going to be -1. And then we are going to count backwards: -2, -3, -4 and -5. Alright. Now if I want to access the last element, I can either say element at index 4 or I can say element at index -1. Now both of these are going to give me the value 5. Alright. So this is something known as indexing, where you refer to the indexes and access one particular element according to the index. The next thing that we have is slicing. Slicing is where you try to access a piece or a slice of your list or array, right? Now say if I want to access the first 3 elements of my list, all I have to do is access 0, 2, 4. Now why have I used 4 over here? Because I want the first, sorry, I'll be using 3 over here. My bad. I'm really sorry about this. Yeah. This is my starting index. This is my ending index. Okay. And the ending index is never included. So this particular array is going to give me the output 1, 2 and 3. The first 3 elements of my list. Okay. 0, 1 and 2. 3 is not going to be included in my output. Alright. Now if I want to access the last 3 elements of my list, all I have to do is -1 to -4, right? Because I want the last 3 elements of my list. So I'm going to do -1 to -4. Now another thing that I have to do here is I have to give a step value that is -1. That is, I have to tell the computer that I want to subtract 1 from the starting point to reach -3. Alright, because by default over here, as you guys must have noticed, the step value is going to be 1. That is, 1 is going to be added to the starting value until it reaches the end value. Alright, so basically we're running a loop over here. So over here I will get the values 5, 4 and 3. Alright, if I were to not include the step value as -1 over here, my output would have been just 5. Let us quickly run it and see. Alright, so say I have my list 1, 2, 3, 4, 5. Okay, now I want to access the last 3 elements, that is 3, 4 and 5. So what I'm going to do is -1, 2, -4. Okay, I am not including the step value over here. So let's see what's the output here. Oh, it's empty. So it's not including the last element as well. So as you can see, I've created my list over here. Now, if I want to access the last 3 elements of my list, that is 5, 4 and 3, all I'm going to do is pass -1 as my starting index, -4 is as my ending index, and right now I'm going to skip this step value to show you guys that my output is going to be 0. Like, that is an empty list. Alright, so I'm not even going to access repeat. So I'm not even going to get my last element in my output. Now, if I include the step value as -1, here you can see 5, 4 and 3 is my output. Alright, so this is basically how indexing and slicing works. I hope you guys got a basic idea. Let me show you guys a normal slicing as well. So basically I want to access all my elements, but I want to access them skipping one value from them. So basically I'm going to give my step value as 2. So I want the first element, the third element and the fifth element. So let's see how this looks. So as you can see, I've got my first, third and fifth element. Okay. Now let's apply the same thing for our NumPy arrays as well. Alright. So I'm creating an array, np.array, and I'm going to have my elements. Alright. So let us quickly see the indexes first. So this is going to be index 0, 1, 2, 3 and 4. Alright. So we have 0 to 4 indexes. Now if I want to access my indexes 0, 2 and 4, that is 0, 2 and 4, what is my syntax going to look like? So let's go ahead and slice it. So I'm going to say from starting to ending, but my step value is going to be 2. So as you can see, 10, 30 and 50. Okay. So I hope I'm making myself clear. Over here, I could have passed 0, 1, 2, 3, 4. Yeah, so I could have passed 0 and left this blank because I want this to be included as well. So, but instead of that, I'm going to leave this blank as well. So by default, this is starting index, that is 0, and this is the ending index, that is the length of the array. Alright. So this is how you can slice your NumPy arrays. Now let's look at negative indexing. So let's say I want to access my last element. All I'm going to do is, so it's giving me np.in6450 as the output. Correct? But if I say print, so 50 is my output. That is the element at index -1. Similarly, you can go ahead and try negative indexing with other arrays and other elements. Okay, you can go ahead and play around with it. The main, the important thing is that you understand the logic behind it, right? And I hope I've explained the logic pretty well over here for both negative indexing, slicing and negative slicing. Alright, so we have already looked at slicing over here. We've looked at negative indexing. Now let's go ahead and perform multi-dimensional slicing. Alright, so I'm going to go ahead and create a matrix. I'm going to call this 2D array a matrix, and it's going to look like this. So I'm going to have 3 columns and 3 rows, 4, 5, 6 and 7, 8, 9. Okay. Now I need to convert this entire thing into a list so that I do not get any error. So that I do not get any errors. Let me run it. Alright. So now say I want to access the first two rows of my matrix. How am I going to do that? So in order to do that, all I have to do is print matrix and my row 0 and 1. Alright, so I want my first row and my second row. So I'm going to say row 0. So this is my row 0, this is my row 1, and this is my row 2. I do not want the second row, so I'm going to have my stop value as my second row. Alright, again the indexing is going to start from 0, so this is our row 0. Alright, so this was about my rows and I want all my columns, so I'm simply going to pass 0 to 3. That means I want my 0th column, my first column, and my second column. Alright, so instead of this, what I could have done is just passed a colon. So let me see here, 1, 2, 3 and 4, 5, 6. Let me explain it over here. So I have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is column 0, column 1, column 2. This is row 0, row 1, row 2. Alright. So basically this is what my matrix looks like. Now I am saying that I want to access this particular section of my matrix. So over here I want my row 0 and 1 and I want my column 0, 1 and 2. Alright. So over here my starting index should be 0 and my ending index should be 2. Over here my starting index should be 0 and my ending index should be 3 because I want my second column as well. Alright. So whenever we are accessing all the elements of a particular row or column, all we are doing is using the colons. We have used this feature when we were performing slicing as well. Alright. So this is basically what we have done over here. Now we can try some other elements as well. Say I want to access these 4, that is 5, 6 and 8, 9 elements. So what I'm going to do is I'm going to print my matrix and I'm going to say that I want my row 1 and row 2. So I'm going to say row 1 and I'm not going to pass any value here because I want my last row as well. Alright, and then I'm going to say I want my row 1 and 2. So again I'm going to pass 1 colon nothing. Let's print it. So I've got 5, 6 and 8, 9 as my output, which is exactly what I wanted. Alright, so I hope you guys are getting a basic idea about indexing and slicing in 1D arrays and 2D arrays, and I am 100% sure that you guys can go ahead and perform it in 3D arrays as well. Alright, so let's move on to our next topic, which is index arrays and np.take. So index arrays are also known as advanced indexing. Okay, so let's quickly see what it is. So instead of filtering with true or false, we can directly pass positions or indexes to get specific values. Alright, okay, so let's look at another method called np.take, which is basically a built-in function to perform indexing or slicing. So whatever indexes you want to access from your array, all you have to do is create a list of those indexes. So I'm going to use this particular array. Okay, so I want to access my indexes 0 and 2. Alright, so I have defined them in a list. So now all I have to do is print np.take, pass my array and the indexes that I want to access. Okay, so as you can see over here, at index 0 I have 10 and index 2 I have 30. Alright, so you can use np.take to perform the same operations. Moving on with our next topic, that is iterating with nder. Okay, so in case you want to loop through the NumPy arrays, you cannot use a for loop, but rather you can use something known as nditer. So it's going to let you loop over each element regardless of which shape it is, right? It could be a 2D matrix, a 3D matrix. You can easily loop through it using nditer. Okay, so I have an array np.array and it's going to be a 2D array having 2 rows and 2 columns. Okay, so let me run it. So all I have to do is for x in np.nditer my array, and I have to print x end equal to, so that it gets printed in the blue line. Alright, so you can see these are the elements of my 2D array over here. Alright, so you can use nditer, or another feature or method that you can use to iterate or loop over your array is nd enumerator. enumerate. So over here, using this, you will get both your index value plus your value of the element value. All right. So I'll use the same array. Okay, I'll use the same array, and I'm saying for ind, which is my index, and x is my value or the element, in np.nd enumerate my array, and I'm going to print my index and my x. Alright. So at index 0, comma 0, that is first row, first column, I have my value 1 and so on. Alright. So you can easily understand this. So moving on to views versus copies. Again, this is a very important topic. Okay. So we already saw that when we create a view, the original array is going to be affected. Whereas whenever we create a copy, our original array is going to remain unchanged. Alright. So let's see how we can create a view. So if we have an array, let's create np.array. Okay. First I'm going to create a view. So my view is going to be array 1 to element. Let me print my view. So it's elements 2 and 3. Alright. Now if I try to change my view, let's say I want my first element of view to be 200 instead of 2. Okay. Let's check my view. It's array 203. Now if I try to print the original array, it has also been changed, right? As you can see over here, instead of 2, I have 200. Now let's try and create a copy. Okay. So in order to create a copy, all I have to do is say arr 1 column 3, that is elements 2 and 3 dot copy. Okay. Now over here, my array is going to look the same as what it looked in a view. But over here, if I say my first element needs to be 2 again, over here it's changed. But if I print the original array, the element remains unchanged. Alright, the values are same as before. So this is the difference between view and copy. We had covered it theoretically, but now we have also seen the practical implementation of the same. So moving ahead, let's look at a very important mathematical concept in matrices, or whenever we have more than one dimensions in an array, something known as transpose. So we're going to look at transpose of a matrix. So say I have a 3 by 3 matrix containing values A, B, C, D, E, F, G, H, I. Okay, so this is a 3 by 3 matrix. Now what transpose basically means? So transpose of a matrix is basically a new matrix created by interchanging its rows and columns. Alright, so if this matrix is denoted by A, my transpose matrix is going to be denoted by A dash or AT. Alright, so this is going to be the transpose of my matrix. Now what interchanging rows and columns basically means is, if I want to transpose my matrix, so this is what my transpose is going to look like. So let's see how it is done using NumPy in our notebook. Okay, so let's create another array, np.array. Okay, 1, 2 and 3, 4. So you can see 1 and 2 are spread row wise, and 3 and 4 are the other rows, whereas 1, 3 is first column and 2, 4 is the second column. Now if I go ahead and print arr.transpose, you can see my rows and columns have been interchanged. Alright. So now 1, 3 is spread row wise instead of column wise, and 2, 4 is spread column wise instead of row wise. Alright. Moving on to the next topic, swap axes. What this means is we swap two specific axes in a matrix. Alright. So I'm going to consider this particular array itself. Let me just copy it. Okay. Now let's quickly see the shape of my array. So arr dot shape. Okay. So it's 2, 2. So I need to change this into, okay, let me add another axis to it. Okay. So now it's 1, 2, 2. Alright. Now if I want to swap an axis, I'm going to say np dot swap axis, and I'm going to pass my array, and I'm going to say I want to swap my 0th axis with my first axis. Okay. Now I'm going to check swap dot shape. So now you can see these two axes have been swapped. It was 1, 2, now it is 2, 1. Alright. So basically you can choose over here which axis you want to swap. That's the only function of swap axis. Alright. Now let's look at some other functions like concatenation. So concatenation is basically when you join multiple arrays. Okay, so let us quickly look at concatenation. Okay, so say you have array 1 of 1 comma 2 and you have array b 3 comma 4. Now you want to concat these two arrays, that is basically you want to join them. So you can say, so that your result basically looks like 1 2 3 and 4. Alright, so in order to achieve this result, all we have to do is, if we had the plus sign, remember our element wise operation is going to take place. That is, if we simply perform a plus b, if that is what you guys are thinking, it's completely wrong, because our result is going to look like something like 4 comma 6. Okay, if we do a plus b, we've already seen that in the addition operation. So in order to do that, what we're going to do is, let me just create the arrays. Okay, so let me run it. Now, in order to combine these two arrays, all I'm going to do is concatenate and pass both my arrays and then print my combined array. Okay, so my combined array looks something like this. Now, there are other ways to combine these arrays. Now, what if I want to combine these arrays not like this, but rather something like 1 comma 2 and 3 comma 4, and I want my array to look like this. Okay, so in order to do that, there is something known as V stack or vertical stack. Okay, so this is where you can understand, this is how I understood. So say if I have two arrays a and b, they must be having, okay, let me call it a1 b1. So they have these particular elements, okay, c b. Okay, and array b looks something like, now if I want to perform vertical stack on these two arrays, my output is going to look something like this. Okay, so my final output is going to look like a b c d. I'm not going to focus on the brackets right now, I'm more focused on the output p q r s. Okay, so basically this is how my output is going to look like. Let me just go ahead and implement it. So I have my array 1 np dot array and I'm going to pass a comma b c comma b. Okay, I think I have to put them in quotes. So instead of that, I'm just going to replace them with numbers itself, and my array 2 is going to be, okay, so these are my two arrays. Now if I perform v stack, which is np dot v stack, and pass array 1 and array 2, you can see this is what my output is going to look like. Now similarly, similar to v stack, there is an other operation called h stack. Okay, now vertical, remember vertical is like this, where your two arrays are going to be stacked like this, whereas horizontal stack, remember it as the horizontal line, where your arrays are going to be stacked like that. Basically they're going to be concatenated. Alright, so in case of horizontal stack, my output is going to look like this. Okay, so it is going to be a comma b c comma d, okay, p comma q and r comma s. Okay, let us quickly perform h stack. So if I were to print np dot h stack and pass both my arrays, you can see this is my output, just as we discussed. Okay, so basically it's going to be concatenated or joined horizontally. Alright, so I already told you the easy way how you can remember this. Whenever we're talking about vertical stack, all you have to do is imagine a vertical line and then imagine the two arrays following that vertical line and finally combining. Whereas in the horizontal stack case, you imagine a horizontal line and imagine the two arrays following the directions and combining. Okay, so that's all about a horizontal stack and vertical stack. Now if you don't want to particularly call h stack or v stack, what you can do is just call stack. Okay, and now this stack function is first going to take your arrays, that is a b, and then it is going to ask for your axis. Okay, now always remember, axis 0 means row wise, whereas axis 1 is column wise. Okay, so this is something that you will have to remember. So say I print np dot stack, I pass my arrays and I give my axis 0, which is basically going to be performed row wise. Alright, so axis 0 means rows. So whenever we're going to stack our rows, they're going to be stacked vertically. Whereas if my axis were 1 over here, my arrays would be joined column wise. Okay, let me just change this to 1. So our axis can only be 0 or 1. Okay, so this was all about joining or combining two arrays. Now let's look at the opposite function of that, that is splitting the arrays. Okay, so this is my array. Let me just print it. Okay, so this is what my array looks like. Okay, Now if I want to split my array into two equal parts, all I'm going to do is print np.split arr1, and I'm going to say two parts. Alright, so this is my array 1 and this is my array 2. If I say I want to split it into three parts, I get an error because there won't be an equal division if I go for three parts. But if I go for four parts, you can see I get four different arrays. So in order to avoid error, you will have to do some prior calculations. Okay, you need to make sure that your array is eligible to split in those many parts equally. Alright. So if we perform edge split on our array and we say we want to split it into two parts, this is what our array is going to look like. Alright, so it's basically split into two parts. We've already discussed edge split is going to be performed this way and vertical split is going to be performed this way. So similarly, you can perform V split as well. You just have to pass the array and the number of splits you want to perform. Okay, you need to make sure that that number satisfies the basic requirement, that is the array is able to divide itself into equal parts. Alright, so moving on to the next topic, that is repeating and tiling. So first we'll look into repeating. So the repeat function basically repeats each element. Alright, so say I have an array over here that contains the elements 1, 2 and 3, and I'm going to perform the repeat operation saying np.repeat, and I'm saying I want to repeat my array twice. So if I print it, you can see each element is repeated twice. Okay, so if I repeat it thrice, this is what my array is going to look like. Now the other operation is tile. Okay, now this is going to repeat my whole array. Okay, so I can simply say print np.tile array twice. Okay, so 1, 2, 3 and 1, 2. Alright, so this is all about repeat and tile. Then we have some aggregate functions. Okay, so aggregate functions are basically used to summarize the entire array. So say for example you want to find the total, the average, or the maximum element or the minimum element. Now in case of Python list, normally you would have to loop through the entire list and perform these operations. But NumPy arrays come with inbuilt functions. So say for example, this is my array. Okay, and if I want to find the sum, all I'm going to do is print np.sum and pass my array. Alright, so I have the sum of all my elements. Similarly, I can find np.mean, that is the average. So my average is going to be 2. 6 divided by 3. Alright, then I can find my median. So my median is 2 again, that is the middle value. So 1, 2 and 3. Then I can find the standard deviation, np.std. Okay, and similarly I can find the variance. This is basically the square of my standard deviation, and standard deviation is basically how spread your data is, your numbers are. Okay, then we can also find the minimum number or the minimum value in my array. So my minimum value is 1 and the maximum value is 3. Alright, now if I have a 2D matrix and I want to find the sum across any one axis, I have some axis based operations that we can apply along any row or column in a 2D array. Okay, so say I have a matrix np dot. Okay, let me just see if I have a matrix already. Okay, so I have this matrix already. So if I want to find the sum across only my columns, okay, so what I'm going to do is print np.sum and I'm going to pass my matrix and I'm going to say axis is 1 because I want it across my column. So since my axis is 1, the sum of this particular row is 6, then over here it's 15 and over here it's 24. Now similarly I can find row wise operations as well. So 1 plus 4 plus 7 is 12. Okay, so this way you can do your row wise or column wise operations as well. Then next we have cumulative operations. Okay, so these are basically for calculating a running total. Okay, let's see how. So here I have my array 1, 2, 3. Now if I want to print the running sum or the cumulative sum of my array, I will just say mp.comSum, pass my array, and you can see the sum of my first element is 1, then sum of my first element plus my second element is 3, then sum of my first element plus second element plus third element is 6. Okay, so this is how a running total or a cumulative sum is calculated. Similarly, you can also calculate a cumulative product, saying np.comProd and pass my array. So 1 multiplied by nothing is 1, 1 multiplied by 2 is 1, 1 multiplied by 2 multiplied by 3 is again 6. Alright. Now moving on to conditional based choices. Okay. So first we're going to look at where. So say I have my array over here 1, 2 and 3. Alright. So I'm going to call my result variable and I'm going to say np.where array is less than 2. I want to print low, and if my array value is greater than 2, I want to print high. Alright. So let's print my result. So here I have my result array saying low, high, high. Okay. So over here my value is less than 2. So I have printed low over here. Whereas over here these two elements are greater than 2. So over here we have high. Alright. So again this is the string format and this is how it's represented. So the next feature is argwhere. So this basically gives the row column positions for 2D arrays wherever your condition is satisfied. So this is my array over here and I want to find out wherever my elements are greater than 20. Alright. So it's telling me at index 1, 2 and 3 I will find my elements greater than 20. So at index 0 I do not have my elements greater than 20. But what if I change my condition to 0 over here? So you can see I have my index 0 also in the output. Alright. So let's move on to advanced conditionals using np.logical and logical OR. Alright. So this is my array and now if I want to get values between 15 and 35, all I have to do is let's create a variable mask and np.logical and arr greater than, that is my array, greater than 15 and array less than 35. Alright. So let's print mask. So over here it's false. Over here it's true, that is 25. It's greater than 15 and 35 is again not less than 35 and 50 is again greater than 35. Alright. So you have false over here. Alright. So this was an example for a 1D array where we just had 3 elements. Now let's try for a more complex array, NumPy array. Let's take a 2D array. We already have a matrix over here. Alright. So now let me give a condition where I'm going to define np.argwhere and I'm going to say wherever my elements in the matrix are greater than 5, give me the index of those particular elements. Alright. So you can see over here the first element that's greater than 5 is 6 over here. Right. So the index of this element is row 1 and column 2. Alright. So you can see over here 1, 2. Then the next element that is greater than 5 is 7. So you can see over here 2, 0. Then we have 2, 1 for element 8 and value 9 we have 2, 2. Alright. So this is basically how np.argwhere works. Alright. It's going to return the row, it's going to return the row column of your value wherever the values satisfy the condition. Alright. So moving on to our next topic, that is advanced conditionals using np.logical and logical OR. Alright. So basically we have and OR in Python, but in NumPy we use logical and logical OR. Alright. So in order to understand that, let me quickly tell you guys about this concept. So whoever is not aware about the concept of and OR in Python, let me tell you. So say I have these particular values. Alright. So now if I implement an AND over here, that is a logical AND between these two values, I'm going to get a 0. But if I implement a logical AND between 0 and 1, I'm still going to get a 0. Between 1 and 0, I'm still going to get a 0. But whenever both my conditions are true, basically 0 stands for false and 1 stands for true. Okay. So basically over here what it means is if any one of my condition is false, my AND result of that false and true condition is always going to be false. I am going to get a true only when both my conditions are true. But in case of OR over here, we're going to get a result like this because whenever we have any one statement, any one condition true, our result is going to be true. Alright. So this is basically what logical and logical OR mean. Okay. So first let's go ahead and look at logical AND. So we have an array. Let me just print my array. Okay, so this is my array initially. So what I'm going to do is I'm going to get my values between 3 and 6. That is, I want 4 and 5. So all I'm going to do is np.logical and and I'm going to say ARR greater than 3, comma, my array should be less than 6. Alright, so if I run it and if I print my mask, so over here I get my false, 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 true, true for 4 and 5. Now if I say ARR here, so I get my values 4 and 5. Okay, just like we intended. So this was the implementation of logical AND. Now moving on to logical OR. Okay. So over here, I want all the values other than 4 and 5. Okay. I want to skip these values and I want all the other values. So what's going to be my logic over here? Let me create my mask variable again. So I'm going to say np dot logical OR, and I'm going to say my ARR, that is my array, should be less than 4 or my array should be greater than 5. So let me run it. Okay. So you can see for 4 and 5 I'm getting a false. Now if I try to fetch these values, so wherever I'm going to have a true in my array, those values are going to be printed. Alright, so you can see 100, 2, 3 and 6. Okay, so I hope the implementation and the logic behind logical and logical OR is clear to you guys. So before we move on to our next concept, let us quickly go ahead and summarize the concepts or the important functions that we have covered so far. Alright, so the first one is Boolean mask. That is basically we want to select the values based on true false conditions. Alright, so here you can see we have created a mask variable. So once we get our array of true or false, we simply use that particular array to index the original array and get the elements that are desired. Alright, so we saw how we use the Boolean mask array to select the values based on true false conditions. Then we also saw np.take, which basically performs the operations of indexing and slicing. So it basically fetches the values at given indices. Then we have np.non-zero. Okay, so this gets the positions where the array values are non-zero. Alright, so let me create an array having, sorry, I have to say np.array 0, 1, 2, sorry, 5, 0, 5. Okay, so this is my array. Okay, now what I'm going to do is print np.non-zero and I'm going to pass my array. So you can see these are the indexes where my elements are non-zero. Alright, so at index 1, at index 2 and at index 4. Alright, so the non-zero function is clear, so it's basically going to get you the positions where the array values are non-zero. Alright, then we saw np.where. So basically the where condition is going to get us the indices where the condition is true. But we already saw that one limitation over here is we can only pass 2 conditions, right? So we already saw the syntax where we say np.where and we give a condition and we tell, so if the condition is true, this particular operation gets performed, otherwise the other operation is performed. Alright, so we can only have 2 conditions over here. Alright, so pick from A, else pick from B. Then we have np.argwhere. So this is where we get the row column positions of matched values. Okay, we already saw this. And then lastly we have logical and logical OR. Alright, okay, so basically we are done with all the inbuilt functions that exist in NumPy. So now we'll be moving on to a very important topic, that is broadcasting. Okay, so what exactly is broadcasting? So broadcasting basically means stretching the shape of smaller arrays so that they match the shape of bigger arrays. So whenever we are doing an operation like addition, multiplication, subtraction, any kind of mathematical operation between two arrays, and one of our array is smaller as compared to the other arrays, so broadcasting is basically going to automatically stretch the smaller array to match the shape of the bigger array. Alright, so basically as a result you will be able to perform these operations between those two arrays. Alright, so before we go ahead into the implementation part, here are 3 very important rules that you should know when you are going for broadcasting. Alright, so always remember that NumPy is going to compare the shapes of the arrays from the end, that is from right to left. Okay, so if we have 2 arrays, they are going to start from the end. So the first rule is if the shapes are equal, they are compatible. Alright, so if we have two arrays that have the same shape, we do not need any sort of broadcasting to be implemented. They will be compatible directly. But if one is 1, it can be stretched to match the other. Now what this means over here is, so if we have one array like this, 1, 2 and 3, and the other array is just a single number 5. Alright, so say over here I want to add these two arrays. Now over here what NumPy is going to do is it is going to perform broadcasting, and this particular array is going to look like this. Alright. So over here initially this was a scalar array, but over here you can see this has become a 1D array. So if we perform this operation, it is going to look something like this. So rule 2 and rule 3 are related. If we read it just like that, it might not be very clear. So let us go ahead and understand this with another example. So say I have an array whose shape is 3, 1. Alright, so basically over here we have 3 rows, say 1, 2 and 3, and 1 column. Alright, so this is what my array looks like. Then I have another array who has a shape 1, 3. Alright, so this array is going to look like 1 row and 3 columns. Alright. Now, if we were to perform broadcasting between these two arrays and say we perform some mathematical operation like addition, subtraction, multiplication, any sort of operation between these two arrays, our final array, our resultant array, due to broadcasting would have a shape 3, 3. Alright. So basically, after broadcasting, this is also going to be 3, 3, and this is also going to be 3, 3. And that is how we get a resultant array that will have a shape 3, 3. Alright. So say for example, I have an array over here. Now what's the shape of this array going to be? The shape of this array is going to be 3, 1. Alright. So basically it's going to have 3 rows and 1 column or in each row. Alright. And then I have another array that looks like 1, 2 and 3. Now the shape of this particular array is going to be just 3, right? Because it has 3 elements, right? It's not a 2D array, it's a 1D array. So whenever we have to write the shape of a scalar dimensional array, we write it like this, 3, okay? We leave it blank. But now due to broadcasting, this particular element will look something like 1, 3. So basically we're going to consider this as 3 particular columns, and this is 1 row. Alright. Now after stretching these two arrays, our final array is going to look like 3, 3. Okay, it's going to have the shape of 3, 3. So according to rule 2, whenever any one of the array has 1 in its shape, it can be stretched to match the other array. Alright. Now let's look at another example where one array has the shape of 2, 3 and the other array has the shape of 3, 2. So why any operation is not possible between these two arrays? Because neither of these arrays have the shape of 1 in any particular row or column. Alright. So I hope the rules are clear. So if the shapes are different and not 1 or equal, then broadcasting cannot be done. So this is the only case where broadcasting cannot happen. So say if shape of B was 1, 2 or 1, 3, then broadcasting could have happened between A and B. But if the shape is 3, 2 where 1 is not there, then any operation is not possible and broadcasting will not take place. You will get an error. Alright. So now let's look at some real life examples where broadcasting is used. So say you have a grayscale image stored as a 2D array. Alright. Now you want to increase the brightness of the image by 50. So let me create a 2D array of the image, np.array, and so this is what my image array looks like. Alright, and I want my brightness to be image plus 50. Okay, I want to increase it by 50. Now if I print brightness, you can see it has been increased by 50. Overall my array has been changed. Alright, so over here 50 was broadcasted from a scalar digit to a array similar to this. Alright, so let's also check the shape of this 2D array. So it was 2, 2. So basically 50 was distributed in a 2, 2 matrix, and then it was added in the image. Alright, so this is basically what's happening behind the scene that NumPy doesn't really want us to get bothered with. Alright. So that was all about broadcasting. I hope you guys got a basic understanding of the rules The second and third rule are very important. If you guys do not understand it, you guys can go back and watch that particular section again. So moving on to the next topic, which is vectorization. Okay. So we already saw vectorization is basically when we replace the loops with array operations. Alright, we already saw array have numerous inbuilt operations that perform the mathematical operations directly, right? It could be sum, minimum element, maximum element, any sort of operation that we want to perform on the list through loops can be done on arrays with a single function. That is known as vectorization. Now, why this is possible? This is possible because of NumPy being run on the compiled C code in the background, right? So it's basically much faster than Python as well. So now why are we looking at vectorization again, since we have already covered it in detail in using all the functions? Another important property of vectorization is, say I want to create a new function. I want to do something different that the inbuilt functions are not able to do as yet. So what I can do is I can write a function and I can convert that particular function into a vector. Basically, I can vectorize that function. So let's see how. Okay. So we are going to use here np.vectorize. Okay. So this is going to convert a regular function to be applied on an array. Alright. So I hope this is clear. So we'll go ahead and create a simple function. I will not do anything complex. Say I just want to create a function where I want to square all my elements. Okay. So all I will do is create the function. Now what I'm going to do is I'm going to create a variable vfunc, which is basically vectorized function, and I'm going to call np.vectorize and I'm going to pass my function. Okay, so this is my array, and now all I have to do is print vfunc and pass my array. Okay, so you can see my array has been squared. All the elements have been squared in my array. Alright. So now you saw how you can basically convert any normal function into a vectorized function, but vector functions are to be used only when you want to apply a custom function to every element, and it is good for readability as well. So these are basically the benefits that you achieve when you're using a vectorized function. But there are some disadvantages as well. Okay, so it's not faster than a loop. Okay, basically you are going to pass your array into that function and the entire process is going to be performed. So it's not comparatively faster to a loop. The only thing it does is it makes your syntax cleaner, but it is not going to improve the speed like a real vectorized NumPy function or a NumPy array function. Alright. So if your purpose is not to increase the speed, you can go ahead and create vectorized functions. But if your motive is to increase the speed of your program or your code, then you should prefer the built-in NumPy functions like np.sqrt, np.exp that we just discussed. Alright. So now we'll move on to the last part of our course, which is dealing with missing values. Okay. So basically, whenever you have a data with you, okay, it could be any particular data. You will be having, say, let's say I am creating a house price prediction model. Okay. I'm going to have features like number of bedrooms, bathrooms. I'm going to have the location of the property. Okay. I'm going to have a number of features. All right. Features are basically the columns in your data set. Okay. So whenever I have a data set, there are going to be some features where I am not aware of what data is over there. Okay, so basically that's called a null value. Okay, so whenever you're dealing with a data set, there are going to be cases where you do not have the complete data in your data set. What I mean by that is maybe you have some data like this. So now whenever you see null written, that means that particular data is not available. Maybe the person forgot to update it. It could be any reason. Okay. So what do you do when you are in a situation like this? When you have some data and some data is missing. So this is where NumPy comes in the picture. NumPy is going to help you deal with all these missing values in your data set. Alright. So the very first feature that helps you deal with missing values in NumPy is np.nan. Okay. Nan basically stands for not a number. Okay. So this is used to represent the missing or undefined value. Okay. So let us see how it's implemented. So I have an array over here where my data looks something like 1, 2, np dot nan 4. Okay, so you can see over here, nan means not a number, means the value which was supposed to be here is missing. Alright, then we have other functions like np dot inf, sorry, minus np dot inf. Okay, see, these basically represent the positive and negative infinite values. So they often appear where in cases like division by 0 or overflow situations. Alright, so I'm going to write positive and negative infinites. Okay. So again, instead of np.nan, you can just write np.inf. Okay, so I'm not going to go ahead and create an array separately. Rather, I'm going to jump to the next step, that is when you check for the special values. So here you can check if your array has any nan, inf or negative inf using special functions like np dot is nan, np dot is inf, and np dot is finite. Okay, used to detect any sort of null value, infinite value or finite value. Okay, so let's go ahead and see how it's implemented. So let me create an array first that has all these criteria checked. Okay, so first we're going to use is nan. Alright, so I already have an array over there. So all I'm going to do is print np dot is nan and I'm going to pass my array a. So over here you can see at index 2 I'm getting a true value. That means at index 2 over here my value is nan, that is not a number. Okay, similarly I'm going to create other arrays like np dot array and I'm going to have values like np dot null, np dot inf. Let me pass this in a list. So now over here I'm going to check for np dot is inf and pass my array. So I'm getting true at position 2, that is index 2 over here, np.inf. So over here I'm not going to be made aware of any null value or not a number value. Okay, so if I want to find out null value as well as infinite value, what I can do is I can use np.logical or, and I can say np.na, sorry, is nan. So first we looked into these functions, what nan did, what inf did, and what negative inf did, right? And then we saw how we can find these null values or infinite values in our arrays. Now once we have found these values, the next step would be to replace or remove these values. So how that can be done? That can be done using np.nan underscore to underscore now. Okay, so let me create a new array and let me pass array b. So if I print my new array, so as you can see over here, all my values have been changed. So basically the null values are going to be replaced by 0. The infinitely large values or infinite values that are positive are going to be replaced with a large number, whereas any negative infinite value is going to be replaced with a negative large number. Alright, so this is what np.nan to num does. Okay, so let me just write over here, remove not a number or infinite values. Alright, so this is what it does. Just a quick info guys, Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course. So hello guys, welcome to this full course video on Pandas. In the last video, we had covered NumPy. If you guys haven't checked it out, you can go ahead and watch that video. I have provided the link in the description as well as in the I button. So before we move ahead with Pandas, I want you guys to understand the basic difference or the basic requirement why we need Pandas. Alright, so basically we saw in NumPy how we were able to perform various numerical as well as arithmetic operations on our arrays. That was basically a data given to us in the form of arrays, right? So why exactly do we need pandas, or what is pandas? Alright, so in order to understand that, I am going to go ahead and show you guys an Excel sheet. So as you can see over here, I have some data. So once you guys get familiar with data analysis, you guys will be able to tell me that this is something known as house price prediction data set. But we need not get into the details of that right now. So for now, all you have to understand is that there are different features or different columns representing the features of a house, right? So we have the square feet, that is the area of the house. We have the city, we have the state, we have the condition, we have the waterfront, which basically is telling us whether there is a waterfront. So basically 0 and 1 is how our data is being represented. Okay, so the number of floors, the price. All right, so we have all these features in our data. All right, now if I were to represent the same thing in a NumPy array, I would have my array something like this. Okay, so say I'm just representing two houses, and these two houses have two bedrooms, two bathrooms, okay, and the other house has just one bedroom and one bathroom. Okay, this is what my NumPy array would look like. Okay, this is basically my house 1, my house 2, and this is my bedrooms, and this is my bathrooms. Okay, so do you guys agree with me or not? Would our NumPy array look something like this or not? Except we wouldn't have this information with us. We would just have an array that would look like this. So this is the major issue that comes in NumPy when we are dealing with data. Okay, so since we only have two columns over here, maybe we can try and remember that the first one is bedrooms, the second one is bathrooms. But in case we have 12 or say 50 columns, how are we going to remember what each and every column is representing? So this is where Pandas steps in. Pandas is nothing but a tabular format of data, just how we saw in Excel. It gives us a similar representation of data in our notebook. Alright, so before we go ahead and see the demonstration with Pandas, first we'll understand why Pandas. So here are some of the important features that Pandas provides us. So it gets very easy to import our data sets. It could be a CSV file, it could be an Excel sheet, okay? It could even be your SQL database. So you can import any sort of data set in your Pandas environment. I'll be using Google Colab in this video, but you can use Anaconda or even your VS Code. Alright. Then comes your data cleaning. So this is a very important step. Now what exactly does data cleaning mean? So when we say data cleaning, we are talking about missing values and majorly the invalid values. Okay. So when we talk about missing values, okay, let me go back to my Excel sheet. Okay, so this is the data that I have, right? So say in case of this particular value over here, 10500, what if I had a blank cell over here? That would represent my missing value. Okay, so that is basically what missing value means. So if we have a particular data set and some of the values in our data set are missing, so whenever we're dealing with that kind of scenario, we will be dealing with those missing values. Okay, we will be seeing how we can do that with Pandas. And the other case is invalid values. So say I have an age column. Okay, now we know our age can normally range from 0 to 100. Taking the worst case scenario over here, we have 100 or say 120. Okay, it cannot go above that and it cannot go below 0. Alright, so this is basically a standard age range. But what if I have a value say 200 in my age column? Now this is basically an invalid value, right? I cannot have an age that is 200 if it's for humans especially. Okay, so I would understand that there is some typing error or there is some mathematical error, and the common way of dealing with this invalid value would be dividing by 10, right? So 20 is a valid age, but 200 is not. Okay, so that is basically what invalid value means. Size mutability. So we can easily add and delete columns or rows. Okay, then we can reshape our data set, we can pivot our data set, we can efficiently manipulate and extract from our data set. And most important step is statistical analysis. Okay, so we can easily have all the statistical analysis of our data with just a few lines of code. Okay, now moving on to the prerequisites to learn Pandas. So you need to know any programming language, preferably Python. But if you know any other programming language as well, it's not an issue. Okay, and the next one is maths. That is basically you need to know some stats or inferential statistics. You need to have a basic idea like what is standard deviation, what is variance, what is mean, median, mode. So basically you need to have a basic idea of all those terms. So moving on to pandas, we have two primary data structures in pandas. First is series, second is data frame. Okay, now what is data structure? Data structure is basically a collection of data types that provide the best way of organizing the items or the values in terms of memory usage. Okay, so series is going to be our one-dimensional data structure, whereas data frame is a two-dimensional data structure. Okay, now series basically represents only a single column from the entire data set, whereas a data frame is able to represent the entire data set. Okay, that's the basic difference. So let's go ahead. Okay, so series we already discussed is one dimensional. Why it's one dimensional? Because a series would look something like this. So say I have a price column and these values would be represented by an index value by default. Okay, and remember our index is always and always going to start from 0. So this is our series. Okay, so over here you cannot say this is a two-dimensional or it has two columns. This is the index and this is our one and only column. Okay, so this is why series is a one-dimensional data structure, because it can accommodate only one column and you can extend it to as many rows as you want. Okay, so it is a one-dimensional labeled homogeneous array. Homogeneous array means it can accommodate only either integers or string values. Now, it's not that if I were to add, say, a string ABC, I would get an error. Rather, if I were to add a value like this, all of my integers would be converted to string. Okay, so this is why series is called a homogeneous array, because if I add a single string value into my series, all of my integers are going to be converted into string, and my data type of this series would be object. Okay, if I were to have only integers, my data type would be integers. Okay, so this is basically what it means. And very important property is it is size immutable. Now what this means is I cannot delete a particular row from here. I can only remove it, and when I perform the remove operation, basically I am going to be returned a new string. That is, my string originally is not going to get manipulated, rather I'm going to be returned a new string where my values would look something like this. Okay, so this is basically what size immutability means. And even if we try to append a new element, we would be again returning a new series rather than manipulating or rather than changing the original series itself. Okay, now moving on to data frames. It is a two-dimensional data frame because we can have multiple columns. So we can have a price column, we can have number of bedrooms, number of bathrooms, and so on. Okay, we can have unlimited, or you can say n number of columns and n number of rows. So basically it can be extended in this direction as well as this direction, whereas series was able to extend itself only in this direction. Okay, and this is going to be a size mutable tabular structure, and it can be heterogeneous type. Heterogeneous means we can have, say, integers in this column and a string, all the string values in this column. Okay, so we can have multiple data types supported in data frames, and it is size mutable, means you're easily able to add and delete the rows and columns. Okay, so I hope the difference between series and data frame is clear. So let's go ahead and look at the implementation in our notebook. But before we do that, I hope you guys remember you are supposed to install pandas using pip install command. Let me just show you guys quickly. So you can go to your terminal or any command prompt, and all you have to do is type pip install pandas. When you run it, you're going to have a few lines of code run for you, and then finally you're going to get your requirement is satisfied, and then after that you can proceed with importing pandas as PD. Okay, so again, this is an alias. Just like we used an alias for NumPy, we are going to use one for pandas, which is PD. Okay, so I'm going to run it. And if you guys remember, I told you guys in the NumPy video that NumPy is going to be used throughout your data analysis process. So right now we are going to focus only on the Pandas features, but when we come to real data sets, which I'll be showing you, I'll be importing a real data set also using a CSV or an Excel file, and then I'm going to show you how NumPy and Pandas both are going to be used to perform various operations on that data set. Alright, but right now we are going to be only focusing on Pandas, understand the features and the implementation. Okay, so as you can see, I have successfully imported my Pandas, and the green tick over here basically represents that the operation was successful. Okay, so now what I'm going to do is I'm going to create a basic series using pd.series, and I'm going to do so using a list. Okay, now if I go ahead and print it, so you can see my data type is in64 because all of these are integers, and by default I got an index value of 0, 1, 2, 3 and 4. Okay, so as I told you, my index is always going to start from 0. And now if I were to add another element, say a string value abc, you can see now my data type is object, and all of these that were integers earlier have been converted into a string form. Okay, so I'm going to remove this for now because I want to show you guys some operations that we can perform in series. So I can go ahead and check the data type of my series. It's in64. Then I can go ahead and check the values of my series. Okay, so you do not need any parenthesis. So these are the values of my series data structure. So you can use s.index to check the index of your series. You can see over here my starting value is 0 and my stop value is 5 and my step value is 1. Alright, so basically I have my index from 0 to 4. So here you can get an idea about your index as well. Okay, and lastly you have s.name. So it's not printing anything because it's none. So if I print s.name, you can see it's none because we have not given any sort of name or any sort of value to a column. Okay, in order to assign a value to our column, we can just say s.name, and we can assign a value to our column, say those are just numbers. So I'm going to write numbers, and if I print my series, you can see this is what my series is going to look like. Alright, so that was it about the random functions. Now we're going to look at an important topic called indexing. Okay, so you can do indexing using square brackets like we normally do for lists, and we have also done for NumPy arrays. So similarly, you can do it for your series in Pandas. So if I want the first element, I'm going to say S0 and I get the first element, that is 10. Okay, so if I want multiple elements, all I'm going to do is S0 to 2, and you can see my ending index or my ending value is not included in my output. So let me just comment it over here, and then we have the step value. So we have done this indexing in list as well, and you guys are well aware that your starting value is always included, whereas your ending value is never included. Alright, so whichever value you want at the end, you give your stop value plus 1 to your desired value you want in the end. Alright, so say I want values at index 2 and 3. My syntax for that would be S2 to 4. Okay, so as you can see over here, I got my values at index 2 and 3. Alright, now another way to perform indexing is by using a function called ilog, which basically does location based indexing. So what this means is it is going to use the indexes, that is the 0, 1, 2, 3, 4 that you have as indexes, and it is going to fetch the values at those particular indexes for you. So all you have to do is say s.ilog and value at 3, and I print it, and you can see I got 40. So at index 3 I have value 40 and it's giving me the correct value. Okay, now if I want multiple values, all I have to do is s.ilog and use double brackets and pass all the indexes that I want my values at. Okay, so I want value at index 1, 3 and 4. So as you can see, I got my output just as I intended. So this was all about location based indexing. Now another important feature in series is that you can change the index according to you. Okay, so instead of 0, 1, 2, 3, 4, these numbers actually represent the calories. Okay, these are the different calories. So you can see I have changed the column name to calories, and now I want these calories to represent the fruit. Okay, so I'm going to create a list of all the fruits that are present in my carries. So you can see I've created a random list of fruits and I've stored it in the variable index. Now what I'm going to do is I'm going to say s.index and I'm going to pass my index variable. And then I'm going to print my series. So you can see over here, I am basically trying to say my apple has 10 calories, banana has 20 calories, grapes has 30 calories, and so on. Okay. So this is how you can change your indexes according to the information you are trying to represent. Now do not comment that I have put wrong calories for the wrong fruits. This is just a random data that I have created just to show you guys how indexing works. Okay. So now if I try to access any value using my indexes, so if I want to find the calorie of grapes, I can just say s grapes, okay, in square brackets. Now can I use ilog function over here? Let's try it. Okay, so I get an error because this is not a location anymore, right? So when I had my numerical indexes, ilog was working absolutely fine. So I can still use ilog, but for my numerical indexes, right? The original indexes, that is, we have indexes in lists, we have indexes in NumPy, we similarly have indexes in series as well, okay? So we can do that by ilog, but again, how will we remember what is index 3, right? So that is why we have another function called log. This is label based indexing, okay? So using log, we can go ahead and say, and you can see I get my value, okay? Now another important thing you need to remember is in label based indexing, your start as well as stop value both are included in the output, okay? Now this is a very important thing that you need to remember because unlike normal indexing or the indexing that we do in list, numpys and all, whenever we're using a normal list, our stop value is never included. Alright. Now say I want my calories of banana, grapes and orange. Okay. So what I'm going to do over here? So you can see my banana, grapes and orange. So all three of them, that is my starting value as well as my ending value, both have been included. I hope label based indexing and location based indexing, that is your normal indexing, the difference between both of them is clear. Difference between log and ilog is clear. Okay. So let me give you guys a quick recap. We learned how to create a series using a list. Okay. We saw the default indexes. We saw the default name, which is none of the column. Then we saw how to check the data type of the series. We saw how to check the values and the indexes of the series. Then we saw how to rename our column or the series, okay? And then we went ahead and looked at indexing. We saw normal indexing. We saw indexing using ilog, okay? Then we went ahead and changed the index of our series. We gave a different set of indexes to our series using s.index equal to the new index. And then we went ahead and performed indexing on our labels. That is, we used the new indexes to index the values. And then we also looked at the label-based indexing, that is using log. Okay. Now, if I want to access multiple elements over here, multiple values, again, I have to give double brackets and I can say grapes and then I want apple and I can print it. So you can see I got my desired output. Okay. So that is all about indexing. Now let's also see how we can create a series using a dictionary. Okay. So I have already created a dictionary for you guys, which is basically fruit protein. So our keys are the fruits and our values are the proteins or the grams of protein stored in that particular fruit. Okay. So this is our dictionary. Now if I want to create a series out of this dictionary, all I have to do is say, I'm going to name it S2 because this is my second series and I'm going to say pd.series fruit protein and I'm going to print it. Okay, so you can see, and by default, the name of our column over here that is representing the protein is 0. So I can go ahead and say name equal to protein. Let's run it. Now my series is giving us a complete information of what our data is representing. Okay, and you can see the data type over here is float. Okay. Again, you can go ahead and perform the similar kind of operations on this particular series. I will be sharing this notebook with you guys in the description below so you can download it and do the necessary operations that we saw in our earlier series, that is our series S. So all those operations can be performed on this particular series as well. So I want you guys to pause the video, download the notebook and perform these operations. And if you guys face any doubt, comment it in the chat box below. I will respond to you guys at the earliest possible. Okay? Alright, so I'm assuming now you guys are done with the earlier operations. Now we'll be looking at something important and something new, which is called conditional selection. Okay? Now what conditional selection basically means is, now I want to fetch all the fruits over here that have protein greater than 1. Okay? I want to find out all the proteins that are greater than 1. So what I'm going to do is, I'm going to say S2 greater than 1. Now you can see over here I've got boolean values that are representing true and false. So wherever I have protein greater than 1, I got a true. And wherever it is less than 1, I got a false. Okay? But what if I want only those rows in my output that have the value greater than 1? So what I'm going to do is I'm going to put this conditional selection statement inside my series. So I'm going to pass it inside my original series and you can see I got the result. Okay, so all these fruits have protein greater than 1. Okay, so this is basically how conditional selection works. It is first going to provide you with a mask series, which is basically a series of boolean values true and false. And if you pass that masked series into your original series using square brackets as we just did, you get your desired output. So our next topic is logical operators. Okay, logical operators we have and, or, and not. So I hope you guys are clear with what is and, or, not. Okay, if you guys are not, let me just give you guys a quick example. Okay, so say I have two values, one is true, the other is also true. Now if I do a and between these, if I perform an and operator between these, my result is also going to be true. Okay, now if I have a true and a false and I perform an and operation between these two values, my result is going to be false. Okay, similarly if I have a false first and a true later on and I do an and operation, my result is going to be false. And if both my values are false, my result is again going to be false. Okay, so we need both our values to be true in order to have a result true. Okay, but in case of or, any one of our value has to be true. This is going to be true. But if I have true or false, it is again going to be true. Okay, if I have false or false, then it is going to be false. Okay, so this is basically and or. Okay, now let's see how it is used in a series. So say I want to give a range. Okay, I want to have all my fruits, or I want to see all those fruits which are greater than 0.5 but less than 2. Okay, so all I'm going to do is S greater than 0.5 and S is less than 2. So this is the syntax that you have to follow. Okay, so you can see I got the true and false values. Now if I want to find only those rows which satisfy this condition, so you can see all these values are going to be between 0.5 and 2. Okay, I can see I can say less than or equal to 2, and now I have my fruits which have the protein value equal to 2 as well. Okay, so this is how AND is performed. So basically what happened there is, wherever we had 0.5 and greater but less than 2, this range was passed to us when we use the AND operator. Okay, now if I were to use the OR operator in this particular scenario where I'm trying to find this range, would I get this desired output? No. For the OR operator, my first condition would be greater than 0.5. So I would get all my values that are greater than 0.5. And then my second condition would be less than 2. So I would get all the values which are less than 2. That means below 0.5 as well. Alright, so as you can see over here, I have 0.3 and I have 2.6 as well in my output. So this is basically telling me that I have used an OR operation over here. Okay. So similarly, you can use and or, and you can also use your not operation. So I can say I want all my values which are not greater than 1. Okay. So you can see all these values are smaller than 1. Okay. So this is how the logical operators like and, or, and not are performed. And then finally, we have a topic of modifying the series. Okay. So say instead of my calorie of mango to be 0.8, I want it to be 2.8. So what I'm going to do is, just like a normal list, I'm going to go ahead and say S mango and I'm going to say 2.8. Okay. So it's run successfully. Now if I print my series, you can see my mango protein has been changed to 2.8. Okay. So this is how you can modify your series. Okay. At any particular index, you can change the value. You can also change the index, but you will have to pass your entire index again. Okay. So this was all about series. Now we are going to move ahead with data frames. So I hope series was clear. If you guys have any doubt, comment your doubts in the chat box below. I will respond to you guys as quickly as possible. And do make sure that you guys have this particular notebook downloaded in your systems and you guys are working with me side by side. So that's going to make the entire process more fun. Okay. So far you guys have gotten a basic understanding of series and we have already covered NumPy. So I have a question for you guys. So basically I have a series and I want you to find the answer of this particular query. Okay, so if I say s dot not null and I say I want a sum of all the values that are not null, I want you guys to quickly comment the answer in the chat box and tell me what's going to be the answer in if we run this particular query. Okay. So moving on, let's look at our very next topic, that is data frame. So it is important and very interesting if you guys understand it carefully. So basically I have some data in the form of dictionary, as you can see over here. So I have some names, I have some ages, and I have some departments and salaries. Okay. And now I want to convert this particular. So if I print this data, it's going to look like this. Okay. It's not very neat and it's not very easy to understand. So what we're going to do is we're going to go ahead and convert it into a data frame. And let me just print the data frame for you. Okay. Alright, so I have this particular data set with me. So if I want to see just the starting values, I can just say df.head and say I want to see the first two rows. Okay, so I can do it using .head function. And if I want to see the last values, I can just say df.tail. Okay, so by default, the parameter over here is 5. But if we want, we can tailor it to our own needs. So I want to see the last three rows. So you can see 5, 4 and 3. Okay. So moving on, we can again use our lock and ilog functions just like we did with our series. So say I want to fetch the first and second row of my data set. So what I'm going to do is I'm going to say df.ilog and I'm going to say 1 to 3. Okay. So you can see I have my first and second row and all the columns. Okay. So now in case of all these columns, what if I want only department and salary in my output? So what I'm going to do is I'm going to say df.log. So instead of ilog, I'm going to use log and I'm going to say rows 1, 2, 3 and I'm going to say I want columns age and department. So I'm going to have a comma over here to separate the columns. So you can see over here I have age and department and my 3 rows. Okay. So we discussed earlier, whenever we use the log function, our starting as well as ending indexes are going to be included. So I have 1, 2 and 3 rows instead of just 1 and 2. So if I want just the 2 rows, I have to say 1 and 2. Alright, so I hope this is clear. Okay, so we can use ilog and log in this manner. But if I wanted to include my first and second column in my ilog column itself, so you can see I have my first 2 columns in my output. Okay, so basically when we're using ilog for data frames, we have to pass our rows and our columns, and the range for these are going to be separated by a column. Okay, so we can do that using ilog and log. So we'll be using this a lot. Okay, direct indexing in a data frame gets a little complicated, so that's why we'll be only using ilog and log functions. Okay, so you can go ahead and play around a little with ilog and log and try to access different rows and different columns. So now we'll be moving to accessing only an individual column. Okay, now if I want to access just one particular column, all I can do is say df_age. So this is how I get only the age column. Okay, now if I want multiple columns, I have to add another bracket And I can simply separate my columns and say I want age and department. So you can see this is how I get my output. Okay. Now what if I want to drop this age column? Okay. So you can see I have a null value also over here. Now I want to drop this age column because I feel it's not very relevant to my data set. So how I can drop it is I will just say df.drop and I will say age. Okay. And I will pass axis equal to 1 because I want this entire column to be gone. Okay. If I want a particular row to be gone, my axis would be 0. Okay. So it is a particular row wise operation. But if I want a column gone, I want my axis to be 1. Okay. So if I run it, now you can see my age has been disappeared from this particular output. But if I print my data frame, you can see the age is still there. Okay. So until and unless we use the parameter in place equal to true, by default in place is equal to false. Okay. So in place is basically telling us to perform the operation in the original data frame. Okay. So if we want the changes to be displayed in our original data frame, we are going to use in place equal to true. Otherwise, by default, it is going to be false and it is only going to return a new data frame and our original data frame is going to remain unchanged. Okay. So as you can see, it has been unchanged. Now this is a missing value over here, this and this. So we'll be dealing with these missing values later on. But first let's understand a few more functions. So we can go ahead and check the shape of our data set using df.shape. So this is telling us that we have 6 rows and 4 columns. Okay. 1, 2, 3 and 4. Okay. So again, the indexes are not counted as a part of a column, just like we did in series. Okay. So these are by default values over here. And we have 6 rows. Okay. So we basically have 6 samples. Okay. These are known as samples. This is the sample sets. Okay. So we can also go ahead and check the data type of our data frame. So we can also go ahead and check other information about our data set. So using info. Okay. So this is telling us that we have these particular columns: name, age, department and salary. Okay. And these are the data types in our column. So we have 2 columns having float data type and 2 columns having object data type. Okay. So name has object data type, age has float data type, department has again object data type and salary has float data type. Okay. Now over here we have a non-null count. Non-null count basically means that we have 6 non-null values, that is we have total 6 samples and all of these 6 samples are non-null. Okay. So basically in the name column we have 0 null values. Okay. And we move to the age column and over here we have 5 non-null values. That means we have 1 null value over here and over here also we have 1 null value. Whereas over here we have 0 null values. Okay. It is also displaying the memory usage to store this particular data set. Okay. And another operation that you can perform on your data set is describe your data set. So over here you get statistical information on your data. So over here we only have 2 data sets that are of type float or integer. Okay. So we can perform these particular operations, that is the count, mean, standard deviation, minimum value, and these 25%, 50%, 75% are basically the outliers in our data set. Okay. And the maximum value. Okay. So using the describe function, you get a basic information about your data, like you have 5 values in your age column and 5 values in your salary column that are present. Then the mean value of your age column is 28, whereas mean value of your salary column is 58400. Standard deviation is this. The minimum value of age is 25 and minimum salary is 50,000. Then you have other information about your data set. Okay. So in NumPy, we saw an important concept called broadcasting. Okay, we also looked at the rules for broadcasting. Now we'll see how broadcasting is performed in Pandas. Okay, so I have a salary feature over here. So our columns are also known as features. Okay, so these are our columns or our features. Okay, so if I want to say increase the salary of all the people over here, okay, of all these people, I want to increase the salary by say 5,000. All I have to do is say df salary and I will say df salary plus 5,000. Okay. Now you guys must be wondering, this is a scalar digit or an integer whereas this is a one-dimensional array, right? If I just print df.salary, let me go ahead and print df salary. If I print this, you can see this is a one-dimensional array, right? This is basically an array having 5 rows and 1 column, right? And this over here is just a scalar value. Now I want to increase all these values by 5,000. So do you think if I perform this particular operation, I will get an error or will it successfully perform? So if you guys said it will successfully perform, you guys have understood broadcasting really well. So if I go ahead and print my salary now, so you can see it has been increased by 5,000. Okay. So what's happening over here is instead of treating this as a scalar value, it has been broadcasted to match the shape and size of this particular column. Okay. And then the operation has been performed over here. Cool. So moving on to the next concept, we have renaming columns. That is, we can rename the columns in our data. Okay. So if I want to rename a column, all I have to do is call df.rename and pass my columns. Okay. So I want my department column to be displayed as DEPT. Okay. And I'm going to say in place equal to true because I want this operation to be performed in my original data set itself. Okay. So if I go ahead and print my data, so you can see my department has been changed to DEPT. Okay, so this is how you can go ahead and rename your columns using .rename function. So you can also go ahead and check the unique values in your data for a particular column. So I want to see all the unique salaries in my data set. So you can see over here, these are the unique salaries in my data set. Okay, I can check it for another column. So I can check the unique departments. So again, these are case sensitive. So if I check the unique departments in my data set, so I have 3 unique departments, that is HR, IT and finance. Okay. Now, if I want to see how many employees are in which department, I can go ahead and do the value count of these departments. So I will say DPT dot value counts. Now, as you can see over here, HR department has 3 counts, IT has 2 counts and finance has 1 count. Okay, so basically it's telling us that there are 3 people in HR team, 2 people in IT team and 1 in finance team. Okay, so this is how you can check the distribution of one particular column across your data set using value counts. Now, what if I want to create a new column called promoted salary? That is, I want to check the salary of all the employees after the promotion. Okay. So say some of my employees have been promoted and I want to create a promoted salary column in my data set itself. So if I want to do that, all I have to do is say df original salary, and after the promotion, their salary is going to be say multiplied by 10. Okay. So if I run this particular query and then print my data set, my data frame, so you can see the salaries have been increased in my promoted salary column. Okay. So they have been multiplied by 10. Again, this is a broadcasting rule again. Okay. So this is how you can go ahead and create a new column in your data set or your data frame. Alright, so now that we have learned how to create a new column, I think it's time to dive into data cleaning. So as you can see, we have a few null values in our data set. So I want to get rid of them because till I have those, I will not be able to perform some operations, plus it doesn't look very good. Okay. So first I'm going to check how many null values exactly I have. So all I did was I checked for my null values inside the entire data set and then I did a sum of all those values. So as you can see over here, my name column has 0 null values, my age column has 1 null value and my salary column also has 1 null value. And so does my promoted salary column. Okay. So I have a few options over here. I can either just get rid of all the rows that have these null values. Okay. So I can do that by using df.drop na. Na stands for null values. So I'm basically dropping all the null values. And if I just run this prompt, if I just run this without any sort of argument or without any sort of parameter, as you can see, I'm just left with 4 rows. Okay, so basically any row that had null value has been removed. And again, I have not used in place equal to true, so my original data set is still untouched. Okay. So this is basically just a new sort of data set that has been altered and returned so that I can see how it's going to look. All right. So by default over here, you can see my argument of how I want my null values to be deleted or dropped is any. So basically any row that has any sort of null value has been dropped. Okay. So if I run this using how equal to any, so again my result is the same. So we saw one sort of parameter in drop NA, that is how equal to any. Now the other parameter in drop NA is all. Okay. Now the other argument that drop NA takes is all. Now what this is representing over here is particular row. Okay. When we said how equal to any, we were just saying any row that had any null value. Okay. So whichever row had any null value was dropped. Now over here we are saying if all the values in a row are null, we are going to drop that row. Otherwise we are not going to touch it. Okay. So we do not have any row that has all the null values. We just have this row that has 2 null values, but again we have 3 non-null values as well in this particular row. So again none of my rows were altered and the data remains as it is. Okay. So this is one option when we are dealing with missing values. We can just get rid of those null values. Okay. The other way is to fill those missing values. Now how I can do that? So let me just find, okay, here is my null value, right? So I can either fill this null value with the most repeated value in this particular column. Okay, that is one option. Let me just write it down for you guys. Okay, so dealing with missing values is one of the most important aspects when it comes to a data set, because you will be dealing with a lot of unclean and messy data sets, and missing values is going to be one of them. Okay, so let me just write missing values. So one way of dealing with missing values is getting rid of them, which we just saw by using drop NA. Okay, and the next one is by filling them up. And for filling those missing values, we use the function fill NA. Okay, so this is the second method. Let us see how it works. Okay, so all I have to do is say df.fill NA. Okay, and let me just run it. So I must specify a fill value or a method. Now I want to fill all the null values with say 0. So you can see this is what my data set is going to look like finally. Okay, but this is again a very noob method to perform on a data set, because I do not want my age to be 0 or my salary to be 0 just because it's missing, right? So instead what I can do is, for my age column, I am going to fill all my missing values with the mean. Okay, and I'm going to say, okay, let's not keep it in place equal to true because I do not want to modify my original data. But if you guys want to, you guys are free to do it. Okay, so I'm just going to replace all my missing values in the age column with the mean of the age. Okay, so initially my third row had a missing value and now it has been replaced with the mean. Alright. Similarly, for the salary column, what I'm going to do is, if I replace it with the mean, it's not going to be very technically or mathematically correct. So instead, what I can do is, I can replace it with the median, right? I can go ahead and replace my salary in my DF column, and I'm going to say I want it to be filled with the median of my salary. So you can see over here, my fourth row was missing in my salary column, and now it has been filled with the median value. Okay, so this is another way that you can fill your missing value. Okay, now this is something that we can do mathematically, right? But what if I want to just randomly fill my value? So this was the missing value, right? So there is another method in fill NA. Instead of providing a default value, what we can do is something known as forward fill. So basically when we use fill NA, we have two methods, forward fill and backward fill. So in forward fill, what happens is we move from top to bottom, okay, and say this was our missing value. So when we use forward fill, 35 is going to be replaced in our missing value. Okay, and similarly, when we do backward fill, 29 is going to be replaced for our missing value. Okay, so this is basically what forward fill and backward fill means. So let us quickly go and perform forward fill first. Dot fill na, and in our method we're just going to pass forward fill. Let's run it. So you can see 35 has been replaced in our missing value column. Okay, so it has been done using forward fill. Similarly, I can perform a backward fill. So you can see 29 has been replaced in my missing column. Okay. Now, using these methods, backward fill and forward fill can be a little tricky, and they can also give you errors in cases where your first or last value is null. Okay, so in case your first value is null and you try to do a forward fill, your first value will still remain null. Alright, and same goes for backward fill. If your last value is null and you do a backward fill, your last value will still remain null because there won't be any value before that to replace it with. Alright, so in cases like that, we go for statistical operations like mean, median, mode, alright, according to what's more technically sound. Okay, so these are some of the methods to deal with your missing values. Okay, so now we saw how we can deal with missing values. Now we'll look at another operation where we can say replace a particular value randomly. Okay, so say instead of Charlie over here, I want to replace this name with another name. So now, just because we did not use in place equal to true throughout our queries when we were dealing with our missing data, does not mean we have not already dealt with them. We have already dealt with our missing data, and currently we shouldn't have any sort of missing values in our data set. Okay, so moving on, I want to just randomly replace this particular name, say with Rose. Okay, so I want instead of Charlie, I want Rose in my name column. I just have to say df dot replace. Okay, df in the name column. Okay, I have to specify the name. Sorry, I have to specify the column, and I have to say replace Charlie with Rose. Okay. So as you can see, my operation has been performed successfully. Okay. And again, if I wanted this change to be reflected in my original data set, I would have to say df name, and I would basically be storing the change in my original data set. And now I can go ahead and run it. So as you can see, I have changed the name from Charlie to Rose in my original data set as well. Okay. So this is how you can make your changes permanent. Okay. Alright, so let's look at the next concept when we're cleaning our data, that is dealing with duplicate data. Okay, so we already saw how we deal with missing values. Now we will see how we deal with duplicate values. Okay, so as you can see in this particular data set that we have over here, we have the entry Alice twice. Okay, and as you can see, the age, department salary, and the promoted salary, they match for both these records. Correct? So how do we deal with duplicate values? So we already have an inbuilt duplicated function. So in order to check for all the duplicate values, all you have to do is say df.duplicated and pass it in the data frame variable. And when you run it, and your output will be your second repeated record in your data set. Right? So we are not going to consider this as duplicate. Rather, we're going to consider this as duplicate. So let's see how duplicated works. Okay, so say I have a record over here of different countries. Okay, so I have Italy, France, Greece, and then Italy again. Okay, so if I go for duplicated method, what happens is we work our way from the top itself to the bottom. Okay, so first I'm going to check for Italy. So Italy is not present. No problem. I'm going to simply add it to my list, or a list where basically I'm keeping a track whether an element is duplicate or not, right? Then comes France, so it's not there, no problem, I add it to my list. Then we come across Greece, no problem, I add it to my list. Then I come across Italy, which is already present in my list. So therefore, this element is going to be marked as duplicate. Alright. So this is basically how the duplicated method works by default. Alright. So basically we can pass a parameter called keep, and we are going to say keep first. Okay, so let's see what happens now. So you can see our first element is not going to be marked as duplicate. So this is basically by default the parameter that duplicated takes. Okay, if I say last instead of first, you can see my first element is marked as duplicate. Okay, so when we say keep last, basically we are going to work our way from bottom to up. Okay, so that's why this element is going to be marked as duplicate. All right, so I hope this is clear. So if we want to drop this duplicate value, all I have to do is, okay, so I'm not going to pass anything because I would prefer my second record to be deleted. So I'm just going to run it. So if I print my data set, you can see my duplicated record, that was the second record, has been removed or deleted from my data set. All right. Okay. So I hope the data cleaning process is clear. We have learned how to deal with missing values as well as duplicate values. Okay. All right. So let's see how we can deal with invalid values. Okay. So since I want to make the changes in my promoted salary column, I have simply written df and promoted salary in the brackets. And now in order to do these changes in the column of a particular data set, I will be introducing you guys to a very important topic or an important function called lambda. So you guys must have studied this in Python as well, right? So all we have to do is promoted salary, and I will say apply lambda x, and I'm going to say divide that x. X is nothing but the records of my column promoted salary. So this is my input variable x and this is my output variable x divided by 10. But I have a condition if x is greater than 6,50,000, right? Else, if it is not greater than 6,50,000, I'm simply going to return x. All right. So let me run it. Okay, so it has run successfully. I'm getting some sort of documentation, but I'm going to ignore it for now. Okay. So as you can see, the two records that I had that were greater than 6,50,000 have been divided by 10. Alright. So this is how you can deal with your invalid values using the lambda and apply function. Alright. So this is the syntax for that. So moving on, we'll also look at some string functions. So in this particular sample data set that I have taken, we do not have any sort of explicit need to do these string functions. Okay, so maximum times whenever you have a string input, okay, so say the names. Over here, I just have the first name, but in case I had a name like Alice underscore, say, Fernandez, okay. So in order to deal with inputs like this, all I would have to do was df, and I would create two separate columns saying first name and last name, okay. And then all I would do was df and I would split my name column. So basically I'm using name as this name instead of my column name because I do not have any sort of input like this which I want to demonstrate to you guys. Okay. So even though this is not a column per se, this is just a variable that I've created and I'm pretty sure I'm going to get an error. Okay. So I am going to split it using string dot split method. Okay, and I want to split it based on underscore. Okay, so wherever I have an underscore, I want to split my string. Okay, so in case instead of underscore all I had was a space, I could use an empty string over here. Okay, but since I have an underscore between my first string and my second string, I'm going to split it based on my underscore. Okay, and let me see if I run it, what's going to happen. Okay, so I do not have any column name, but again, this is how you would split your data set. So obviously this code is not going to run for me because I do not have any column called name, and wherever I have name, I do not have any sort of connectors between two strings. These are just single names. All right, so I will not be able to split these particular strings over here that I have. So this is just a demo for you guys that in case you have a column like this is how you're supposed to deal with it using string.split method. Alright. So now that we are clear with data cleaning, I want to show you guys a few more examples of apply and lambda. Okay, so because there will be instances where these methods are going to be very useful because they let you change the single entries of a column or a row, right, based on particular conditions. All right, so let me create another scenario where I want to multiply the age. Okay, I want to multiply all the ages by 2. Okay, so all I'm going to do is age, and then I'm going to call my age function age column over here, and then I'm going to say I want to apply. Now instead of passing lambda, what I can do is I can go ahead and create a function where I am multiplying my age. Okay, I'm going to have my input as x, and then I'm going to simply return x into 2. Okay, so instead of calling lambda over here, what I can do is I can say multiplying age and pass x. Okay, so it will not take any input. I'm sorry about that. So let me run it. Okay, so now if I print my data frame, you can see my values of age have been multiplied by 2. Okay, so let me bring back my ages to the original value. Now this time I will use lambda instead of creating a function by default. Okay, and I'm going to say apply, and I'm going to pass lambda, and I will say x, and I will say x divide by 2. Okay, now there are no conditions, there are no if else conditions. I want all of these entries in the age column to be divided by 2, so I'm not going to pass any if else like we did previously, right? So I'm going to run it, and if I print my data frame, my ages are back to the original values. Okay, so this is how lambda and apply functions are used, and you will be using them quite a lot. Okay, so moving on, I want to tell you guys about another very important concept, that is joins and merges. Okay, now in order to understand joins, let us go through a quick overview of what are joins. Okay, so consider this scenario where I have two data sets, A and B. Okay, now when you're dealing with large data sets, it's not necessarily that you're going to have all the columns in one particular data set. Okay, so if you guys remember, I showed you guys an Excel sheet of various columns or various features of a house, right? Number of balconies, number of bedrooms, the location, the state, and so on, right? Now I had all those columns in one particular sheet. But what if I had two sheets, A and B, where in one sheet I only had, say, the features of the house, that is, the number of bedrooms, the number of bathrooms, the balconies, and in another sheet I had the different features, say when the house was built, where it's located, what's there nearby, and stuff like that. Okay, so I had two separate sheets. Now I want to combine these sheets. All right, so there are different methods. So if we talk about joins, there is left join, right join, outer join, and inner join. Okay, these are the joins that exist. And another method is to merge. Okay, merge is similar to inner join. All right, so let's quickly see what left join would look like. So if we were to combine these two data sets on, say, a particular property, and we perform a left join, our left side of the data set, okay, whatever there is common between the two data sets is going to be ignored. Whatever exists in only data set B is going to be ignored. Rather, we are going to have something that is solely available with data set A, and this happens in left join. Okay, similarly in right join it happens the opposite way. We're going to have only the properties of B in our data set. Okay, and when we perform a full outer join, we're going to have everything of A and B. Okay, so each and everything that we have in A and B is going to be included in our outer data set, sorry, outer join. And when we perform an inner join, it basically happens over here. Okay, only the common properties between A and B. And when we merge two data sets, we merge them based on this particular common column, and whatever properties A and B have, both are visible in our merged data set. Okay, so let me say this is another data set. So let me just convert it into a data frame. So I'm going to call it df2, and I will say pd dot data frame, and I will pass my department. Okay, So let me just print my other data frame. So as you can see, this is my second data set. So now if I want to combine the information from this data set and the data set that I had earlier, I have something known as concat. Okay, so concat is going to let me merge the information from both these data sets. So if I use pd.concat and pass the two data sets that I have, this is the output that I'm going to get. Okay, so since in our second data set we have a location and manager, but we do not know which employees have this location and this manager, we have a null over here. Okay, so by default both my data sets are being combined in a horizontal manner, that is they are being stacked horizontally, right? So wherever I don't have the names, I am getting null, and wherever I don't have the location and manager information, I'm getting a null. Okay, but if I were to do the same operation column wise, that is if I were to combine these two data sets in this particular direction, I would have to say pd.concat, pass my two data sets df and df2, and I would say I want it to be joined on axis 1. So as you can see over here, wherever I have department HR, my location and manager is for the department HR, right? So this is how you can combine or merge two data sets using pd.concat. Okay, there is another function called pd.merge. Okay, so you can pass your data sets df, df2, and I want it to be merged on my column department because that is the common column. So as you can see over here, my department is being repeated twice. But if I do not want that to happen, I can use merge, and as you can see over here, my department column appears only once and my data is managed accordingly. So wherever I have HR department, I'm going to have my location as New York and manager is going to be Laura. Okay, it is, you can see it over here as well, New York and Laura. Alright, so this is also how you can merge or combine your two data sets into one. Okay. So these were basically all the operations that were there to know on data sets. The basic operations, obviously, as you go down the line, you deal with bigger data sets, your operations get more complex, but this is the standard basic base that you require to get started with Pandas. Alright, so now we're going to look at how we can import a complete data set file, that is an Excel or a CSV file in our notebook. So since I'm using a Google Colab notebook, I cannot directly pass the entire path of my file or my CSV or Excel sheet. If you're using Anaconda or VS Code, you can do that. So if you're using those platforms, all you have to do is right click on your data set and click on copy as path and create a variable and just say pd.read underscore CSV because this is a CSV file, and all you have to do is pass the path inside the parenthesis as an argument. Alright, but since this is a virtual environment and it is not going to be able to access my local environment, what I have to do is I have to upload my data on Google Colab. Okay, so I'm simply going to select it. So as you can see, it's uploaded over here. Okay, so now all I have to do is in quotes, I have to say data.csv. So you can see it's run successfully, and now I can do data.head. That is, I'm trying to get the first 5 rows of my data set. So you can see this is the date, price, bedrooms, bathrooms. So I can easily access all the columns and I can go ahead and perform the basic operations, like I can check the shape of my data set using data.shape. So I have 4600 rows and 18 columns. All right. So accessing such information in an Excel sheet would have been a much more difficult task. So this is why we use Pandas, which helps us gather information like this in a much more efficient and easy manner. All right. So I can also go ahead and check the information of my data using data.info. So you can see I have 4600 non-null values. That means I have 0 null values in my entire data set. I have 0 null values. Okay. So you can also check the data type of each and every column. Now you can see over here, this is an object data type, but date is supposed to be in a time format, right? You're supposed to be able to access the day, time, and year of a particular date in an efficient manner, but this is stored in an object manner. All right. So I'm just going to quickly show you guys how you can convert this date time from an object to a time. Okay, so this is the syntax that you have to follow. So I'm going to pass my date, and then I'm going to use pt.datetime to convert my date from object to, okay, so it is data. Okay, so as you can see, it has been executed successfully. Now if I go ahead and check my information of the data, you can see it is converted to date time format. All right, so this is how you can convert your date time features into the valid format using Pandas. All right, so this is again only a one line code, but you should be aware that it can be done, and this is how you bring your data to the correct format. All right, so this was it for this video. I think we have covered almost everything there is to know about Pandas, and I'm sure you guys got a basic understanding of how you guys can implement Pandas on even a large data set. And I am going to give you guys this notebook link in the description, so you can go ahead and download it and practice on this data set, or you can download data sets from Kaggle. Let me show you guys the website. So you can go ahead and type Kaggle and click on the first link that you get. Register on this website and you get hundreds and thousands of data sets for absolutely free. You can download them, and you can also go ahead and check out the discussions if you face any issues or doubt, right? So get started with your Pandas journey right away. So before we get started with the implementation of Matplotlib, I want to quickly show you guys the anatomy of a Matplotlib figure. So a figure in Matplotlib is basically the entire window or page. It's basically the entire canvas that represents the various components like legends, your axes, the grids, your labels, everything, right? So all the components are contained inside a figure. So let us quickly go ahead and see what are these different components. So first we have the axis. So we have x-axis and the y-axis, and what these axes are representing is basically shown by the labels. So we have x-axis label and y-axis label. So say for example, I have the data of number of hours studied versus the marks scored. So I can represent my x-axis as the number of hours studied, and I can label it as number of hours studied, and similarly I can do it for y-axis label as the marks scored. So I know what I am showing on my plot. Then there's something known as ticks. So we have major ticks and minor tick labels. So major tick labels are basically these marks that you can see on your axis. So 0, 1, 2, 3, 4 are basically your major tick labels, and your minor tick labels are the in-between marks like 0.25, 0.5 and so on. And then we have something known as a legend. So this basically represents what each color or mark is representing. Right, so over here we have a blue line and a red line. So whatever these blue lines and red lines are representing, that can be shown in a legend. Then you have your grids. So these are the dotted lines that help you figure out or read your plots in a more efficient manner. Then you can also label your entire figure. So you can give a title to your figure using the title component. So that is pretty much it about a figure. So these are basically the major components inside your figure. As we go ahead, we will see how to tweak these different components according to how we want our figure to look like. Alright, so in order to get started, I want you guys to quickly open any terminal and just run the command pip install matplotlib. And once you run it, you will see a few lines of code run over here for you. And finally, when you get the message requirement satisfied, that means your library is installed successfully. Now, once your library is installed, you can go ahead and import it in any environment that you like. I'm using Google Colab. You can use VS Code or Jupyter Notebook, right? According to your preference. So I'm going to go ahead and import my matplotlib. If I run it, so it's imported successfully. So along with my matplotlib, I'm also going to import pandas. And if I run it, so both my libraries are imported successfully. So just to give you guys a basic gist of what matplotlib does, I'm just going to create two variables for you guys. So I have my variable x as 1, 2, 3 and my variable y as 4, 5 and 6. Okay, so these are my x and y variables. Now, in order to plot these variables using Matplotlib, all I have to do is say plt.plot, pass my variables x, y, and just say plt.show. And as you can see over here, this is what Matplotlib gives me. So over here, what Matplotlib is trying to do is, it is trying to plot my data like this. So 1, 4, then I have 2, 5, and then I have 3, 6. Okay, so these are the variables that I passed, and this is the data that Matplotlib is trying to plot over here. Okay, so if you go ahead and see 1, 4, 2, 5, and 3, 6. So if I want those dotted grid lines that we initially discussed in our figure, all I have to do is say plt dot grid and run it. So now you can see I have my grid lines. Now it gets much easier to read my data in a more efficient manner. Now I can easily spot that this particular dot represents 2, 5 and this particular spot represents 1.75, 4.75. So now you're easily able to figure out what each of these points on this particular line represent. Right? So this is basically the major idea or the major implementation of Matplotlib. Now using this functionality of Matplotlib, we are going to try and plot different kind of plots for different data sets. So as we discussed earlier, Matplotlib has two types of plotting. So one is using the PyPlot API and one is using object-oriented API. So first we're going to cover the PyPlot API. So let me just write it down that we are only going to discuss PyPlot API right now. In the end of the video, I'm going to discuss how you can use object-oriented API as well. Okay. So in order to understand which particular plot is to be used for what kind of data, let me quickly introduce you guys to univariate analysis. So a univariate variable basically focuses on one variable at a time. It could be a height, weight, or a category like yes or no. Alright, so first we're going to cover the numerical column. So in order to understand, let me just create a data where I have a column salary and it looks something like this. Okay, so this is my salary column and this is just a dictionary and I have to convert it into a data frame. So I'm going to call my data set df and I'm going to say pd dot data frame and I'm simply going to pass my data. Now if I try and print the first 5 records of my data set, this is what it's going to look like. Okay, so this is my salary column and these are my records. Let me also go ahead and check the total number of records in my data. So all I have to do is say df.shape and if I run it, so I have 20 records and I have only one column. So over here I have 20, 1. Alright. So now in order to visualize this particular column in my data frame, the first plot that I have is a line plot that we have already seen, but now we're going to see it in much more detail. So in order to plot a line plot, all I have to do is plt.plot. And in my parentheses, I just have to pass my column inside my df variable, that is my data frame, like this. So if I run it, so this is basically how my salary column is varying. Okay. So at some point it is really high, that is the highest salary is going to 55,000, whereas the lowest salary is somewhere around 25,000. Okay. Now what I can do is I can also go ahead and make some changes in my plot. Like I can say I want my color to be red and I want my grids to be shown, and I can also have my markers. So I can have my marker as letter O. Now what this marker is going to do is wherever I have a data point, it is going to be marked. So for example, over here, basically wherever I have a data point, it's going to be marked with the letter O. I can also go ahead and change the line width. Let me just run it. So as you can see, my color has been changed to red. I have grids in my plot and my marker is being represented with a dot over here, as you can see. Now instead of a straight line, I can change my line style to a dashed line like this. So now you can see my line is a dashed line, or I can also change it to a dot using the colon. So now you can see my line has been dotted. I can also go ahead and change the width of my line using the line width parameter, and I can say I want it to be 2. Okay, so as you can see, the width has been increased. So if in case I want my marker to be represented with a star, all I have to do is pass this particular symbol and you can see the marker style has been changed. Okay, so you can go ahead and play around a little with the parameters that are available in Matplotlib. Again, Seaborn offers a bit more functionality compared to Matplotlib, but this is great when you want to deal with your plots at a lower level. Okay. Then the next way we can visualize our column is through a histogram. So in order to plot your histogram, all you have to do is say plt.hist and pass your column in the parenthesis. And for now, I'm going to exclude the bins parameter and just show you guys how the salary column is going to look like in a histogram. Alright, so histogram basically tells us the frequency of our data distribution. So what this graph is basically telling us is that there are around 3 people that have the salary in the range 25,000 to 30,000. Then 2 people have the salary in the range 30,000 to 35,000. And there are 3 people again in 35 to 40 range. Okay, so this is basically how our data is being distributed. Now, in order to make it more clear, I can go ahead and pass bins, and I'm going to, no, I don't want grids for this particular graph, and I'm going to say my color is going to be green. So now I have divided my plot in 5 bins. So now it's more clear and more readable. Okay, so I have 6 people earning 25,000, then 5 people earning 30,000, then 3 people earning 35,000 and so on. Okay, so this is how you can read your data through a histogram. Then the next plot that we have is a box plot. So in order to plot a box plot, all you have to do is say plt.boxplot and pass your column over here and simply say plt.show, and this is what your box plot is going to look like. Okay, so whoever is not clear with what a box plot is exactly, let us quickly understand it with the help of this image. So a box plot has 2 endpoints. One represents the minimum value and one represents the maximum value. Then there's a line that is connecting the minimum value to the lower quartile, and it's called the whisker. Now your lower quartile is known as Q1, which basically represents 25 percentile. So basically 25% of the data is below this particular point. Okay, then you have your mean value and your median. Median is also known as Q2 and it's the 50th percentile. This represents 50% of the data is below this particular point. Then you have Q3, which is 75 percentile. So 75% of the data is below this particular point, and then you have your maximum value. Okay, so Q1 to Q3 is known as your interquartile range. And then you have something known as outliers. Now, outliers are basically the extreme values that are either lower than the minimum value or greater than the maximum value. Okay, so these are basically the extreme values and they are plotted outside the box plot. So, box plot makes it very easier to identify whether there are any outliers in your data or not. Okay, so as we can see in this particular plot over here, there are no outliers currently. But if I were to add a salary, so at index 20, I'm basically adding a salary 0. Okay. Now, if I run it, now I go ahead and plot a box plot. You can see over here, I got an outlier value which is at 0. So this is the value I just inserted, as you can see over here, through df.loc. So we have already covered LOC and ilog in my previous video of Pandas full course. If you guys have not watched it or you guys do not understand how I have added a new record in my dataset, I suggest you guys to quickly go ahead and watch that video before you continue with this video, because we will be using Pandas somewhere or the other throughout this video. Alright. So as you can see, I've got my outlier value over here, which is really far away from my entire box plot. So it's suggesting that whatever range my other salaries are in, this particular salary does not match that range. Okay. So I can simply go ahead and remove this value from my dataset in order to avoid any bias in my entire calculation when I'm going ahead with prediction models and all. Okay. So I'm just going to go ahead and remove this value. Okay, so I'm back to my original data set. Now this was all about when you have a single numerical column. Alright, so salary was something that contained all numerical values. But what if I had a column that had all categorical values? So now we're going to deal with a univariate categorical column. Okay. So in order to deal with a categorical column, let me just quickly go ahead and add another column to my data set called department. So now let me go ahead and check my data frame, what it looks like. So as you can see over here, I have a salary column and a department column, and my department column is a categorical column. I can also go ahead and check that using the info parameter. So you can see this is of type integer and this is of type object. So basically, all of the data that I have in my department column is of type string. Alright, now if I want to visualize this particular column, I cannot use a line chart or a histogram or even a box plot because those are used for a numerical column. So in order to visualize this column, I'm going to use something known as a pie chart. Now, in order to plot a pie chart, what I have to do is I have to create a count variable where I am simply going to count the number of unique values in my department. So this is what it's going to look like. So I have 8 HR departments, 6 IT and 6 finance departments. Okay. Now I can go ahead and plot this data in my pie chart using plt.py. Simply pass my count variable, and if I print plt.show, this is what it looks like. Now over here, I do not know what these different colors are representing. So in order to have that on my pie chart, all I have to do is say labels equal to count dot index, and if I print it now, you can see the green color represents my finance, blue represents HR, and orange represents IT. But again, another issue is I do not know the values of these sectors. So in order to get my values printed in my pie chart, all I have to do is say auto PCT and pass 1.1%, 1.1 F. So you can see I have 40% HR, 30% IT and 30% finance. Okay. So the format I've given over here basically represents that I want one decimal. If I were to pass 1.0, I would get only my integer parts over here. If I were to say 1.2, you can see I got 2 decimal values in each of my sectors. Okay. And another important parameter in pie chart is explode. So the explode feature basically helps us decide if we want to separate any particular section in our pie chart. So let me just show you guys. So I can simply say 0, 0.1 and 0. If I do that, so you can see IT, which is my second sector over here, has been separated from my entire pie chart by 0.1 distance. Okay, I can do that for 2 sectors at a time also. I can say I want this to be separated by 0.2, the last sector finance. So this is what my pie chart looks like now. Okay, now if you feel that your pie chart is not a complete circle, it's not a proper circle, you can quickly go ahead and say axis and pass equal in the parenthesis, and that will make your pie chart in a complete circle. Okay, so this was one way of visualizing a categorical column. The other one is known as count plot. So in order to do a count plot, all you have to do is say plt.bar and pass your count.index and count variable and simply say plt.show, and now you can see your different sectors represented as a bar chart. Okay, you can easily understand that HR has 8 values, basically 8 people working in HR, 6 people working in IT, and again 6 people working in finance. You can also go ahead and change the color of your bars. You can make it, so if I want different colors for different bars, so I can go ahead and say green, black, red. So you can see I have different colors for my different bars. Okay. So this was all about univariate analysis. That is when we had to deal with only one column. Either it was just a numerical column or just a categorical column. But what if we had 2 columns at a time? That brings us to our next type of analysis, that is bivariate analysis. And over here, we basically try to analyze the relationship between 2 features or 2 columns. So first we're going to look at 2 numerical columns. Okay. So right now, if I check my data set, I have 1 numerical column and 1 categorical column, right? So in order to perform numerical analysis, I should have another numerical column. So let me just go ahead and create a new column. I'm going to call it H, and okay, so this is my new column called H. And if I go ahead and check my data frame now, so you can see I have 3 columns, two are numerical columns and one is a categorical column. Alright. So now if I want to visualize salary and age column together, the first plot that I have is known as a scatter plot. So a scatter plot is basically going to help us analyze the direct relationship whether salary increases with age or not. Okay, so if we want to check that, all we have to do is say plt.scatter and pass my age column, my salary column, and I'm going to give the color orange, and I'm simply going to say plt.show. So as you can see over here, my age and salary are increasing together. Okay, so this is also known as a positive correlation. Alright, so when my age is around 20 to 25, my salary is somewhere around 25,000 to 30,000. But as my age increases, so when I reach the age of 40, my salary is somewhere around 55,000. Okay, so this is how you can analyze the relationship between two numerical columns. And the next way of visualizing two columns is again by using a line plot. So as we saw in our initial example, we had two features x and y. So right now we have two features called age and salary. So I'm going to go ahead and plot my line graph over here. So as you can see, my line graph is not very easy to visualize over here. You can see the lines are very random. So instead of line style as dotted, I'm going to have my simple and plain line style. So as you can see, it's going back and forth a lot. So why is this happening? Because my age column is not sorted over here. So I have random age values and random salary values. So in order to have a better visualization, what I'm going to do is I'm going to sort my age feature. I'm going to create a variable called sort age, and I'm going to simply sort my values of age. Okay, and over here, instead of passing my age directly, I'm going to pass my sorted age. So as you can see over here, now my line chart is giving me a better visualization of the relationship between the age column and the salary column. Okay, so this is how you can plot a line chart between two numerical columns. Then the next visualization graph that we have is a bar chart. So in order to plot a bar chart, all you have to do is say plt.bar, pass your age. I'm going to pass my sorted age features and my salary column, and I'm going to say I want my color to be green for all the bars. And as you can see over here, it is giving you the visual representation in forms of bars. Okay, so at the age of 22, I have my salary in this range. At the age of 25, I have the salary at this range. So I can also go ahead and create bins. So I want only 10 bars to classify my age. So I can also go ahead and align my bars, and I can say I want my bars to be in center. So if I run it, so they were initially like this. Now if I say I want them to be left, so align supports center or edge parameters. Okay, so this is how you visualize two numerical columns, but what if you had a numerical and a categorical column to visualize? So let me go ahead and show you guys. Bivariate analysis, but with a numerical and a categorical. So I'm going to consider my salary feature and my department feature, and now I want to see the visualization of how my salary is distributed according to my department. Okay, so what I'm going to do is I'm going to create my feature called HR salaries, and here I'm going to fetch all my salaries that have the department of HR. So basically my HR salary variable is going to contain the salaries of only the HR department. So basically these are the people working in the HR department and these are their salaries. Okay. Similarly, I'm going to do that for the other two departments as well. So I'm going to create IT salary, and similarly I'm going to create finance salary. Okay. So once I have my salaries for all the three departments separately, I can go ahead and plot them in a box plot. So I'm going to go ahead and create a box plot. So in order to do that, all I have to do is say plt.boxplot and pass all the three salaries that I have together. And you can see the distribution like this. Okay, so I have one salary that is an outlier, that is 55,000, which is, okay, so I need to also go ahead and label them. So I'm going to say label, and I'm also going to show the legend for my plots. So if I plot this, you can see I have three box plots, and over here you can see I have an outlier value for my first box plot, but in this particular figure, I'm unable to understand which box plot is referring to which department. So in order to clarify that, I can go ahead and say I want my labels to be HR, IT, and finance. So if I run it now, you can see my first box plot represents the HR department, and I have an outlier value in the HR department. Okay, so this is how you can analyze a numerical column with a categorical column using box plots. Okay, you can also check their median values. So the median HR salary is in the range of 25,000 to 30,000, whereas IT median salary is 35,000, and finance has the highest median salary, that is 40,000. So this is how it gets much easier to visualize data using plots in Matplotlib, right? If you were to find out such insights just looking at the data, it would take you much longer, right? But using graphs like this, I can easily figure out which department has uh, a higher median salary, or the maximum salary, or the outlier lies in which department, right? So box plot was one way. Another way where you can visualize your numerical and categorical column together is pie chart. So in order to plot my pie chart, what I'm going to do is I'm going to sort, or I'm going to group my salary by department, and I'm going to say df dot group by department, and I want my salary to be grouped, and I'm going to use the sum instead of mean. So this is what it looks like. So I have a total of this number for my finance department. So basically all the people in finance together are earning this much salary, whereas all the people in HR are earning this amount, and in IT they're earning this amount. Okay, so now I can go ahead and plot it in a pie chart. I can say plt.py, and I can give my salary by department variable, and I can call my labels as the index, and I'm going to label them using auto PCT. And once I print my pie chart, so in my pie chart I can easily see the distribution of salary in percentage for the three different departments. Okay, so this is another way of visualizing. So in my box plot, I could easily figure out the minimum salary, the maximum salary, and the median salaries for all the departments. And over here, I can see the distribution or the percentage for each department, that is the total amount being earned by each department. Okay, so another way when you can visualize your numerical and categorical column is by using a bar plot. So I want to show the mean salaries of all the departments in my bars. So what I'm going to do is I'm going to say HR mean, and I'm simply going to say sum of HR salary and I'm going to divide it by the length of HR. And similarly, I'm going to do it for IT and finance as well. So once I run it, I can simply go ahead and plot my bar chart over here. I'm going to say plt.bar, and I'm going to pass my HR, IT, and finance as labels. And I'm going to pass these as variables as well, and I'm going to say I want my bars to be of color green, black, and red. And once I print my chart, this is what it's going to look like. Okay, so in my bar chart over here, I can easily see the mean or the average salary for the three departments in a very clean and neat manner, right? So my HR mean salary is somewhere around 35,000, whereas IT is a little more, and finance is almost crossing 40,000. Let me just use my grids over here. So you can see, now you get a better visualization of the mean or the average salary for the three departments. Okay, so this is going to further help you in analysis where you are building large predictive models. Right now I just have three columns and the values are really small, so I could even look at the data. But when you have a larger number of columns and larger values, visualizing your data becomes a much more easier, or you can say efficient way to understand what the data is trying to tell you, right? So with this we finish our bivariate analysis. Next comes our multivariate analysis. So basically this is where we're trying to understand how the three columns affect each other and how they change with each other, right? So first we're going to look at three numerical columns, that is numerical, numerical, numerical. So I'm just going to write three numerical columns. So in order to have three numerical columns, right now I just have two in my data set. Let me just check. Yeah, so I have two numerical columns, that is salary and age. I need to add another numerical column in my data frame. So let me just say df and let me add experience. Okay, so you can see I have added another numerical column, that is experience. So basically, this column is telling us how many years of experience the person has. So over here, there's 1 year of experience. Here, over here, the person has 2 years of experience, and so on. Okay. Also, another thing that I missed over here is a few parameters in pie chart. So over here, there's something known as shadow. So if you want to give these effects to your pie chart, you can simply say shadow equal to true, and over here you can see a shadow like structure has been created below your pie chart. Okay, so it kind of gives your image a 3D effect, right? And you can also go ahead and say explode and pass a list of the distance that you want your each sectors to be away from the radius. So I'm going to say 0.1, 0 and 0.1. So basically this makes your pie chart look a little more interactive and different from the normal images that are out there. So you can go ahead and customize it. Okay. Alright, so moving on with our multivariate analysis. So I have three numerical columns as you can see over here. So now in order to analyze these three columns together, I'm going to use something known as a bubble plot. Okay. So a bubble plot is nothing but a scatter plot where your third numerical column, so in this case we're going to use experience as our third numerical column, and this experience column is just going to define the bubble size. Okay, so with that you get an idea of how much experience the person has. So basically the larger your bubble, the more the experience the person has. Okay, so let me go ahead and quickly create this plot for you guys. So I'm going to say plt.scatter. So basically I've passed my age column, my salary column and my experience column as the size of my bubble. And I'm saying I want orange bubbles. And if I print this, okay, so as you can see, the size of my bubble by default is very small. So basically the smallest bubble is representing 1 year of experience and the largest bubble is probably representing 5 years of experience. But in order to have a better visualization, what I'm going to do is I'm going to multiply this by 20. Okay, so now you can see the bubble size has increased and now it's much more easier to visualize this particular graph than earlier. I can also go ahead and increase the number of multiplication. Okay, and I'm going to give the color blue because that would give a better bubble effect. So this is what my bubble plot is going to look like when I have three numerical columns. Okay, so you can go ahead and easily visualize that person of age 27 is earning around 35,000 and again the experience is also good, right? So I'm simply going to give the color as sky blue and I can also go ahead and customize it as edge color. So I'm going to give my edge color as black so that I have a better understanding of my bubbles. Alright. So see, this is what my bubble plot is going to look like. Again, I can give a title to my plot. I can say plt.title, age versus salary versus experience. And my X label is going to be age, my Y label is going to be salary, and I do not need a grid. So now you can see my plot looks much neater and easier to read, right? So this was when we had three numerical columns. But what if we had two numerical and one categorical column? So in this case, we are going to again use a scatter plot. So the two numerical columns are going to be our age and salary. And our categorical column is going to be the department column. Now, in order to plot this on a scatter plot, instead of using a bubble plot, we're going to use a scatter plot again. But for the different departments in our department column, we are going to use different colors. Okay, so what I'm going to do is I'm going to say plt.scatter and I'm going to pass my age column, my salary column, and I'm going to say I want my colors to be of the different departments, that is DF department. And I'm going to say I want the colors of a rainbow. So I want different colors in a rainbow. Okay. Or if I didn't want rainbow, I'm going to show you guys how I can customize the colors in my own way. So I'm going to say x label, and my x is going to be age, then y label, plt.x label, and plt.y label. My y label is going to be salary, and I'm going to give a title to my plot, and I'm also going to print my legend. Okay, so I cannot use a rainbow color. Rather, what I'm going to do is I'm going to say df.map, and I'm going to map the different departments. So if I have an HR department, I'm going to map it with, say, color yellow. And similarly, I'm going to map my other two departments as well. So I'm going to say IT, I want to be mapped to color blue. And finally, I have finance, say orange. Print it now. So as you can see over here, I've tried to print my legend, but I am not really getting an output. So I can resolve this by simply saying labels equal to df department. So as you can see over here, I have tried to print my legend using plt.legend, but I am not really getting any output for that particular line. So the reason being, I have explicitly defined what colors each of my departments are going to get, and Matplotlib is unable to read that. So I have to explicitly define the labels using label, and I'm going to say HR, IT, and finance. So if I print it now, so as you can see over here, even though we've passed the plt.legend parameter, our legend is not getting printed. So the reason is because we have explicitly defined the colors over here, and even if we try to get the label parameter as df department, so you can see it is not going to work for us. So we cannot use this particular strategy. Rather, we have to follow a different kind of format over here where we explicitly define our color using a variable. So I'm going to say my HR is going to be linked with yellow, IT is going to be with blue, finance is going to be with orange. Okay, now I'm going to iterate through each of my color and my department. So I'm going to say for DPT and color in color.items, and basically I'm going to classify each of the departments separately, and then I'm going to print my scatter plot of age and salary. I'm going to say my color is going to be the specific color for each department, and I'm going to label my department. And if I run this and I go ahead and print my legend, so now you can see I've got my legend successfully, because now Matplotlib knows which department is representing which color. Alright, so that is why it is able to generate a legend successfully. Earlier in this case, Matplotlib had no idea about it. So this is how you can create a legend when you're plotting two numerical and one categorical column in a scatter plot. Alright, so that was all about our PyPlot API plotting for a single numerical column, a single categorical column, then two numerical columns versus a numerical and a categorical column. Then we went ahead and saw multivariate plotting, and we did all that using the PyPlot API. That is, we directly went ahead and used terms like plt.bar, plt.boxplot, and so on. Now we're going to dive into object-oriented API. That is, we're going to create objects before we start plotting. Okay, so let me just comment it over here. So object-oriented API basically allows subplots or multiple axes or multiple plots in a particular figure. Okay, so till now we saw one particular plot in one figure, but now what we can do is we can have multiple plots and subplots in a single figure. Okay, so let's quickly see how. So first I'm going to create two objects called figure and axis, and I'm going to say plt.subplots, and I'm going to pass 1,3, and I'm going to say my figure size is going to be 10,5. Okay, so this is basically the x and y ratio. So in terms of x, I'm going to have the figure horizontally expanded and vertically just 5. Okay, so basically what I'm telling my subplot parameter is that I want one figure, and in that one figure I want 3 subplots. Okay, so now let's go ahead and create our first plot. So I want my first plot to be a line plot. Okay, So as you can see over here, this is one complete figure and I have 3 subplots. Right now, all these 3 plots are empty. Okay. So I'm going to go ahead and create my line plot first. So in order to do that, I'm going to use my sort age variable. Let me see if I still have it. Yes. Okay. So I'm going to use my sort age variable. So I'm going to say at my axis 0, that is my 0th x-axis, I want to plot a line plot and it is going to be sort age, pass my age and salary, and I want my color to be red, my marker to be a star, and my line width to be 2. Okay, I can also go ahead and define my marker size. So I'm going to say marker size equal to 2. So I can go ahead and set the grid. I can also set my title for this particular plot. I'm going to say it's a line plot, and I can also go ahead and set my X label and my Y label for this. So I'm going to say dot set X label and I'm going to call it age, and Y label is going to be my salary, and then I'm just going to run it. Okay. So since I've not called my plot till now, it's not being generated. Now I'm going to go ahead and plot my histogram. Ideally, all this should be run in a single cell. So I'm just going to paste it in my cell over here. And then I'm going to plot my histogram. And over here, my axis is going to be 1 so that Matplotlib understands that this was my first plot. And I'm going to use axis 1 over here throughout histogram so that Matplotlib understands that this is the second figure, while the earlier where I use 0 for axis is going to be my first figure. Alright, so basically I'm referencing to my first figure and my second figure over here. So I've created a histogram for my salary and I'm going to give the color sky blue. And I'm going to set my title for histogram and I'm going to set my label salary, and Y label is going to be frequency. Then my third plot is going to be a box plot where I'm going to say axis 2, that means my third figure, and I'm going to plot my salary over here. I'm going to set my title as box plot and I'm setting my X label as salary again. And if I run plt.show, that is I print all my plots, this is what it's going to look like. So as you can see over here, my plot is sort of coinciding with my second plot. So I can go ahead and increase my x-axis direction. So I can say 15,5. Now you can see it's fitting perfectly. Okay, so you can go ahead and adjust the dimensions for your plots, that is your figure size. Okay, so this is how you plot multiple plots together, okay, in using object-oriented API. Cool. Now, if I want to save this particular figure in my local environment, maybe I want to use it for some sort of presentation or any sort of document that I'm preparing, and I want to use this figure in that, how do I do that? Okay, so you can either just right click and go to copy image, but that's not the right way. So Matplotlib offers an inbuilt feature where you can save your image. So all you have to do is say plt.savefig and give a name to your image. So I'm just going to say multiple plots. And now you can use any particular extension. So I'm going to use PNG. You can use the JPG format or you can use the PDF format. Okay, any format that you want to download your image in, you can just use that particular extension in the end using the dot. So whichever image I need to save, I just need to run this particular line before the plt.show. And if I run this, so let me see if my image has been saved. So as you can see over here, multiple plots.png has been saved in my drives. So since I'm using Google Colab, it is unable to access my local environment, and hence my image is saved only in my drive, that is my disk space over here. If you're using VS Code or any other notebook like Jupyter Notebook, you can specify the path that you want your image to be saved in. Okay, so you can directly go and say, I want it to be stored in my C drive. Okay, so you can use a path like this so that your image is stored in that particular folder. And I can also go ahead and download it from here. So this is how you save an image. I can also save it in, okay, let me just go ahead and, so if I click on this is what my image is going to look like. Okay. Now, before we wrap up with our 3D plots, I want to show you guys another interesting scenario where we have a data somewhat like this. Okay, so basically I have multiple numerical columns. Now, if I want to visualize all these particular metrics over here, like the sales and profit and expenses all together in one chart with reference to the year column, this is how I can do it. So first I'm going to convert it into a data frame. I'm going to call it df2. This also ideally should be data2 because I already have data variable initially. Okay. So in order to do multiple plots, all I have to do is say plt.plot and pass my year as my x variable. So this is going to be fixed throughout. All my x variables are going to have the column year because I want all these particular metrics to be represented with reference to year, but in a single plot. Okay, so this is how I'm going to do it. So I do year and let me plot sales, and I'm going to label it as sales. So similarly, I'm going to do it for profit and expenses column as well. Okay, and I'm going to label it as profit and expenses. So if I give my plot a title, financial analysis, and I'm going to label my X label as year and Y label as the amount. So now my Y label, that is the amount, is going to vary according to sales, profit and expenses. Okay, so if I run this, okay, so as you can see over here, I have my profit, my expenses and my sales. Now, how do I know which line is representing what? I can see it through the legend over here. And my x-axis is representing the year and my y-axis is representing the amount. Okay, so basically we had lesser profit and our expenses were greater than our profit throughout the years. So basically the company is in financial loss. So that is something that we can easily predict through this particular graph. Although our sales were pretty high, we are not generating the required profit, right? So this is how you can analyze financial data in just a few lines of code. All right. So now coming to the last topic for this particular video, that is a 3D plot. So let's plot a 3D plot for this particular data frame that we have. Okay, so in order to do a 3D plot, all you have to do is create a variable. So I'm going to call it AX and I'm going to say plt.figure and I'm going to say projection equal to 3D. Okay, and now I'm going to create my scatter plot and I'm going to pass my variables. So I'm going to pass my age, salary and experience column and I'm simply going to say df plt.show. Okay, sorry, it's not going to be plt.figure, it's going to be plt.axis and my d is going to be small. Okay, so as you can see over here, I've got a 3D plot. So in order to clarify what each of these axes is representing, I'm going to label these axes. And in a 3D plot, I'm going to use set X label, set Y label and set Z label. Alright, so once I run it, so as you can see over here, this particular axis represents age, this represents salary, and this one over here is supposed to represent experience, but I'm not really getting the label over here. So this code is going to perform better if it was run on a Visual Code or Jupyter Notebook. Okay, Google Colab does not really support a lot of 3D animations. So if you were to run this particular code in VS Code, you would be able to rotate your graph on different axes and be able to visualize the data better. So if you want to achieve the same functionality in Google Colab, all you have to do is import plotly.express as px, and if you run it, so it's run successfully. And then you can simply go ahead and create your figure, which is going to be your scatter plot 3D. So it directly comes with a 3D scatter plot and you can pass your data frame and your variables are going to be age, salary and experience. So what I've done over here is I've created a figure variable and I've used px.scatter3d. So it's directly going to plot a 3D scatter plot and I've passed my data frame, my age, salary and experience variables and I've titled it as 3D scatter plot. Okay. Now all I have to do is say fig.show and if I run it. So as you can see over here, now I am able to rotate my graph. I can visualize the data on a 3D level. Okay, so this is how you can do it using Plotly library. Okay. Matplotlib also offers this particular option, this particular functionality, but just not in Google Colab. Okay, you can do it on Visual Code or Jupyter Notebook. So this was it for this video. I hope you guys were able to understand Matplotlib, the functionalities, and most importantly, which plot is supposed to be used for what kind of data set. So we've discussed univariate, bivariate, and multivariate analysis along with PyPlot API and object-oriented API. So whenever you enter any interview, the very first question that will be thrown at you is, what is your most preferred language? Once you give your answer, which will be Python in our case, then comes the real question, which is also the first question for our video. What makes Python different from other languages? Or simply, why Python? Companies are looking for programmers who know why they choose a language, not just what they code in. So when asked why Python, it is your chance to show you understand what makes it special. So you need to be very crisp and to the point while answering this particular question. Start with the popular features of Python and what makes it different from the other languages. For example, you can start by saying that Python is an interpreted language, dynamic, high-level programming language. Dynamic means that the type of variable is determined only during runtime, and hence one variable can have different data types at different times. Data types are checked during execution. For example, Python allows addition of a float and an integer but will throw an error if one tries to add a string and an integer. And high-level language means that Python is easy to read, manages memory for you, works on any system, and provides tools that let you focus on solving problems instead of dealing with the hardware. Second question that can be asked is, what do you mean by Python being an interpreted language? Do keep in mind that whenever you answer any question in an interview, the next question is going to be a follow-up for the previous question. And this question is one of that kind. So your answer for this question should look something like this. An interpreter allows the code to run line by line rather than being compiled into machine code first. This is why Python is easier to debug. We can take the analogy of cooking a meal. We follow one instruction at a time without worrying about the entire meal at once. Moving on to the next question, give 3 differences between lists and tuples. Now you might feel that this is an easy question, but the catch here is that the interviewer is not just looking for the basic concept, like square brackets are used in lists and tuples use parenthesis concept. You need to also have knowledge about mutability, memory usage, and performance. You can differentiate in pointers like first talk about mutability, that lists are mutable whereas tuples are immutable. Then for the second point, talk about memory usage. A list occupies more memory as compared to a tuple. Then the last point will be performance. List has slower iteration compared to tuples, but it is better for insertion and deletion operations due to its mutability. Now let us look at the fourth question. Differentiate between mutable and immutable data types, or simply what is mutability? This is a somewhat direct question, but make sure you elaborate the key areas and do not forget to include examples. So first explain mutability. Mutable data types are those that can be modified after their creation, like lists, dictionaries, and sets. Say we have a list L containing elements A, B, and C at the indexes 0, 1, and 2 respectively. But later on we realize that instead of B at index 1, we want G. We can easily achieve that using slicing. Access the first index using square brackets and assign G using equal to sign. We can also insert an element or delete an element from the list using the append and pop method respectively. Mutable data types are used in cases where data requires frequent update. Now let us look at immutable data types. In the case of immutability, there cannot be any modifications once the data types like tuples, strings, integers, and floats are created. If in case of a tuple or string, we try to modify any particular element, it will throw an error. Immutable data types are used in cases where we need to store data that will not change frequently. Moving on to the fifth question. What is the difference between slicing and indexing? This is again a very simple question if you are able to follow a proper structure while answering it. So slicing and indexing are both ways of accessing elements in sequences like lists or strings, but they work a little bit differently. Indexing is when you refer to a specific item in a sequence by its position or index. For example, if we have a list L containing elements 10, 20, 30, then using the list L and passing 0 in the square brackets would give me the first element, which is 10. It's just a way to grab a single element from the sequence. On the other hand, slicing is more about accessing a range of elements. It's like cutting out a portion of the sequence. For example, if I want the first two elements of the list, I'd use the list L and pass the range in the square brackets using a colon to indicate the start and stop value. That is 0, colon 2. And since I'm not passing any step value, it will be 1 by default. And that would return 10 and 20. Slicing can be really flexible. You can specify a start, stop, and even a step value to control how you're accessing the sequence. So in short, indexing is for accessing the element and slicing is for working with a range or subset of elements. Now let us move on to the next question. Explain list comprehension. List comprehension is a neat way to create new lists using a simple one-line syntax. It's a much more compact and readable alternative to using a traditional for loop. With list comprehension, we can generate a new list based on an existing one, applying conditions or transformations right within that single line. If we were to do the same thing with a for loop, it would take multiple lines, and as the logic becomes more complex, it can get harder to read and understand. But list comprehension simplifies this, making the code both elegant and efficient. Now let us look at the seventh question. What is the difference between break and continue? So in order to differentiate between the two control flow statements which determine how and when certain sections of the code should be executed or skipped, you can also use the analogy of a person watching a movie to back up the definitions you give to the interviewer. First, define what the break statement does. So the break statement will terminate the very loop inside which it is used and move the control to the statement that follows the loop. It is like stopping the movie midway and leaving the theater and then continuing with whatever action you would normally perform after watching the movie. Continue statement is used when you want to skip a part of the movie but watch the rest. Basically, the continue statement terminates the current iteration of the statement and transfers the control flow to the next iteration of the loop. Moving on to the next question. What is the pass statement? The pass statement is generally used to fill up an empty block. Basically, when there's a movie scene where nothing happens, you just keep going without stopping or skipping. The pass statement in Python is essentially a placeholder. It doesn't perform any action when executed. It's often used when you're writing code and want to leave a certain section empty for now but don't want to run into errors. In Python, an empty block of code will raise an error, so pass comes in handy to avoid that. It is a no operation statement. For example, if I'm designing a function or a class but haven't decided what the implementation will be yet, I can use pass to fill in the space, allowing my program to run without issues. Then we have our ninth question. What do you understand by scope? Scope is the area in a program where a variable or a function is accessible. To put it simply, it tells where you can use or interact with a certain variable or function. There are two types of scopes, global and local. When a variable is defined outside of any function or block, it's accessible from anywhere in the code. In such cases, the variable is said to have a global scope. For example, a book that is placed on a public shelf so that anyone in the library can access it. But on the other hand, when a variable is defined within a function, it can only be accessed inside that function. In this case, the variable has a local scope. It's like placing a book in your drawer so that only you can use it. Moving on to our next question, what are negative indexes and why are they used? Negative indexes allow you to access elements from the end of a sequence, such as list or string, rather than from the beginning. It's like counting backward instead of forward. Typically, when you use a positive index, you're accessing elements from the start, with 0 being the first element. But sometimes it's more convenient to start from the end. That's when negative indexing comes into play. This feature is useful when you don't want to calculate the length of a list or string to get the last few items. For example, if you want to quickly access the last character of a string, you just have to pass -1 in the square bracket to access the character using indexing. So now let's look at a more implementation-based question, which is how do you copy an object in Python? Now, there are various ways of copying an object. Let's look at all of them one by one, right? So when we use an assignment operator, what we do is say our one variable is pointing to a certain list which contains 1, 2, and 3. And when we use assignment operator to create a copy of this very list, what it's going to do is the other variable also points to the same object, right? It just creates a reference for the other object, which point to the same object in the memory, right? So what happens is, basically, instead of creating an actual copy of an object, we just create a reference. Both the variables basically point to the same memory in the object. So any changes made through one variable should reflect in the other variable as well, right? So if I say a dot append, so basically b will also reflect the same changes that are made in the a variable. But if we want to create actual copies of objects, especially when we want independent copies, we can use the copy module that is available in Python, right? It gives us two ways to copy an object, which is the shallow copy and the deep copy. So as you can see in this diagram, so having its own separate elements, as you can see, bag 1 has its own separate elements, whereas bag 2 has its own separate elements. Whereas in shallow copy, again, a reference is being created where both the bags over here, or in case of Python, both the variables are going to point to the same object, right? Let's go ahead and look at them in detail. So shallow copy is like copying the surface of the object, right? It will create a new object, but it will not fully duplicate the nested objects inside it. So if we consider a nested list, so say we have a nested list. I will show you guys the implementation of this code in my VS Code. But before that, understand the concept behind it, right? So in case of nested list, only the references will be copied, right? Any changes to the inner elements or the elements that are inside the nest of the list will affect both the original and the shallow copy. Let me take you to the code. So as you can see, I have imported my copy module, and when I use, and I have my list over here, which is containing elements 1, 2, and 3 and 5 over here are nested. So at index 2, I have a nested list, which is containing 2 elements again. At index 0, I have 3, and index 1, I have 5. And then at index 3, I have another element 4. Now, if I use the shallow copy method, which is just copy in my copy module, and I assign 7 at index 3, which is basically I am replacing 4 by 7. And then I'm appending 6 at index 2. So 0, 1, and 2. So index 2 is my nested list, and inside my nested list, I'm appending an element 6. So when I make these changes in my list 2, these changes shouldn't have reflected in my list 1. But when we print both the lists, so the changes inside the nested list, as you can see over here, is reflected both in my original list and my copied list. But outside over here, the element that was replaced is not reflected in my original list. So this is how shallow copy works, right? But in the case of deep copy, it will create a fully independent copy of the entire object, including all the nested objects as well. So this can be done using the deep copy method from the copy module itself. Let me quickly show you. So this is how the deep copy syntax works, right? You just have to import deep copy from the copy module and pass your original list and assign it to the variable that you want it to be copied in. And now whenever we make any changes, it will not reflect in my original list. As you can see, I have copied my list 1 in a variable called list 3. And then at index 3, I'm replacing 4 by 8. And then I'm appending 7 in my nested list. So as you can see over here, the changes are being reflected only in my copied list, which is list 3. But my original list remains the same. So this is how shallow copy and deep copy work. I hope this is very clear to you guys. So this is the syntax of the shallow copy and deep copy methods, which I've already shown you guys on my VS Code. So this should be really easy to understand. This is my original list in the variable list, and I am shallow copying it over here and storing it my variable L2. Similarly, I'm performing deep copy over here. I have passed my original list, which is stored in variable list again, and I have used variable L2 to create a deep copy of my original list. So moving on to the next question, which is what does star args and double star keyword args means? right? So whenever we are creating a function and are not sure about the total number of arguments that will be passed, we use the arguments, which is args or keyword args, as parameters. Right, so this helps the function to take a variable number of arguments and not throw any error. Say I have a function. Let me just get my pen over here. Say I have a function person, which is basically used to print the details of a person. So say I have name, age, and then I have optional arguments also. Maybe I have the degree of a person or the qualification or the job status and arguments like that, right? But not every person is going to fulfill all these criteria. Now, if I pass all the parameters beforehand, and if some person does not have those features or those qualifications, my function is going to throw an error, right? So to avoid that, what I'm going to do is I'm simply going to pass star args as my next parameter. And so this is how that function is going to handle all my extra arguments or my lesser number of arguments, right? So star args basically allows you to pass a variable number of positional arguments to a function. It collects these arguments into a tuple. So we're going to look at their implementation in our VS Code. But before that, let's just understand the difference between star args and double star keyword args. So basically, keyword arguments basically allow you to pass a variable number of keyword arguments. So now they collect these keyword arguments into a dictionary. So basically, whenever we're passing arguments in our function, we can pass them as, say, I want to pass person and I have my name, I have my age, and then I want to pass, say, qualification. So I will just say qualification and I will pass the qualification. Say I want to pass the degree, I will say degree and pass my degree over here. So this is how keyword arguments work, right? So this is the syntax. Whenever we're creating a function and we are not sure about the total number of arguments that a function is going to take or the total number of parameters, we just pass star args and double star keyword arguments. So on printing these arguments, you will realize this is a tuple and this over here is a dictionary. And star over here means variable length, right? So this is what we're basically trying to implement over here using star and double star keyword arguments and normal arguments. So as you can see, I have a function created over here called test. It's taking normal arguments and keyword argument. So let's understand this. But first, let's see what we're passing in our test function, right? So we're passing 1, 2, and 3. So these are our positional arguments. These are the arguments that our normal argument parameter is going to take care of. Whereas name equal to Alice, age equal to 30, city equal to New York is something that our keyword arguments are going to take care of. So when we print them, let me just quickly run this function. So on printing, you can see I have my positional arguments 1, 2, and 3. And then I have my keyword arguments. My keys are basically the name, age, city, and my values are Alice, 30, and New York. So this is how keyword arguments and the normal arguments parameters function and take care of the variable number of parameters that you want to pass in your function. Moving on to the next question, how are arguments passed by value or by reference in Python? So passing by value is basically copy of the actual object that is being passed, whereas pass by reference is basically reference to the actual object that is passed. Now, you might have come across these concepts in other languages, in other programming languages like Java and C. But in Python, arguments are not passed by either of the two. They are actually passed by assignment or passed by object, right? So this is basically a trick question that the interviewer is going to try and ask you to trick you into picking one of the two options, but you need to be very clear. You need to start by explaining pass by value and pass by reference. We can just give one line definitions and move on by saying that in Python, none of these methods work. Rather, we have pass by object method that actually is being implemented in Python. So passing by object basically works like this. When you pass a variable to a function, what actually gets passed is a reference to the object the variable is pointing to, right? So say I have a function and I'm passing a variable to it. So whatever my variable is pointing to, that object, the reference to that object is being passed in my function, right? Now the behavior of how things process afterwards depends on the type of the object. So now my objects can be of two types, which is mutable and immutable. So mutable objects are again objects that allow changes made inside them once they're created. But mutable objects, when we're talking in terms of passing inside the functions, they're basically changes made to the object inside the function will reflect outside the function as well. And immutable objects are basically when you pass these objects, any modification that are made to these objects inside the function, they're not going to affect the original object. That is, when you access these objects outside the function, they are going to be they're going to point to the original value that was stored inside that, right? So let us quickly look at the implementation of passing by object. So as you can see, I have a list over here and I'm printing my list. Let me run this function also so that you can understand side by side. So before modifying my list, it was 1, 2, and 3. And then I go ahead and modify my list, which is basically I'm passing my list in this modify list function. And what I'm doing inside this function is basically I'm appending an element 4 and then printing my list, which was passed inside the function after the modification. So inside the function, my modified list contains this element which I just appended. But what if I try and print it after the modification as well? So after I print my original list, after it was passed in this modify list function, it also reflects the changes in the original list. So this is how the mutable objects function when they are passed to any functions. But what if I pass an immutable object? So my immutable object over here is a number 5. So I print it before passing it to my modify number function. It is 5. And then I pass it to my function. I increase the value by 10. So initially it was 5, now it becomes 15. When I print the value inside my function, it is showing 15 over here, which is correct. But after I have passed my function, I print the value outside the function, it is giving its original value, which was initially stored over here. So this is how mutable and immutable objects function when they pass to a function in Python. Moving on to my 14th Python interview question. What is lambda and why is it used? So in Python, lambda is a small anonymous function defined using the lambda keyword, right? So in Python, lambda is basically a small anonymous function. Anonymous is basically we do not need to define a name for a function, say def func. We do not need to give a particular name to our function before implementing it, right? So it is anonymous and it is defined using the lambda keyword itself. So unlike the regular functions in Python that are defined with the keyword def, these lambda functions are used for the short and simple operations where you do not need to formally define a function, right? So a lambda keyword can take any number of arguments, but the only constraint here for the lambda function is that they can only have a single expression. So they're often used as arguments for functions like map, filter, and sorted, where you need a small function for a specific task. They basically help in increasing the readability of the code, right? So what's happening here is basically we're defining our function lambda, and then we are passing an input variable, and we're giving an expression that this is what is supposed to be done with the input variable. So say our x is 2. So our expression is going to perform the operation which is 2 star 2, which is x star 2, which is basically 2 star 2, and it's going to give the output 4, right? So this is how the lambda function works, which is really short to implement. Let me show you the implementation in my VS Code. So as you can see, I have a list called numbers where I have numbers 1 to 5. And what I am doing here is I am basically squaring these numbers. So if I were to write a for loop, it would at least take me 2 or 3 lines of code, right? But over here, I can just do it with my map and lambda function. So what I'm doing here is I'm passing my input variable x, and I'm giving the expression that it is supposed to be multiplied with 2. So my each input has to repeat. So my each input has to be multiplied by 2. And I'm giving my input list over here, which is numbers. So I'm telling my function that this is my input parameter, and it is supposed to access each element one by one and multiply it with x and store it in a list, right? So let me run it and show it to you. So that it has mapped each input variable with my expression over here, which is my output, and given me a list, which is 2, 4, 6, 8, 10 square of all these numbers. Sorry, not the square, but the multiplication of 2 with all these numbers. Then the next question is exceptional handling. So in order to avoid your code or program to crash due to any error, we use the try and except block, right? Be it the dividing by zero error or any syntax error or even the file handling error. These are the errors that you get while running your code or while reading or writing into files, right? So whenever you feel that a piece of your code or a part of your code has the potential of raising an error, all you have to do is put that piece of code in the try block. So if there is any error in the try block, it will quickly jump to the except block and handle it without raising any errors, and it will also allow a smooth functioning of your code, right? But if there is no error in your try block, it will just continue with your program and move on to your else block. And then you can even use a finally block to execute code no matter what, regardless of whether an exception occurred or not, like closing your files or freeing up resources. These actions can be performed in your finally block because this block executes no matter what, right? So exception handling is performed to avoid any code crash. Now, how that is done, the code that could throw an error is put inside the try block. So if the code does throw an error, the except block handles the error. So this is the syntax for exception handling. So what's happening here is I'm dividing a number. So what this result variable is storing is basically a number being divided by 0. Now, in case you have a doubt whether it's going to throw an error or not, you put it in a try block so that your code does not really crash, right? And then you can simply print your error over here so that your code ends in a very neat and clean manner, right? So let me quickly show you the implementation of my code over here. So as you can see, it prints, oops, you can't divide by 0, which is the except block handling the error that we have tried to avoid in my try block. And then the finally block gets executed and prints this line of code. This code will execute anyway. Right, so I hope you guys got a basic understanding of how the try and except and the finally blocks are used and implemented in Python. Moving on to the next important question, which is memory management in Python. This is a very frequently asked question in most of the Python interviews. So unlike the other programming languages, memory management in Python is handled automatically by a system called garbage collection and a private heap space, which store all the objects and the data structures. So in order to understand what these are, first let's quickly look at this diagram. So we have our two objects that are being stored in our memory. So this circle represents the memory or the heap. And we have a reference count and we have a stack over here. And what basically is happening here is whenever the reference count becomes 0, the object gets ready to move into the garbage collector, right? So until and unless any object is being referred by a variable, so an object stays in the heap only until it is being referred by any variable. As soon as the reference count becomes 0, it is moved to the garbage collection. So let's understand these terms in a detailed manner. So Python basically has a built-in garbage collector that handles the circular references. Circular references are basically when two objects refer to each other but are no longer needed, right? So basically their reference count is 0. We'll understand what reference count is. So the garbage collector basically identifies these unused objects and then clears them, ensuring efficient memory usage, right? So a private heap is basically a heap that contains all the Python objects and data structures, right? Unlike the other programming languages like C, you do not need to manually allocate or free memory in Python, right? The interpreter takes care of it. And then comes reference counting. So every object in Python has a reference count, which is basically a track of how many variables or objects refer to that object, the object that is in the heap, right? When the reference count drops down to 0, meaning no one is using it, right? So Python frees up the memory for that object. Basically, it moves that object to the garbage collection. So this is how reference counting helps. So this is how reference counting basically keeps track and helps moving the objects from the heap to the garbage collection, right? So let's move on to the next question, which is differentiate between sorted and sort. So now you might be wondering, sorted and sort are both used to sort the data, right? But they do differ in how they function and how they're applied, right? So let's look at sorted first. So sorted basically returns a new list. So whenever a list is passed in the sorted method, then this method does not actually change the original list. Rather, it creates and returns a new list which contains the sorted elements of the original list, right? That means it is not just limited to lists. It can work on tuples, it can work on any sort of iterable that is being passed in the sorted method. The syntax is very simple. The iterable, it could be a list, tuple, or any other object. And we have a key equal to none. Key is basically the function that serves as a custom sorting criteria. And then we have a reverse, which is by default equal to false. If we use reverse equal to true, the result is going to be sorted in descending order, right? So these are the parameters for sorted. Now let's look at sort. So sort basically modifies the list in place. So whenever a dot sort method is used, the original list is going to be modified rather than creating and returning a new one, right? So it is an in-place operation. It works only on lists. Now there is one reason for this. If we perform this operation on tuple, since this method modifies the object that is being passed, now this is where you need to connect the dots, right? Lists are mutable, whereas tuples are immutable. And since sort is an in-place operation and it modifies the object in place, tuples cannot have any modification since they're immutable. So they work only on lists, where you use dot sort for the list that you need to sort and pass the key and reverse as optional parameters. And these key and reverse work the same way as sorted, right? So the key difference between sorted and sort is basically the return value. You can say sorted returns a new sorted list, leaving the original list unchanged, leaving the sorted list unchanged, untouched. Whereas sort method modifies the original list and does not return anything, right? It returns none. The next point is the scope. So sorted works on any iterable, whereas sort is restricted only to lists, right? So these are the major key pointers that you can give as differentiation between the two methods for sorting, right? Moving on to the next question, which is what is compile time and runtime error? Do they exist in Python? So you can think of compile time errors as mistakes that are caught before the program actually runs, right? So these errors are usually related to syntax. Python has an interpreter that reads through your code before execution. As we already discussed, Python is an interpreted language, which basically means that your code is read line by line, right? So before the execution of your code, Python's interpreter reads the code line by line and it needs everything to be structured properly or it raises an error. So you can call this error as compile time error, right? So say for example, you're typing up an email and the spell checker that you use, it could be Grammarly or any other spell checker that you use, it underlines mistakes for you as you type, right? So this can be an analogy for compile time error in Python. So, but the thing is, in Python, we do not use the term compile time, rather we use syntax error. Uh, but the thing is, in Python, we do not use the term compile time error, rather syntax error is more preferred, right? Moving on to runtime error. Now, moving on to the runtime errors. So, the runtime errors happen while your code is running, after the syntax is checked and the program has started to execute, right? So, basically, your interpreter has gone through your code line by line and has given you a go signal that you can go ahead and execute it. So, these errors usually occur because something unexpected happened during the execution of the program that the interpreter wasn't prepared for, right? Right. So, an example of runtime errors or an analogy with a real life situation would be, say, a person driving on a smooth road, and then all of a sudden a bump or a pothole arrives, and the person has to suddenly apply the brakes, right? So, everything was going fine, but then something unexpected disrupts the flow. That is something known as runtime error, right? So now the second part of the question is, do they exist in Python? So you need to tell the interviewer that yes, they exist in Python, but also mention at the same time that compile time error is known as syntax error, right? In Python, we do not use the term compile time error, but rather we use it as syntax error. So both types of errors exist in Python. And Python handles everything else as runtime errors, which can include things like type errors, index errors, or exceptions that are only detected once the code is in action. We can start by saying, yes, both types of errors exist in Python, though we do not use the term compile time error, rather we use syntax errors, which serve the same purpose. And you can continue and say Python handles everything else, all the other errors like the type errors, index errors, or exceptions that are only detected once the code is in action as runtime errors, right? So this is how you're going to wrap up your answer. So before we move on to the next question, let us quickly go through the compile time error code once. So as you can see, this is my code and I have missed a semicolon over here. And let's see what happens, right? So as you can see, missing colon and expected over here, and it is giving syntax error, right? So compile time error, basically before running the code, when our interpreter is going through it line by line, it reaches here. So now as we studied that Python uses an interpreter and interprets the code line by line and raises the error wherever the structure is not matching the interpreter's expectations. So it will print hello before raising an error, right? Let's try and run it. So that was all about compile time error and runtime error. And we also saw how they are implemented in Python and what is the kind of error, the syntax error that is raised in compile time error, right? Now let's move on to the next question. What are generators and decorators, right? So now this is a combination of two questions. Usually generators and decorators are not asked together in one question. But in order to avoid any confusion, I have put these two questions together so that you can also know the difference between the two, right? So first, let's look at the generators. So generators and decorators are basically two powerful tools in Python that help make code more efficient and readable. But they, again, serve very different purposes. As I told you, these are supposed to be two different questions. They have no interlink whatsoever, right? So let's look at the generators first. So generators are a function that basically return an iterator. So using this iterator, we can iterate over one value at a time. So instead of returning all the values at once like a normal function, a generator yields values one by one, which makes them more memory efficient. So this is again done using the yield method instead of the return method. So as you guys must have noticed that whenever we create a function, any function, we usually return the value at the end. But whenever we use generators, we use the yield method instead of the return method. So this is useful when dealing with large data sets or infinite sequences, right? So say for example, if you need to process each line of a huge file, you wouldn't want to load the entire file into memory, right? It would firstly affect the performance of your machine and also make it difficult to read the entire data set or the entire file at once. So this is where generator comes in the picture, and generator allows you to process each line as it is needed, one at a time. So again, it is helping in making your code look neat. It is helping in the understanding of the data. Another important feature of the generator is that they remember their state between each line, right? So say you have 10 lines of file, and you yield the first 2 lines, and then you take a break, you take a pause. So what the generator is going to do is it is going to keep its pointer over here. So first it read this, and then it moved on here, and then it is going to stay here until you yield or until you retrieve the data again, right? So it remembers its state between each yield. So the next time you call the generator, it picks up where you left off. So this makes them very different from the normal functions, which always start fresh, right? If you were to call a normal function, it would start from here always. So this is a basic illustration of a generator. So we have a for loop over here. So we have a for loop over here, which is iterating through this tuple, which is containing 1, 2, and 3. And so we have a for loop over here, which is iterating through this tuple containing 1, 2, and 3 elements. And basically, we're trying to return I plus 1. So when I is equal to 1, it is going to return 2. And when I is 2, it is going to return 3. And when I is 3, it will return 4, right? So this is what is happening over here. If we were to run this loop directly, we would just get all the output at once, right? What we are passing it through a generator, and this generator is going to return an iterator through the yield method, and this is going to be our output, which is going to be retrieved one by one, right? Let us quickly go ahead and look at an example. So let us go ahead and quickly look at how generators work, right? So as you can see over here, I've created a countdown function, and it is taking a parameter num. Now you can see I've created a for loop, and I'm passing 5 as my argument in my countdown function. Now what this for loop is doing is basically it is going to print the count. Now whatever the countdown function returns or yields is going to be stored in count, and then we're going to print it over here, right? So let's look at the countdown function. It is going to check whether a number is greater than 0. If it is greater than 0, we're simply going to yield the number. Yield is basically another method of returning it. So we store this number in count, and it is going to print over here. And then we go ahead and decrement the number by 1. So this process is going to repeat until the process is 0, right? As you can see over here, I get my output as 5, 4, 3, 2, 1, right? Okay, what if I were to use return instead of yield over here? You can see int is not an iterable, so I get an error, right? So this will not work in the case of return, and this is why yield is used in generators. Then we have our decorators. So what the decorators do is basically they modify the behavior or the pattern of a function or a class, right? It is pretty evident by this image. So we had a yellow color fruit. You can consider it as a mango, or so you can see we have a fruit over here, and when we pass it in a decorator, the color changes, right? So we are not modifying any core property of this fruit, rather we are just changing its behavior, right? So this is what decorators do in Python. They're often used to add functionality to an existing function. Basically, they extend the functionality of an existing function without changing its code, right? The core functionality remains the same. Only the behavior or a certain feature of it is extended. So decorators take a function as an input or as an argument. They add some behavior and then return a new function. So this is useful for cross-cutting concerns like logging, authentication, or timing how long a function takes to run, right? Let's look at our decorators. Let's see how they are implemented in Python. So as you can see, I have created a function greet, and all I'm doing in this function is I'm printing hello, right? Now what this @decorator func. So this is the name of my decorator function over here that I've created. And using @ before this is basically a shortcut to this syntax. So basically, I am creating a variable greet, and I'm calling my decorator function decorator func, and I'm passing my greet function as an argument, right? So this is a great shortcut for the entire syntax. I just have to write @decorator func, right? So I've already created a variable greet, and all I have to do at the end is call my decorated function. So once I apply this method, this greet variable becomes my decorated function. Now let's go ahead and look at my decorator function. So as you can see over here, I've created a wrapper method inside which I am modifying the functionality of my function. I am printing that something is happening before the function, and I'm printing something is happening after the function, and in between I'm calling my function as well. So once I have modified the functionalities completely, I will just simply return my wrapper method, and upon calling my decorator function, this is what is going to be returned. So I have simply modified the functionality, whereas my main function remains the same. I have not touched my greet function. I have just modified it using a wrapper function. So this is how decorators work, and they are used to extend the functionalities of an existing function without changing the code. So let's quickly summarize generators and decorators. So generators create or return iterables one at a time, and decorators are about wrapping or extending functionality of an existing function, right? Simple enough? So pretty simple, right? So let's move on to our next question now. What is the difference between abstraction and encapsulation? So now we have entered our OOPS concepts, and abstraction and encapsulation are a very important topic under this concept. Even though they serve very different purposes, coders and users tend to get confused between the two terms, right? So first, let's look at abstraction. So in order to differentiate between the two, we'll go ahead and explain the terms individually. So first, we'll look at abstraction. So abstraction is all about hiding the complexity of a system and showing only the essential details to the user. So basically what abstraction is doing is it is focusing on the what rather than the how. It is not going to show you how the brakes of a car are functioning. Rather, it is just going to show you the interface or the application, the brake, where you can just go ahead and use it, right? So what abstraction is doing is basically it is focusing on the what rather than the how. By using abstraction, we're providing a simplified interface while keeping all the intricate workings of the system hidden, right? We do not want to show the user how our application is working. Rather, we just want to give them a very smooth and interactive interface, right? So this is a functionality of abstraction. So let's consider an example here. So say you're driving a car, you will only care about pressing the accelerator to make it go faster and the brake to make it go slower, right? That's a basic functionality we understand about the car when we're driving it. We do not need to know how the engine works, how the fuel is burned, or how the brakes are actually stopping the car, right? So that is how you can relate abstraction. So this is how you can relate abstraction with the real life examples, right? So this is how you can relate abstraction with real life examples. So now let's look at this image over here. We have our methods taste and color. So now you can consider these as the parent class. So they are just implementing these methods. They're just implementing, say we have a class and inside which we have these two functions. So you can see the function taste and the function color are just being implemented and they are not doing anything, right? And then we have our child classes, which basically inherit from the parent class and implement these methods, taste and color, and implement their functionality. So we can provide these implementations in the child class itself. So we are not worrying about how these are being implemented. Rather, we are just passing our features. That is, I want this fruit to be tangy and the color to be tangerine. I want this fruit to be sweet and the color to be yellow, right? We're just looking at the outer surface rather than understanding how this came to be. So now that we have understood the theoretical part, let's go ahead and look at the code implementation in Python. So in order to implement abstraction in Python, from the ABC method, you can import the abstract base class method and the abstract method. So we have created a parent class animal over here, and we have passed our abstract base class ABC as a parameter, and we have called our abstract method over here, and we have created a function make sound and not implemented anything, right? And then we create a child class or a subclass dog, and we inherit from the animal class, and we simply implement the make sound function and print bark, right? So we are not bothered with how the make sound function came to be or how it is being implemented. We are just, so it is up to the dog class over here to implement the make sound function in whichever way it wants, right? So this is one example of abstraction. The next point is encapsulation. So as you can see over here in this image, there's a capsule, and in one part of the capsule we have our variables and our methods, and in the other part we have our class, right? So this is an analogy for encapsulation in Python, how it works. So encapsulation is basically encapsulating all our attributes, all our data, all our methods, and protecting them, right? Let's look at them in detail. So encapsulation, on the other hand, is about restricting access to certain parts of an object or a class to protect its details, right? It hides the internal details of how an object works, how it functions, by bundling the data or the attributes and the methods or functions into a single unit or class. So how it hides the details is by making those certain attributes private. So it can easily make any attribute private by using the double underscore as a prefix. So say I have an attribute balance, which basically stores the balance of my bank account. I need to keep it private because I would not want it to be accessed just like that, right? So I'm going to keep it as a private variable by using the double underscore. Now this attribute can be accessed within the class in different methods, but outside the class, for any instance, it cannot be accessed directly, right? So it is going to raise an error whenever an instance of the class or an object is going to try and access this private method. So in order to understand encapsulation in detail, let's look at the code for encapsulation. So as you can see, I have my class car over here, which is implementing the function accelerate and the function get speed. So whenever I call accelerate, it is going to increase my speed by a certain value. And whenever I access get speed, it is going to return the current speed of my vehicle. Now, as you can see over here in my dunder method, I have declared my speed variable and initialized it to 0. But the only different thing over here is I've used a double underscore as a prefix for my attribute speed. So now this becomes a private variable or a private attribute. So now you can see I have instantiated my object car using the variable car, and I'm trying to access my speed over here. So when I run my program, I get an error. Car has no attribute speed, right? I cannot access this private attribute outside my class. But what if I want to just print my speed, right? I want to know what the speed of my vehicle is. So I can use the method get speed, and I will pass it in a print function to print the value. And I will pass it in the print function to get the value. So you can see I got 0 as my output. If I were to increase the speed before printing it, I would simply tell my program to accelerate, and I would pass the value, say 10, right? I want my speed to be accelerated by 10, and now my current speed is 10 because initially it was 0 and it is getting incremented by 10. So you can see I will be able to perform all the other operations that are available in my class, or I will be able to access all my functions, but I will not be able to access my private attribute directly. So this is how encapsulation works. This is how encapsulation works in order to protect the car's internal state, and in order to prevent any outside control, we made the speed variable private, right? So it cannot be modified through illegal means. So the main goal of encapsulation is one, to prevent direct access to the data, which also applies the concept of data integrity, So the main goal of encapsulation is one, to prevent direct access to the data, which also applies the concept of data integrity. So the main goal of encapsulation is to firstly prevent direct access to the data, which also applies the concept of data integrity. And the other is to show only what is needed, which is also known as abstraction, right? So you can say that abstraction is a functionality of encapsulation. So that was all about these two important OOPS concepts. Now let's move on to our next question. What is method overriding and how is it different from method overloading? Now, this is an important question because, again, method overriding and method overloading are quite confusing, and people tend to mix up with the two concepts. So, in order to understand overloading and overriding, let's look at this diagram really quickly. So, in overloading, you can see I have a function my sum, right? And as you can see, it is taking variable number of parameters. So whatever may be the functionality, you can see the first time I'm calling it, I have two variables over here. I'm adding two numbers. And for the second time I'm calling it, I have three parameters or three arguments that are being passed. So this is what overloading refers to. Whereas overriding, as you can see over here, I have a parent class. I'm implementing the function mySum and I have two variables A and B. But when the child class inherits from the parent class, it is going to apply the same functionality, but the only difference is the parameters are going to be different. Now, in case of overriding, we have a parent class implementing the same method mySum. Maybe it is performing some operation. Maybe it's adding the two elements over here that are being passed as arguments, right? So as you can see, in case of overriding, we have a parent class mySum, and it is taking two parameters A and B, right? Now this parent class must be applying some method, some functionality to this method, right? But when we inherit this very method in our child class, the functionality or the behavior of this method could change, right? So this is what refers to overriding. Let us go through these concepts in detail. So method overriding and method overloading are both ways to achieve polymorphism in object-oriented programming. But again, they work in very different ways, right? So method overriding happens when a subclass provides a specific implementation of a method that is already defined in its parent class. So we're basically changing the functionality or the behavior, or the child class overrides the behavior of the parent class's method. The key point over here is that the method, that is like the names and the parameters, remain the same, but the behavior changes. As you can see in this image over here, we have the same parameters that are being passed, A and B, but again, the functionality or the behavior for both of these classes or both of these methods that are being called in the parent class and the child class will vary greatly, right? So the subclass basically extends the features of the parent class. This allows the child class to provide its own version of the method that better suits its needs. And then we look at method overloading. So method overloading in languages like Java or C++, method overloading allows you to basically define several versions of a method. Each are designed to handle different input. But in Python, overloading isn't supported directly. Again, we cannot say that Python directly supports overloading. Instead, Python typically handles it using default parameters or by checking the types of arguments manually. So now that we have understood overriding and overloading, let's go ahead and look at their implementation in our VS Code. So first, let's look at overriding. So we have a class animal and we have a method implemented in our parent class which returns some sound, right? So this speak method over here returns some sound. And then we have a child class dog, which is inheriting from the parent class animal, implementing the same function over here, but returning a different output, right? Over here, there is some sound and over here, there is bark. So basically, this child class is overriding the speak method, which is basically extending the feature of the speak method and returning a different output, right? So when we instantiate the dog class and access the method dog.speak, our output is simply going to be bark, right? So it has overridden the initial output that was supposed to be given by the animal class or the parent class. And then we have overloading. So we have a class math over here, which is basically implementing an addition function, taking the input A, B, and C. We have initialized C as 0. So this function is basically going to add all these arguments and return them. So the first time we call this method, we pass only 2 arguments, 2 and 3. Now since C has already been initialized as 0, it will not throw any error, right? It will just consider C as 0 and add 2, 3 and 0 and return the sum, which is 5, as you can see over here. The next time we call this method again, we pass 3 arguments, 2, 3 and 4. Now instead of 0, C takes the value of 4 and returns the output as 9. So this is how overloading is performed in Python. Moving on to the next question, how does inheritance work in Python? So whenever we hear the word inheritance in our day-to-day lives, we think of assets, we think of property being inherited by the children from their parents, right? So this is a similar concept that is implemented in Python. So inheritance in Python is again a key feature of OOPS that allows one class, that is the subclass or the child class, to inherit the attributes and the methods from another class, which is the parent class or the superclass. So this application or this methodology promotes code reuse. So whenever a child class inherits from a parent class, it automatically gains access to the parent's class's methods and attributes, meaning you don't have to rewrite them, right? So whichever methods, whichever functions that have already been implemented in the parent's class, we can directly use them in our child class. This wouldn't be possible without inheritance, right? Our code would raise an error if one class directly tries to access the attributes or the methods of another class. This is where inheritance comes in the picture. Inheritance will allow one class to access the features that have already been implemented in the other class. So accessing is one thing. The child class can also extend or override these methods to change or add functionality to the existing methods, right? We can take the example of a real-world application would be a vehicle whose attributes and methods would be again applicable to all the types of vehicles, such as different makes and models. So all the models, all the different brands would have 4 tires, would have 4 windows, would have some common features that can be accessed from the vehicle class itself. So let's quickly look at the implementation of inheritance in Python. We have a self variable name. We have implemented a method speak, which returns name and makes a sound, right? And then we have a subclass, our child class dog, inheriting from the animal class over here, as you can see. And we are overriding this method speak and returning name barks, right? So we have overridden the function, we have inherited and overridden it. So you can see we have nowhere implemented the name function, but we can directly use it because we have inherited from the animal class. So let's see, let's run and see it. So, right, so it prints buddy barks. We have given an input for name as buddy, and it is printing buddy barks for the dog instance, right? So this is how inheritance works. And then we have a next question, which is again a very important one. What is the significance of self in Python classes? Right, so as you have already seen, most of the codes that we have implemented till now use the word self, right? Whenever we use the dunder method in it, we had the self keyword as parameter. So in Python, self keyword is like the glue or a bridge that connects an instance of a class with its methods and attributes, right? So whenever you create an object from a class, you need a way to refer to that specific object inside the class's methods. That's where self comes into play. Let's relate it with a real world example, right? Uh, just suppose you're working in a company and each employee in that company has a badge with their name on it. Now, if you want to personalize a message to each employee, you need to know who they are, right? Self is like the employee's badge. It lets the methods in the class know who they're working with. So it basically connects the instance of a class with the associated methods and attributes, right? So that is the main functionality of the self keyword. And as you have already noticed, whenever you define methods inside a class, the very first parameter that is always passed is self, and it refers to the object that's calling the method. So this allows each object to have its own data, which is very crucial for OOPS. Now, this is also what differentiates instance attributes from local variables. Now, say I have a function which again takes self and let me just write it neatly. So in order to understand the self parameter, let's look at this example, right? So we have our class employee, which is taking the name and position as its arguments. And as you can see over here, we've implemented a greet method, which is basically introducing the person. It is saying, hi, I am, and it's going to print the name of the person, and I work as, it is going to print the position of the person, right? So here we create an instance of employee and we pass John and manager as name and position respectively. And then we call the greet method. So using this object that we have created, we have instantiated the employee class. We use that to call the greet method, right? So Python automatically passes emp1 as self. Now the class understands that our employee 1 is John, who is a manager. This is possible because of the self keyword over here. So this is what is connecting our object and our method over here. So it is the self keyword that is connecting our object and our method. So it is the self keyword that is connecting our object and the method that is in our class over here. Now moving on to the next question, what are class methods and static methods and how are they different from instance methods? So now in order to answer this question, you need to know class methods, you need to know static methods, and you need to know instance methods. So the strategy that we would follow would be to explain these three methods, give examples for all of them, and maybe give a few key pointers that differentiates the three, right? So first we'll begin with class methods. We'll explain what they are. So basically a class method is tied to the class itself. It is not an individual instance of a class. Rather, they modify the class state or class level attributes. They do not modify a specific object instance, right? Instead of using self, class method takes CLS as their first parameter, which refers to the class itself. One important point is the class methods are defined using @class method, right? So this is a decorator that lets us define the class methods, which tells Python that the method works with the class and not a particular instance, right? So let's look at how the class methods are implemented. So you can see over here, we have a class dog. It has a global variable species, global variable inside the class, right? We have our dunder method over here, and then we're creating a class method. As you can see, we have declared it with the decorator over here, and we are calling a method change species, and our first argument over here is CLS, and our second argument is new species. So over here, this is our default species name, but if we want to change it, we can use the change species method, and our variable species is going to be affected globally inside the class, right? Let's go ahead and run this program. So you can see instead of canine, our species has become feline, right? Our input over here as we changed it using dog.change species. So this is what class instance means. So now let's look at our static methods. So static methods are quite different from both the instance and class methods because they do not really depend on any instance or class specific data. So a static method is basically a regular function, but the only difference is we include these static methods inside a class to make our code look neater and for better organization. So static methods are again defined by the decorator called static method and using @ as a prefix. So they do not take any self or CLS as parameters. And they are usually utility methods that perform tasks that don't involve accessing or modifying class or instant data. Static methods are really useful when you need a method that logically belongs to the class but doesn't need to access any class or instance specific data. So let us see how that is done. So you can see we have a class dog over here, and again we have a static method dog age in human years. So what we're doing here is we are converting dog age to human years. Now this does not require any sort of attributes from the class. Rather, we're simply going to pass our argument when we call the method itself, and it is simply going to return. So it does not need to access any class level or instance level data. So no self or CLS is required. Rather, it is simply going to multiply 7 to our past argument and return that. So this is why static methods do not require any sort of arguments as self or CLS. Then our next method is instance method. So instance methods always take self as their first parameter. As you might have seen the init or the dunder method, they always take self as their first argument and then whatever parameters are required for the function, right? So this is one example of instance method. They always require self as their first parameter. Self basically refers to the instance that calls the method. As we have already seen in the previous question, self is basically the bridge that connects the method and the instance that calls the method, right? So using this, they can access instance-specific data or the attributes and perform actions on that data. So let us quickly look at the code for instance methods. So you can see over here, we have our instance attribute name and breed, and we create an instance method bark, and that bark is basically going to print name says words, right? Whatever name we pass as a parameter, we've passed buddy over here, so buddy says wolf is what is going to be printed. Let's see. So buddy says wolf. Golden retriever is our breed over here, which we are not really using in our method, so it is nowhere being printed. So this is how instance methods work, or they are implemented in Python, right? Moving on to our next question, explain the differences between a set and a dictionary. Now we know a set and a dictionary are both built-in data structures, right? So you can see in this image, a set is somewhat stored like this. So we have different elements stored in curly brackets. We know dictionary also use curly brackets, but the only difference is they use key value pairs. So basically we'll have a key called B, which will be pointing to the value beauty using colons, right? We have J for joy and C pointing to computing, right? So now the main properties of set is that they are unordered and they're unique, right? They will never store duplicate values. So sets will never store duplicate elements. So this was just an overview. We'll go ahead and look at the differences in detail. So sets don't really care about any order, right? They're unordered. The items are not stored in a specific sequence. So say if you were to insert the elements A, B, and C in that particular order itself, A, B, and C. So say this is stored in set C. So the order could be B, C, A, or it could even be B, A, C. So it is completely unordered, right? It does not follow a specific location or a specific. And the main rule for sets is that every item inside the set must be unique. That is, no duplicates are allowed. So this is useful when you want to avoid duplicates or quickly check if something exists in the collection. So in Python, sets are unordered, meaning they don't maintain the order in which you add items. You can't refer to items by an index like you can with lists and tuples. So if you were to store your elements, say A, B, and C in a list at the indexes 0, 1, and 2, you could easily access A at index 0, B at index 1, and C at index 2. But that is not the case with sets because, as I told you, they're unordered, so their indexes are not fixed, right? A could be at index 0 in the first time you printed, and the second time you printed, it could be at index 1. So this is why you cannot access them through indexes. And they're also useful to check if an item exists because, again, you will only have unique items, so there won't be any duplicate items. And to check if an item exists, there will be fewer number of passes or iteration, right? And lists are also mutable. That is, you can easily add or remove items from a set. And then we have dictionary. So dictionaries are key value pairs. They're like a real world dictionary where you have words as keys and their meanings as values, right? You would pick up any dictionary that you have. You will have a similar implementation in that dictionary. So in Python, a dictionary is again a collection of key value pairs, and every item has two parts, a key and a value. Another analogy of a dictionary could be an address book where you store people's names, which would be the keys, and their phone numbers and other details about the person, like their address, as their values. So in dictionaries, the keys must be unique, right? So now in dictionary, the keys must always be unique. Just like in a dictionary, how each word is unique, similarly, dictionaries in Python also have unique keys. And then the values, on the other hand, can be anything, right? They can be string, numbers, lists, even other dictionaries, and they do not need to be unique. So the values do not really follow any constants over here, but the keys need to be unique and they need to be immutable as well. Dictionaries as a whole are mutable, but the keys, the data types that are used for the keys, need to be immutable. So now let's quickly differentiate between the two using some pointers. So let's look at the structure of the two data types, right? So sets contain individual items with no associated pair, just unique elements, whereas dictionary contain key value pairs where each key is associated with a value, right? Now, then let's look at the purpose. So sets are used when we need to collect unique items and we do not care about their order. For example, when we need to collect the unique words from a text, right? Whereas dictionary is used when we need to map one item to another. For example, storing people's contact details where names are the keys and phone numbers are the values, right? Next comes order. So set is unordered. The order of the elements does not matter. And dictionaries are ordered. That is, keys and values are kept in the order you add them, right? Then comes accessing the elements. So you can only check if an item is present, add or remove items, but there's no index or key to directly access a particular item. Whereas dictionaries, you can access the values by referring to their associated keys, right? So this was the difference between a set and a dictionary. The more points you remember, the better, because again, the interviewer is looking for as much information you can give to him or her during an interview. Then the next question is, what is the time complexity of inserting elements in a linked list? Now, whenever these kind of questions are thrown at you during an interview, do not directly start with the time complexity and do not ever give direct answers to the interviewer. Always start with breaking down from the most complex part. So we'll start and first understand linked list, right? So linked list, maybe you can give a one-liner about what is linked list, what do you understand about linked list, and then move ahead with the answer, right? So a linked list is again a data structure where each element is called a node and it contains two parts. So as you can see over here, this is one node, right? So as you can see over here, this is one node. And this node has two parts. One is the data and one is the reference or a pointer which links to the next node in the list, right? So unlike an array where elements are stored in contiguous block of memory, a linked list stores its elements in separate nodes that are scattered in memory but connected by references. So the only way we know that B is stored after A is because there is a pointer from node A to node B telling us that there is another node which contains the data B, right? And how do we know that this is the first node? Because we have our head pointer pointing to this node. Because we have the pointer of this node pointing to null, which is basically telling us that there is no further node and I am the last node, right? So the time complexity for inserting elements in a linked list depends where we're inserting that element, right? If we're inserting that element at the beginning, we would have a time complexity as 1. We would have a time complexity as 1. Because this operation is very simple. If you're inserting a new element at the head of the linked list, you just have to create a new node, make this node, you just have to create a new node, make this node's pointer point to the current head node. Like this was our previous repeat. This was our initial head node, right? So the pointer of this node is going to point to the current head node, and the head has to be pointed to our new node. This operation is always going to be performed in a constant time, meaning it is going to take the same time no matter how many elements are there in the linked list. So the time complexity is big O of 1. The next operation is inserting the element at the end. So this can be a little more complex depending on the setup. So if you don't have direct access to the tail node, you need to traverse the entire linked list to find the last node, which takes big O of n time, where n is the number of nodes. So once you find the last node, inserting the new node is again a constant operation. It's just going to take big O of 1 time because you just need to update the last node. All you have to do is update the last node's pointer to the new node and update the new node's pointer to null. This operation is always going to take big O of 1 time because it's a constant operation, but the overall time complexity is going to increase because of traversing through the entire linked list, right? And then we have our last operation, which is inserting the element anywhere in between the linked list or at a specific position. So this operation is again going to take big O of n time, because in order to find where exactly you need to insert the element, you will have to traverse through the linked list to find that position. For example, if you want to insert at position k, you have to traverse k nodes to reach that spot, right? After you find the correct position, the actual insertion operation is again big O of 1, right? This operation is only going to cost us big O of 1, but the actual complexity is going to increase for traversing through the linked list. So the overall time complexity over here is big O of k, where k is the number of nodes, where k is the number of nodes that you have to traverse in order to reach the insertion point. But since big O always considers the worst case, what if you have to insert your element right at the end, right? So k is going to be almost equal to n, where n is the total number of nodes. That's why we're going to have our time complexity as big O of n, right? So I hope this was clear. Moving on to our next question. How do you find the middle element of a linked list in one pass? Now, finding the middle element of a linked list is no big deal, because if the interviewer was to ask you to find the middle element of a linked list, it would be very easy. All you would have to do is traverse through the entire linked list, keep track of the number of nodes. Say the number of nodes over here are 5. So you could easily use a formula and figure out that your middle element or your middle node is at index, is the third node. So you would easily be able to figure out that your middle node or your middle element is the third one, right? But the constant over here is one pass. So what does one pass mean? It means you traverse the linked list only once. You don't get to go back or have multiple iterations through the list. That means you can only traverse through the linked list once. You cannot go here, come back, and then go through the list again and then stop at the third node, because you figured out that the total number of nodes are 5, and therefore your middle node or your middle element would be the third one, and you would then return the data stored in the middle node. So that cannot be the case, because you need to do the entire thing in one pass. So this is where the two-pointer technique comes in the picture. So this two pointer approach basically uses a slow and a fast pointer, right? As you can see in this diagram, the slow pointer is going to move one step at a time, and the fast pointer is going to jump one node in between and is going to move two steps at a time. So it is pretty evident from this diagram, when our slow pointer is at the middle, our last pointer is going to be at the our fast pointer is going to be at the last node. So this is basically our condition, right? Whenever our fast pointer reaches null, like whenever the fast pointer reaches the last node, our slow pointer is going to be at the middle node. So this is the approach that you can follow and explain to the interviewer in detail. So you can also explain that since the slow pointer covers only half the distance in the same time as the fast pointer covers the full distance. So this is the main reason why we would have a slow pointer pointing to the middle element while the fast pointer is at the last node, right? Now this is a very simple explanation, but in order to stand out, you should also consider the edge cases, right? Like if you have odd number of nodes, say you have only 3 nodes, in this case, the fast pointer will reach the end node and the slow pointer will be exactly in the middle node, right? So our slow pointer would start here with the fast pointer. Say this is a fast pointer. So the slow pointer would be exactly at the middle node and there would be no complications as such. But in case of even number of nodes, we have our slow pointer here and a fast pointer over here. When we have a slow pointer here, our fast pointer would be over here. When our slow pointer goes here, our last pointer would be pointing to null, which means out of these two, one of them is our middle element. So this is where you need to decide which one of your nodes you want to consider as a middle node and pass the element of that node as a middle element, right? So this is a very important edge case that you need to consider. So moving ahead with our next question, which is an implementation based question. You will usually find these questions in the final round of your interview. So I would say the difficulty level would increase over here. You have to write a function that will implement a logic such that whenever the function takes a string as input, it should return the length of the longest substring that contains no repeating characters. Right, so for example, you have this string over here, and as you can see from FAVTU, we have no repeating characters, but the moment we come across this T again, we know it's a repeating character. So again, our longest substring without any repeating characters is 5, right? 1, 2, 3, 4, 5. Similarly, over here, we have another string called Python. So as you can see over here in this Python string, we do not have any repeating characters. So the entire string is a substring without any repeating characters, right? So these are the two cases. Let us look at the implementation in detail, right? So this is the way you will be given the question. You will be given examples where you will be given the sample input, the sample output, and the explanation. So this is the common approach the companies follow whenever they give these kind of questions, right? Implementation based question. So we have an input over here, A, B, C, A, B, C, B, B. Now, the longest substring we can find over here is A, B, and C. Because the moment we move from C to A, we know this is a repeating character. And then again, B is also a repeating character. And then BB over here is also a repeating character. Right? So, our longest substring is A, B, and C. Then, similarly, we have another example, which is B, 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 B. Right? So, our longest substring is just going to be with one character B because all are repeating over here. Then we have another one, which is PWWKEW. Now, our longest substring can be either KEW or WKE, right? So the answer is going to be 3 over here, no matter what. So this is the main logic behind this question. So first, what we're going to do is look at the brute force approach. Now, what the brute force approach says is you have to generate all the substrings for a given string. Now, say I have this string over here, right? So what we're going to do over here is run 2 loops over here. So you can say my first loop I and second one is J, right? So now what I'm going to do is I'm going to generate all my substrings starting with character A over here, right? So I'm going to keep moving my J forward till I have all the substrings generated starting from A. So my first substring is going to be just A, then it's going to be A, B, then it's going to be A, B, C, and then it's going to be A, B, C, A, right? So I'm going to generate all my substrings like that starting from A. Then I'm going to increment my I, and then I'm going to have my second set of substrings starting with B, right? So it's just going to be B first, then it's going to be B, C, then it's going to be B, C, A, and so on, right? So I'm going to do that with all the substrings, and then I'm going to check whether the characters in all the substrings are unique. Now over here I have unique characters, over here I have unique characters, so my maximum length is going to be 2 over here. For initially it's going to be 0, then it's going to increment to 1, then it's going to increment to 2, because again 2 is greater than 1, and then we're going to move over here, which is 3. But over here you can see I have a repeating character, so my maximum length is going to remain 3, right?
Yeah.
Similarly, we're going to do that for all the substrings. Now imagine the complexity in this kind of approach. It is going to be really high, right? We'll be running 2 for loops, so the complexity goes to n square automatically, and then we're going to have to do a lot of comparison and a lot of operations in a brute force approach. So that is why we have come up with a simpler or an optimized version or an optimized solution, which is a 2-pointer method, or it is also known as sliding window. So what we do over here is, so let us look at the steps real quick. So we start with a left and right pointer. So instead of running our loops with I and J, now we're going to run it with our left and right pointers, right? And our left pointer is initially going to be at 0, and our right is also going to start with 0. And then what we're going to do is we're going to increment our right pointer until we come across a repeating character, right? So now our main condition over here is, if our right pointer comes across a repeated character, we simply have to increment our left pointer by 1 plus the index of our last occurring character. Now this might sound a little confusing over here, but let us quickly look at the logic behind it. So we again have this sample string. We have our left pointer here and our right pointer here. Our maximum length is initially 0. Now we know that our right pointer has come across A, so we're going to create a hash map or a dictionary, and we're going to map A with index 0. And then we're going to increment our right pointer by 1, and then it's going to point to B. So now our maximum length is going to be 1, right? So B is again not a repeating character, so we'll map it with the index 1. Then we come across C, which is at index 2, and we increment our maximum length to 2. And now our maximum length is 3, right? Initially it was 0, then we came across A, which it was incremented to 1. When we came across B, it was incremented to 2. Then when we come across C, it is incremented to 3, right? Then we come across A. Now this is a repeating character. So what we're going to do is we have to increment our left by the index of A, which was initially 0, plus 1.
Yeah.
So now our left is going to point to B. And then we update the index value of A as well. So now the last time we found A was at index 0, 1, 2, 3. Right? So this is how we run the loop. Now let us complete this. Now our right points to B, which is again a repeating character. So we follow a similar approach. We are going to increment our left by 1 plus 1. So it is going to point over here at C. And then we increment our index value of B to 4. Right? So now our substring is from here to here, which is stuck at 3 itself. And then we increment our right pointer again. So again, this is a repeating character. We update the value over here and we increment our left pointer by our previous value was 2. Now it is 2 plus 1. So it is 3. Our left pointer is going to point at A. So now our string is from here to here. Right? So A, B, C, D. So this is our longest substring over here, as you can see. So our maximum length turns out to be 4 at the end. And then we update the value of D as well. So it is at 0, 1, 2, 3, 4, 5, 6. right? So this is the basic logic behind two-pointer method or the sliding window method, which is really simple if you get a hang of it, and it is super easy to implement. So now let us quickly go ahead and look at the code for the same. So this is again a very short 18 lines of code, not even 18 lines. So let us quickly go ahead and look at it. So we created a function length of longest substring. We passed a string over here. We have initialized a maximum length variable to 0. Our left pointer is also at 0. And we created a dictionary called character count. Now we run a loop and we are going to increment our right pointer in this loop. So our current character is the character that the right pointer is pointing at, right? So we stored it in a variable called current. Now if our current character is present in our dictionary, that is, it is a repeating character, and the index value of that particular character previously is greater than our left pointer, then we are going to increment our left pointer, right? So this is the main logic that we have implemented. Now after implementing the if condition, we come out and we update our maximum length value, and we also update the index of the character, right, in our dictionary. And after coming out of this entire for loop, so see over here, we are running the for loop only once. So this is directly decreasing the complexity of our program. And then we simply return the maximum length value. And let's run our program to check it once. Yeah. So here you can see 4 is our maximum length of substring without any repeating characters. So yes, it was a very easy problem. So yes, it was an easy problem, and I hope you guys got a hang of it and will be able to implement it on your own. So now our 29th question is again a very interesting one, and it is very commonly asked in a lot of interviews. This is also known as the 0-1 knapsack problem. Let me just write it down for you guys. So this problem is also known as the 0-1 knapsack. Now 0-1 means either nothing or the entire thing, 0 or 1, right? There's no fraction over here. Either we take the entire thing or we don't take it at all. So you're given a set of items, each with a weight and a value. So now we have a weight for each item and we have a value for it. So the value is $4, and we'll consider any kind of currency. It could be rupees, dollars, anything. Basically, it has some value and it has a weight also. Your task is to figure out how to pack the most valuable items into a knapsack without exceeding its weight limit. Now we have a knapsack over here, which is nothing but a backpack, and we have a capacity for our backpack. Over here it is 15 kgs. So now each item either can be taken or it can be left behind. We need to find a method where we can keep the most valuable items. Like we should have the maximum value out of all the things we take in a knapsack, right? So let us look at the approach. So this is how you'll be asked the question in interviews. You'll be given the problem statement and you'll be given some constants, and then you'll be given sample inputs and outputs. So over here, we have A as our values associated with the items, B is our weights, and C is the capacity of our knapsack or our bag, simply. So let's look at this. Now we have the bag capacity as 8, right? And we have 4 items over here, and each item has a weight and a price. Now if we were to check the items one by one, if we were to follow the brute force approach, what we would do is we would consider all the items one by one and consider the possibilities as well. So if we talk about item 1, okay, let's say I have 4 items over here. So now this item has only 2 possibilities. It can be taken or it cannot be taken, right? This also has 2 possibilities. This again has 2 possibilities, and this also has 2 possibilities. Now if I were to have n items like this, each having 2 possibilities, my complexity would turn out to be somewhere around 2 to the power n, which is again very high, right? So what I am going to do over here is, I'm going to implement something known as dynamic programming. So what dynamic programming does is basically it helps you break down the complex problems into smaller chunks and it makes your solution more manageable, right? So we're going to look at the approach for dynamic programming over here. So over here, let's call our table as V. Let's call these columns as J, and let's call our rows as I. Right? So V is our entire table. So I hope you guys are not confused. And over here we have our capacity, and over here we have our weights. So now if our capacity is 0, we cannot have any profit, or we cannot put in any weights. And if our weight is 0, again we will not have any item in our bag. So this is the first step to solving the problem. So now considering this example over here, I'm going to fill my table. So now I have my weights as 2, 3, 4, 5, right? Let me just write it down. And I have my profit associated with these weights as 1, 2, and 5, 6. Right? So let me show you how to fill this table without using the formula, and then we're going to fill the last few values using the formula as well. So what we're going to do is, as we go down these rows, we are going to consider the previous items as well. So if we are over here, there's no previous item, so it is just this item. But when we are considering this second item over here, we have to consider the first item as well. And similarly, as we go down. So what we're going to do here is, we have to consider the previous rows. So our maximum value is going to be 0. Now, if our weight is 2, the profit can be 1. So now we have to consider these previous columns, previous cells, and according to these, we can fill our next values. So it is going to be 1. And now you can see over here, our weight is 3 and our profit is 2. So whenever our capacity of the bag is 3, our profit is going to be 2. Then as we move along the line, now you can see when our capacity of the bag is 5, we can have the weight, the maximum profit as 3. So we have to consider the previous weights as well, right? So now based on the previous values, we're going to fill the previous cells. Over here, our maximum profit is going to be 2, then it's going to be 3, right? Then when we have our weight as 4, our profit is going to be 5, right? But when we have our capacity of the bag is 6, which is 4 plus 2, our profit is also going to be 6. But when our capacity of the bag is 7, which is 4 plus 3, our profit is also going to be 7. And now we can fill these previous cells based on our previous values over here. It's going to be 0, this is going to be 1, this is going to be 2, this is going to be 5. Maximum of these is 7, so 7, right? Now let's fill this last one using the formula. So now the formula goes like, let me just write it down for you. So V is the table, V of I and J. So V of I comma J is going to do nothing but locate a particular cell for us using the row and the column value. So this is equal to the maximum of V of I minus 1 comma J, or V of I minus 1 J minus W, Wi you can say, plus P of I. Now P of I over here is nothing but the profit associated with I, right? So now let's try and find this value using the formula. So we have table of I is 4 and our J is 1. So maximum of I minus 1 is 3 and J is 1. So 3 comma 1 is this cell over here. So we're considering this cell and we're going to compare it with I minus 1 is 3. J is 1. 1 minus the weight associated with I. So our I is 4, right? So the weight associated with the fourth item is 5. So it is basically 1 minus 5 plus the profit is 6. Now if I subtract this, this is going to be minus 4. And we do not have any cell that is pointing to 3 comma minus 4. So this is again invalid and we are directly going to consider this. So this has a value of 0, so we're going to fill 0 over here. Similarly, you can do that for all the cells over here. I'm going to do it directly, but you can go ahead and give it a try, right? So now whenever our weight is going to be 5, our profit is going to be 6. And similarly, when my capacity is going to be 8, my weight is also going to be 8 over here. As you can see, 6 plus 2. 5 plus 3 is 8. And my 6 plus 2 is 8 again. So the rest I can fill directly. And as you can see, this cell is giving me the maximum profit my knapsack can have when the capacity is 8. So the answer is 8 itself. So this is how dynamic programming works, and this is how the tabular approach is for dynamic programming. So this is our optimized solution for a 0-1 knapsack problem. And what we're going to do is quickly look at the code for it. So here we have our profits, we have our weights, and W is the capacity of our bag, and N is the length of profit, or you can see the number of items, right? So we're passing all this in a function. So we create a table K over here, and we're going to do this in bottom-up manner. So again, we create 2 for loops to fill our table. So whenever we have a row or column equal to 0, we are directly going to fill 0 in our table, right? And this is the condition, or this is the formula that we discussed, and we're simply going to implement it over here. And finally, we're going to return the last cell and print it, right? Let me just run this program for you. And as you can see, 8 is our maximum profit associated with the particular capacity for our knapsack bag. And then we have our last question for the series, which is the asteroid collision problem. So now what the problem statement is here, you are given a series of asteroids which are moving in a straight line. Now, whenever there's going to be a collision, they will either destroy each other or they will continue moving forward. So now your task is to determine the final state of all the asteroids after the collisions. So now, as you can see, you're given a number of asteroids. Over here, you're just given 4 asteroids. And you have some asteroids moving in the right direction and some moving in the left direction. Now, how you're going to approach this problem is, you will go to the first asteroid, you will check its direction. Basically, if it has a positive magnitude, it's going to be moving in the right direction. And if it has a negative magnitude, it's going to be moving in the left direction. Simple enough. So now what you're going to do is, you look at the first asteroid, you see the magnitude, and you know it's moving in the right direction. Then you move to the next asteroid. You check, again it has a positive magnitude, so it is going to be moving in the same direction as the last asteroid, so there will be no collision over here, right? Then you move to the next asteroid, and you see that the previous asteroid and your current asteroid are moving in opposite directions. So now there is going to be some collision over here, right? So what do you do in this case? You check the magnitude of both the asteroids. Now this has a greater magnitude, so this asteroid is going to survive after the collision, whereas this one is going to get destroyed. Correct? So now that you know this asteroid is destroyed, you will not consider this asteroid in the picture, right? You move on to the next asteroid. Now this asteroid and this asteroid needs to be compared. So now this one has a greater magnitude, so this asteroid is going to be destroyed, right? Now we have these 2 asteroids in the picture. So now this one again has a greater magnitude, so this asteroid is again going to be destroyed. So now after all the collisions, the final state is just going to be minus 15. There's just one asteroid that survived and it is moving in the left direction. That is all you have to figure out using a very basic implementation. So let's look at the logic behind it in more detail. So again, this is how you're going to be given the problem statement. You'll be given the description, and then you'll be given some sample examples, and you will also be given some constraints for your variables, right? So let's look at these examples first. So here you have 5, 10 and minus 5, right? So this is moving here, this is moving here, this one is moving in the opposite direction. So these 2 asteroids will collide naturally, and you have this one with a greater magnitude, so this one gets destroyed, and your final state is 5 and 10, right? So this has to be your output over here. Then the next one is 8 and minus 8. So now this one is moving in this direction and this one is moving in the opposite direction, and they have the same magnitude. If you ignore the sign, they have the same magnitude, but since there will be a collision, they both will get destroyed with each other, and you will have no asteroids left. So an empty output. Then finally, you have another example, 10, 2, and -5. Now, our first collision is going to happen over here, and this asteroid is going to destroy this one. And then finally, we're going to have 10 and -5 having a collision, and this one is going to get destroyed. So 10 is our output. Correct? Now, you might have gotten a basic idea about this, and you might have realized that you need some sort of LIFO structure over here to maintain this, right?
Yeah.
All you're going to do is you're going to put the positive asteroids in your stack and then compare the top of the stack with the asteroid that's going to be colliding. Let's look at the example. Let's take 10, 2, and -5, for example. So we have 10. We'll put it in the stack because it's moving in the right direction. Then we have 2. It is again moving in the right direction. So we'll again put it in a stack. Then we have -5. Now we'll compare our -5 with our top of the stack element, which is 2. So now we know this asteroid has a greater magnitude and is going to destroy this particular asteroid. So we pop it out. We're going to pop this asteroid out, and we're going to compare our top of the stack element again with our current asteroid. And now we know this asteroid is going to destroy this one. So we move on to our next asteroid. But again, we do not have any other asteroids, so we just return a stack. Correct? So this is the basic idea. So now let's look at the implementation of this particular program. So we have a function asteroid collision. We pass all our asteroids. So our asteroids is nothing but a list of the asteroids that we have. Right? We pass it in our function. So now what we're going to do is simply create a list to avoid extra operations. And we'll go through each asteroid. We'll run a loop in our list itself. So we're saying ast in asteroids. And we're saying add asteroid equal to true by default. Right? So what we're saying is add the asteroid in the stack is true. Like go ahead and add this particular asteroid in the stack. But now we cannot add all the asteroids in the stack. So we are going to check for the particular conditions. So now we're saying while our stack is not empty, and our asteroid is less than 0, and the top of the stack element is greater than 0. So while these conditions are true, we're going to stay in this loop, and we're going to check if the top of the stack element has a greater magnitude than our current asteroid where there is a collision. So this particular condition is basically checking for a collision, right? And then what we're doing is we're checking if our top of the stack element is greater or our current asteroid is greater, right? Now, if we find that our top of the stack element or our top of the stack asteroid is greater than our asteroid moving in the left direction, the opposite direction, we are not going to add that particular asteroid. So we make this condition, we make this variable as false, and we break out. But if we find that our top of the stack element is equal in magnitude to our asteroid moving in the opposite direction, we're simply going to pop that particular asteroid from our stack. That is, we're going to remove it, and we are again going to add asteroid equal to false, because we do not want that asteroid being added to our stack as well, because they're both being destroyed. And again, we break out of the loop. But again, if both these conditions are not true, that is, if our top of the stack element is not greater, that is, it is having lesser magnitude than the other asteroid, we are simply going to remove that particular asteroid from the stack, and we are going to add the other asteroid in our stack, as you can see over here, right? But this is going to happen only when the collision condition is false. That is, we move out of this condition, we add our stack, and then finally we return our stack. Let's run this program. So over here we have -18 and -19. Let us quickly look at this example, right? So if we consider this example, we have, let's put it in a stack and see so that it becomes more clear, right? So this is a stack. I add 4, then I add 7, then I add 1, then again I add 1, then again I add 2. Now I have minus 3. Right? So now I'm going to compare this with this. So now I know this has a greater magnitude. So I'm going to follow my last condition, which is simply popping this element out. Right? I pop this element out of my stack. Now again, I'm going to check this with this. So again, this is going to be removed or it's going to be popped. Right? Then I check this element with this one. So again, it is going to be popped. Or I can just erase this from my stack. And then I'm going to check this asteroid with this one. So now this one gets destroyed. And I move to the next one. Now this is minus 7, this is positive 7, both get destroyed. Right? So I'm going to pop this element out of my stack. And that one also gets destroyed. So I'm going to move to the next one. And it's positive, so I'm going to add it. Like there's no collision, so I'm going to add it. And my pointer is also going to move up. Then I move to the next one, and again there's no collision, so I add it. And now there's minus 18. So I'm going to compare it with my top of the stack element. So it is going to pop this out. Right? Then I'm going to compare it with this one. So again it has a greater magnitude. I'm going to pop this out. Then I'm going to compare it with this one. Again, it gets popped because minus 18 is greater than 4. So now I do not have anything else to compare my current asteroids with. So I'm simply going to add them in the stack because my add asteroid condition is true over here. Right? So I'm going to add it and then I'm going to return this stack. So this is also what the code is implementing in the program. Right? So I hope this was clear. And I hope you guys got a good understanding of implementing the optimized version of the solutions, not just how you implement the solutions. Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.